Yes, good evening guys to all of you. Please tell me, am I properly audible and visible to all of you or not? Aniket, Nirved, Shreya, Ashray, please tell me, am I properly audible and visible to all of you or not? So guys, today we are starting the machine design. Yes. Please tell me, am I properly audible and visible to all of you or not? Yes. Good evening, guys. So, guys, today we are going to start the machine design complete marathon. If you remember, yesterday we met for theory of machines, and today we are meeting for machine design. Savi, good evening. Janardhan, good evening. Shreya, good evening. Aniket, Harikesh, yes. So, Nirved, Shreya, very good. So, guys, when we are talking about machine design, first of all, yes, the weightage of this subject is going to be somewhere around 4 to 6. Okay, let me take some color. Somewhere around 4 to 6 marks. Okay. But my dear, when we are talking about this subject, the type of questions are almost fixed. Like when we are asking from theory of failure, fatigue loading, there are some fixed type of questions. Because of which I personally feel that it is easy to score in this subject rather than the subjects like other design subject. Tom is there. Okay. Yes, Bora, good evening. Abhishek, good evening. So guys, this is my Telegram channel link, that is Mechanical by Dheeraj Sardana. And guys, in this Telegram channel, you will get the PDF of this session. Like I have given you for theory of machines, you will get for machine design also. Good evening, Ashray. Hari Sandhu, good evening. So you know, from 9th of January, this marathon series is going on. And this is the mathematics plan, as I already told you, maths and aptitude from 22nd to 1st of February. Okay. So you can see differential equation, then aptitude, then calculus, then analytical, then matrices, then special, then numerical, then verbal, then complex numbers, and so on. Okay, this is how the things are going to be here. Abhishek, that also we will plan in next 3 days on some of the day. Okay, so don't worry. So that we will plan, don't worry. Okay. So Vinay, good evening. So guys, if you want one-to-one counseling with our counselors, here in this session, in the below, Google form link is there. Okay, you can fill it and you will get the call from our counselors. Okay. No, Savi, actually I told you ki I will be telling you about the second part tomorrow in the MD. Actually, I don't want it to change the entire schedule. If today we would be meeting from gear train, then machine design would have to be shifted someday. So that's why today we have not changed, because today in the morning aptitude session was there, so we could not have this session. So that is why if we will start at that time, so I was having some doubts. So that is why we are not doing any change today's session. But yes, that gear trains and other parts of top we would be having either on Tuesday or on Wednesday. Okay, so be ready for that. I will inform you on my Telegram channel. Most probably that will be on Tuesday. Okay, so we will do at either on Tuesday or on Wednesday. Out of these 2 days, 1 day it will be there. Okay, Akhila, yes, good evening. Okay, so let us start machine design. So guys, 14th January, today I feel this was the time is about to over for this. 17th January, you have a workshop at 7:30 p.m. 7 golden rule to ace gate 2025 in first attempt will be taken by Rakesh Talreja sir. And guys, this is about the mega mock challenge. If you are preparing for gate 2024, still 2 mega mock tests are remaining. You can appear into these two, and definitely you can see where you lie among all other students. So guys, do like and share the session, then we are starting. So I already told you around 6 marks machine design is coming. Okay. So my dear, we would be having some question solving also today along with the theory concepts. I will be teaching you completely, and I want to tell you first what are the topics I will cover here. If you remember theory of failures, okay, we will be starting with the introduction of design. Then we will enter into the theory of failures. After theory of failure, we will go to fatigue loading, then to brakes. After the brakes, we will go to the bearings. Then we would be going for the joints. Then at the end, we will see the clutches. and also we will see that is gears and springs as well. Okay, so each and every topic we would be covering one by one. Okay, and this subject is not a very big subject, and even the types of questions are also fixed. So whatever I would be telling you here, you need to listen to me properly. In the machine design, whatever I will teach you, the question will be from here only. So just concentrate on the class. These 6-7 hours will make your machine design perfect. Okay, so we are starting here. So guys, first of all, whenever we are talking about engineering design, whenever this design word is coming, it is defined as an iterative process. There is a word used for design that is said to be iterative process. Okay, iterative process. Iterative process. Okay, iterative process or decision making. To convert the resources, to convert the input, to convert all the inputs which are there in the form of man, material and other things like energy, like machine and all, into some useful output. So this is why I am saying this iterative process. My dear, whenever we are talking about iteration, iteration simply means improvement. Like in the numerical method, what we do? We are starting with an arbitrary solution. Let us say this is the correct solution. So in numerical method, we are starting with bisection method, Newton-Raphson, whatever method you use. We are going to start with some of the arbitrary solution. You know, this is not the exact solution. Maybe in the next iteration you would be reaching near to this. In the next iteration you would be reaching near to this. In the next iteration you will be reaching near to this. In the next iteration you will be reaching near to this. You will always going towards the solution, but you will never reach the final solution, and that's why we call it as more the number of iteration, better will be the solution. Likewise, whenever mobile came into the picture, initially when mobiles were not there, initially no, we were having the landline. So initially whenever something is coming into the market, the basic thing behind that is the human need. Okay, so human need is going to be the starting point for any design procedure. Like we wanted to communicate with each other from a far away distance. I am taking an example of mobiles. So for that purpose, that landline mobiles came into picture. Yes, Farinder, good evening. Okay, I feel you are asking something, just wait. So you are asking, sir, maximum how many hours take the class? Farinder, it should be going like last year I completed machine design in 6.5 hours. Okay, so let us see today what it go. But 6 hours you can say we can complete the machine design part. Okay, so no 10 11 12 1 2. Yes, let us see, rest depends on your energy. Okay, so what is the secret of your energy? Let us see. So guys, whenever we are talking about human need, it is the first step. It is the first step for anything. It is the first step for anything. Okay, so when we are saying it is the first step for anything, then my dear, like you wanted to communicate with each other, landline came into picture. So landline came, our need was fulfilled, but we did not stop there. Then we thought it would be great if that landline become a device which we can carry with ourselves. Then this mobile came into picture. But initially the mobiles were coming like Nokia 1110. Nokia, whatever mobiles were coming, they were very small mobiles we can carry with ourselves. But they were useful only for the calling facility. They were not having much features. But at that time it was a very big thing. So when we were having that mobile, everybody was not having. Some people were still going for STD, PCO and all. But there was a time came when everybody was having that mobile. Then we wanted, it would be great if we can listen the song onto that. Then FM was included. Then we thought, when we want to listen the song, why of FM? We want to listen the song of our choice. Music player was added, video player was added, camera was added, internet was added, and slowly, now you know your mobile is like a mini computer. So what are those? Those are iterations. They are said to be improvements or iterations. Like whenever we are reaching till that level, still we are looking at every month, in every 15 days, every mobile company is going to launch a new model with new functions or some better functions. What is that? That is a kind of iteration. And you know this iteration process should carry on, because if it will end, my dear, that company will end. Because if that company says this is our final model, we cannot make the mobile better than this is our best. So after that, once everybody will have this, now there would be no person who won't that mobile, because everybody have that and that company will shut down. So that is why it is required always that improvement should happen. Okay, Shreya, actually there are many students who do not understand Hindi here. So that is why I cannot go with English. Otherwise I would love to. But here there are many students who do not understand Hindi. So for them it would be a waste of time in that case. Okay. But I feel English everyone can understand. That's why we are going with English. Okay. Yes, yes, yes. Fine. Great. So my dear, I already told you that whenever we are talking about design, design is an iteration process. Means every time improvement will be happening in the design. Now whenever we are talking about the design, what is the ultimate target of design? So my dear, the ultimate target of design is to get the shape, the size, the manufacturing process and material. Generally people thought that design means only dimension. But my dear, when we are talking about design, actually we are looking for these four things. One is the shape, other is the size, third one is the manufacturing process, and fourth one is the material. These are the four things which comes under the entire design. And in the interviews of IIT, whenever you are looking for design branch for MTech, the very first question they are asking what is CMP with reference to design. So you would be saying C refers to configuration, M refers to material, P refers to manufacturing process. And here configuration means what? Size and shape. So my dear, these are the things related to design. So whenever we are going for a design procedure, these four things should be our final output. And our target is to make a design or drawing where all these four things are mentioned. Okay, so my dear, I would like to show you this procedure for the very simple element shaft, and after that only we will be starting the topic from theory of failure. So my dear, you can see engineering design is an iterative process or to convert resources optimally to satisfy the human needs. And I already told you here our target is to calculate appropriate dimension and the selection of manufacturing process, and also we need to go for the desired shape and appropriate material. These are the four things which are coming in design. So all the things are written in this PDF. Okay, I will also share the handwritten notes already available on my Telegram channel. You can follow those notes also. You can follow this PDF also, because these PDFs are made by those notes only. Choice will be totally yours. Okay, so now my dear, we are moving further. So here I am showing you a small procedure for design of shaft, which will give you the entire picture of design. Okay, so my dear, first of all, when we are going for the design, our first thing what we are looking for is okay, just wait. The first thing what we are looking for is specify the need or objective. So whenever you are going for something, first of all we have some target. So let us say I am showing you the design of shaft first of all. So I would like to say that we wanted to transmit a power of 2 kilowatts at some 1000 RPM. So this was the objective for which we wanted to design something. And when we have seen the objective, we get to know this thing is going to be rotating thing. And rotating things would be generally circular, it would be better, because rotating things, you know that shafts, whenever we are talking about, they are generally having bearings for the support, and bearings also have the circular cross section. So just whenever we have seen this, we get to know one idea, that if we want to transmit a power of 2 kilowatt at 1000 RPM, we found out power is equals to 2 pi nt by 60. From here we get to know that the loading is torque. The loading is a kind of twisting moment. Is it clear? So when we get to know the loading is twisting moment, now you can see the first is specify the function. Second is define the various types of load which is acting. Now we get to know if torque is acting, thing is rotating. So the best cross section would be the shape that should be either solid circular or it should be hollow circular. Okay, these are the preferred shape for this type of loading. Now my dear, we are going for the fourth. We have already selected the shape. Now it's time to select the material. When we are talking about the material selection will be depending on various factors. One is the mechanical properties, means what kind of properties you are looking for. Are you looking for ductile? Are you looking for brittle? In that way you will be deciding based on the properties. At the same time, you would be having another criteria as availability. What do you mean by availability? So my dear, availability means whether that material is available near to you or you need to go far away from there. So in that case, if availability is not there, whatever the material is, we cannot afford it. That's why availability is one of the important factor. So likewise, we will see property, availability, cost, है ना? By looking at all these, we would be deciding some material. Like let us say when we are talking about the mild steel and cast iron, we will go for cast iron if we need brittle. We will go for mild steel if we need ductile. So likewise, we are going for the selection of material for the shaft. And once the selection is going to happen, then my dear, the next step is, once the selection of material is going to happen, the next step is, we are going to find out the mode of failure. This is a very important step, and from here only the things are going to be started for us. Mode of failure means material will be getting failed by which type of stresses. So we already know that ductile materials are poor in shear and brittle materials are poor in tension. So my dear, if you are going for making a shaft of ductile material, then you would be designing with reference to shear. If you are going to have a brittle material, we will be going with respect to tension. So based on that, you would be looking at this. Let us say our material is ductile. So you would be having tau induced because of the torque is 16 T by pi d cube. Now don't ask from where this formula came, because that is coming from strength of material. Machine design is the application of strength of material. So here I would be using the concept we have already discussed in the strength of material, specifically the principal stress and strain chapter. Okay. So my dear, when we have this step, what is the next step? The next step, my dear, is going to be the safe design. Okay, now we are going for design. So we would be having this safe design as tau induced maximum should be less than equals to tau permissible. Now this permissible will be coming from the test, like we have tension test, okay, like we have torsion test. So there are 4 types of tests happen: tension test, compression test, shear test, torsion test. So from these tests we are getting the permissible value. And my dear, once we are going to get the safe design, actually safe design means here we are going to get the dimension or size. Okay, shape selection happened here, material selection happened here. Now here size is getting, now we are left with only one thing, that is selection of manufacturing process. Here we would be going for selection of manufacturing process. Once that process is getting selected, at the end we will make a drawing, and in the drawing all 4 things would be mentioned. So this is the complete design procedure of a shaft, and I feel that you got the feel of design from this. That design does not mean only to find out the dimensions, but design have 4 things. One is size, other is shape, third is manufacturing process, fourth is material. But you may be thinking, sir, we have given many times the exam of machine design, but nobody asked us that which material shaft you should go for. Nobody asked us that which manufacturing process you should go for. So guys, I would like to say the syllabus of yours is designed in such a way that you only need to work with the dimensions, and we are lucky that GATE is also restricting themselves to that only. So no doubt the real design indicates material, manufacturing process, shape and size. But in our syllabus, things are in such a way that we need to worry only about the size. So that is why out of this 8-step procedure, our major concentration would be from here only. The mode of failure, okay, and then this. So we just need to go for step number 5 and step number 6. All other things are not required for us, because all other things would be given in the question or they will never be asking about them. So in our syllabus of machine design, we are supposed to do only step number 5, and step number 6. Is it clear for everyone? Please tell me that. Now if any of you have not studied strength of material, is there anybody or everybody know about the forces, about the loads and all? Everybody know about the forces and couples? I need not to go for the forces and couples, or anybody wants? Everybody is okay with that? Shall we directly go for the theories of failure? Can I assume that we have studied the strength of material? Because this is not the classroom course going on. I would be every time starting from basic. Okay. This time I have to assume that you already are okay with strength of material. But don't worry, I will tell you wherever it would be requiring. Pleasant music, I would like to say rest are required in ESC mains paper, not in objective paper. So in mains paper, they are required. Okay. Yes. Very good, Janardhan. So now my dear, we are going for, these are the types of load which we generally talk about in the strength of material and engineering mechanics. Bending couple, twisting couple. So these things I am assuming that you are aware of already. Okay. But if anybody have any doubt, no problem. Whenever the need of these things will be coming, I will be telling you. Okay. So don't worry. So now my dear, we are coming with the very first thing here. That is the mode of failure. Okay. That is the mode of failure. Because we have already seen that there is something called as mode of failure. So mode of failure is going to be a small or quick revision of all the types of stresses you have studied in strength of material. So within 5-7 minutes I will tell you all the way a material can fail, and then we will start the theory of failures. And my dear, theory of failure will be the first chapter for machine design as per your syllabus, and I am telling you majority of the time theory of failure always been asked in the paper. In 2023 paper also question was there from theory of failure. It is a pet chapter for mechanical engineering. Now my dear, when we are talking about the mode of failure, the very first failure which can happen is by the direct tensile and compressive stresses. When we are talking about direct tensile and compressive stresses, whenever we use the word direct word is used for the stresses coming because of forces, and indirect word is used because of the stresses coming because of the couple. So when we are talking about direct tensile and compressive forces in the strength of material, you have studied that if a body is subjected to a tensile force like this, or if a body is going to be subjected with a compressive force like this, so you have made there the stress distributions, and if you know that the stress distribution you have made was like this, okay, here it was like this, and here you were making like this. So even if you forget, so that 5-7 minute revision I am giving you, which is very useful. So here the stresses are tensile, you would be writing P by A. Here the stresses are compressive, you will be writing P by A, but here minus P by A. And if you want to write the state of stress at any point, then this point can be shown by a box, and we can show it like this. I feel everybody know this type of loading I have given the name of uniaxial loading. Okay, this type of loading we are calling it as uniaxial loading. Everybody knows that. Then my dear, second we are talking about is indirect normal stresses. Normal means tensor and compression only. So indirect means it is coming because of either moment or couple. Okay, so guys, do like and share the session. Whenever we are talking about that, we are having a beam like this, and that beam is subjected to a bending moment of M. In machine design, we are not worried about beams, so I will be calling shaft, because beam is the application of civil engineering. Our shaft would be subjected to bending moment also, twisting moment also. So we would be talking in terms of shaft. Okay, so if this is the shaft and we are going to write the state of stress, so you know here it is going outside, here it is coming inside. So state of stress will be showing like this, stress distribution will be coming like this, and I feel everybody know that here the formula we are using, if this is a circular cross section, then you know that sigma b is coming out to be 32 m by pi d cube. And if you don't know that, I am going to make you remember that the same equation is used, m upon I, sigma b upon y, and E upon R. Here majorly we would be using this, and from here the bending stress maximum will be coming like this. So whatever I have written, this 32 m by pi d cube, this is the stress at outer fiber. Okay, so if my dear you are calling this value, this is 32 m by pi d cube, this is 0, this is minus 32 m by pi d cube. So this is said to be indirect normal stresses. Okay, now my dear we are going for the third type of stress. Everybody is getting or not? Please tell me, and do like and share the session, guys. Other student can also reach here. I am going from very basic. You can see this is my habit, so that even a new student who is going to study all these things for the first time, then also he can understand. This is the indirect shear stresses. Indirect shear stresses. Indirect shear stresses are also known as torsional shear. It is also known as torsional shear. Okay, so my dear, whenever we are writing here as they are shear stresses, we are showing the distribution on the cross section of the shaft. So my dear, the shear stress, if the torque is coming like this, then shear stresses would be made like this. Like this. This is the distribution. Okay, this is coming from the T by J, tau max by R, G theta by L. And when you are going to use this equation, you can write the tau max value as 16 T by pi d cube. Because this equation is valid only for circular section, so we would be going only for the circular section. Is it clear for everyone? Please tell me that. This is about the pure torsion. Okay. Now my dear, we are coming to the next type. You may be thinking shear stresses in beams. So here we are not going to study the beams, so shear stresses in beams are not required. Now my dear, I am talking to you about the next type of stresses, that is nothing but bearing and crushing stresses, which you have not studied in SOM. Bearing and crushing stresses. Bearing and crushing stresses, which are new type of stresses which you have not studied in the strength of material. What is bearing and crushing stresses? So my dear, you know bearing is a device which is going to support the shaft. Let us say this is the shaft, and my dear, on this shaft many components like gear, rotors are present, and let us say this is the bearing. Let us say this is the bearing. This is the bearing. Okay, and my dear, when we are talking about this bearing, in between that we are having some lubricant. Okay, and I feel everybody can understood what I want to say here. The cross-sectional view, if you want to see, this is going to be the shaft. Okay, this is going to be the shaft, and if you see, this is going to be the bearing. Bearing is generally fixed. Inside we are going to have the lubricants. Inside we are going to have the lubricant. Yes, it's fine for everyone. But my dear, I would like to tell you there would be a condition sometime when bearings and shaft, they are in contact. If this is the bearing and this is the shaft, because bearing is bigger than the shaft, then my dear, you know, whatever the components which are present on the shaft, the weight of theirs would be going in downward direction like this. So if I show that weight is W, let us say, then my dear, because of that, whatever the surface is coming in contact, here the distribution of pressure is found, and it is found to be like this. The pressure distribution is coming to be like this. It is not constant, it is variable like that. That kind of pressure distribution is coming. And my dear, whenever you want to feel it, you can also feel it. Take a bottle full of water. If you will be falling it onto this your hand, you will find this center point will be having the maximum force, maximum pressure or maximum pain. The same I have shown here like this. Okay. So my dear, to take the average effect of this pressure, what we are doing is we are writing this bearing pressure as equals to load but a projected area. Now my dear, when we are talking about the projected area, this is how we are going to define the bearing pressure. And my dear, load but a projected area. If you want to see the projected area, we will see the projected area of this part of the shaft. This part of the shaft which is inside the bearing, we call it as journal. Complete shaft is not journal. Journal is the part of shaft which is inside the bearing. Okay. So if you see that, I would like to tell you the projected area of the shaft, of this shaft, of cylinder is nothing but the rectangle. So if this is the length of journal and D is the diameter of journal. So L into D is the projected area. So this is how we can write the bearing pressure, W upon LD. Now my dear, same thing will be there when we are going to have two plates like this. In these two plates we are going to make a hole of 11 mm, and in this 11 mm hole we are going to put a rivet of 10 mm. Now my dear, as we are having rivet size smaller than the hole size, rivet size smaller than the hole size. So my dear, here also when you will be applying the forces like that, like this, the contact of the hole will be bigger, shaft will be smaller. When it will be coming like this, here also the contact will be maintained only to the some part, like here it is happening. So that is why the stress distribution will also be like that only. So that is why here we are defining it as crushing stress as the same way. If P is the force, P divided by projected area. Here projected area will be, you can see this is the rivet like that. So this is the rivet like that. So once again cylinder, you would be having this time dr is the diameter of rivet and T is the thickness of plate. So projected area is dr into T. You may be thinking, sir, when they are both same, why here we are giving the name of bearing pressure and here we are giving the crushing stress? Why not the same name? So my dear, there is a difference. Shaft is always a rotating element, whereas this rivet is not rotating. So to distinguish that relative motion part, here we call it as bearing pressure and here we call it as crushing stress. But both are given by the same formula. Very good, Vinay. So please tell me guys, everybody understood or not till this point? कुछ कहते रहो comment में ताकि मुझे पता लगे कि आप हो. Is it clear or not? Please tell me that. So guys, आग लगा देंगे, आज मशीन डिजाइन पूरी हो जाएगी, ठीक है? जैसे हमने सोम पूरा किया, हमने कास्टिंग वेल्डिंग मेटल शीट मेटल ऑपरेशंस पूरा किया है ना, टोम पूरा नहीं हो पाया वो भी करेंगे. तो आप सभी लोग, एवरीबडी वांट्स टोम टू कंप्लीट ना, shall I do na? It should not, everybody want here na, whoever is present, everybody want the second part of tom. Yes, so we would be planning it on Wednesday most probably. Okay, most probably Wednesday we will be planning. Very good guys. Jyoti, Manjari, Danesh, Shailesh, बहुत बढ़िया. So let us move further. Akhila, very good. So now my dear, we have seen all the types of stresses and I would like to tell you one more thing before going further. Just look at it. Now my dear, we would be starting the next chapter, that is theories of failure. But before we go for the theories of failure, we need to understand some basic terms. Out of that, okay, let me see if there is mentioned that term. We can go here also. Yes. So before we start the theory of failure, we are going to see something known as factor of safety. Because without this, machine design cannot be started. This is something which is required to start the machine design. So my dear, whenever we are talking about factor of safety, first of all we need to understand what is factor of safety. So my dear, let us say you have a wallet and in this wallet you have 12,000 rupees. Now my dear, out of these 12,000 rupees, you know that this month you have your girlfriend's birthday. And you know, on your girlfriend's birthday you need to give or you need to throw a party, and for that you need some amount to be saved, otherwise the relation can be in problem. So that is why you are doing one thing, you are dividing this 12,000 into two parts. You are saying I will keep 3,000 save for that party and rest 9,000 rupees I would be utilizing for my monthly spendings. So my dear, you know that if these 3,000 will be in front of you all the time, you may spend it. So you wanted to save it somewhere else. So what you have done, you have kept these 3,000 into your chore pocket, like this is my wallet. You can see that these are the main wallets, where if I will show, everybody can see. So here there are some pockets which I call as chore pocket. With whatever I will be putting here, maybe I never check this pocket, I never go inside this, है ना? So my dear, these are the chore pockets. So I will keep 3,000 here. for the situation like if I don't have money or for that birthday saving I am doing. Okay, so my dear, these 3,000 I am going to save for that particular purpose. So my dear, actually I am having 12,000 rupees, but I am pretending that I am having only 9,000 rupees. So I am allowing myself to spend this much only, but in actual I can spend this much. So my dear, factor of safety is defined as the actual money after which you will become nil, that is 12,000, and the money you pretend you have, that is 9,000, you are allowing yourself. So that ratio is said to be the factor of safety. So in reality, material is getting fail at the failure stress, and that is nothing but yield strength for ductile material, ultimate strength for brittle material. But I am thinking that material will be, I am assuming some stress permissible, sigma permissible or sigma allowable. This is the stress up to which I am allowing myself to go. I am not allowing myself to go beyond this. Then factor of safety is sigma failure by sigma allowable. Sigma failure by sigma permissible. That is the factor of safety. So sigma allowable is sigma failure by n. Is it clear or not? So we can get sigma allowable or sigma permissible is nothing but sigma failure divided by factor of safety. And my dear, this is how we are defining the factor of safety. Now my dear, you may be having a doubt, sir, but why this factor of safety is required actually? So my dear, in strength of material, whatever equations you have derived, bending equation, torsional equation, all those equations have some assumptions. So if you have assuming something which may not be true in practical, for that reason, that is the first reason of considering factor of safety, unrealistic assumptions of strength of material. Second thing, we know that in India we are having a big population. So because of big population, there is one problem. Because of big population, there is one problem, that we are having limited resources but unlimited persons. So that is why what happens, like when the festivals are coming, a bus having capacity of 50 is going to take 200 people at one time. A train which is having some limited of 1,000 person is going to take 5,000 person with that. A lift which is having a capacity of 10 people, maybe of 67 kg each, but they are going to have 15 people of more than 80 kgs. Why these things? Because it is not like because we are illiterate. No, it is because we have less resources and more population. So because of that reason, this is not high demand, Savi. This is said to be not high demand, okay. We will be calling it as less resources and more population, okay. So when we are going for all, yes, high demand is there, but this is not like that. On the Pavli, yes, you can say we are having high demand, but in the lift case, the problem is peoples are more, resources are less. All whenever we are having resources are less, peoples are more, we need to give that liberty to the peoples to break some small rules. And my dear, for that what we are doing? We know that for that we need to do something by improving the capacity. Actually, it would be having a capacity of 20 people, we would be writing it 10, so that even if 15 go, it will not fail. So my dear, as we are having more people, less resources, for that purpose we know peoples would be breaking the rules. So for that reason also we should have more factor of safety. Okay, that's why factor of safety is required. So I have told you the factor of safety is required for what persons? So unrealistic assumption, unknown loading condition which I just told you, and some typical environmental condition, and the fourth one is stress concentration, which is generally coming for some specific shapes. So that we right now don't know. We will be studying this in the next chapter. So for that timing, neglect this. Okay, yes, we will have this discussion in the next chapter. Is it clear for everyone? Everybody understood factor of safety? So you can say whenever you are using the factor of safety, sigma failure minus sigma permissible, this is said to be the reserve strength. This is said to be the reserve strength. So my dear, this reserve strength is basically nothing but the extra stress which we are going to provide to the component for the bad times. Like you are providing 3,000 rupees for the girlfriend when you are going to throw the party. So my dear, this is the case of theory, the factor of safety. Now my dear, this factor of safety will always be used. So wherever you will see sigma permissible, it simply means sigma failure but a factor of safety. Okay, and I would like to tell you factor of safety is always more than or equals to 1 for the safe design, and factor of safety is always less than 1 in the failed design. So my dear, in the machine design we are going for safe design. In the production, when we are going for metal forming and sheet metal operation, there we are going for failed design. And right now today we are studying machine design, so we would be going with factor of safety more than 1. Is it clear? So my dear, now we are going to once again have the starting of the chapter, that is theory of failure. So if you want to go for the theory of failure, what is the point? So if I ask you why we study theory of failure, because I see some of my classroom students are also there in this session, so I want to know what you will say why theory of failures are required. What is your point in that? Why we need theory of failure? Let us see how many of you will be giving the right answer. Why we need theory of failure? Why we need theory of failure? Anybody? I will go in the marathon style, okay? The same machine design in the paid course I taught you for 39 hours to 42 hours, depending on different batches. The same we are going to complete in 6 hours, so we will go in the marathon way only. No standard test, very good Mathur, Divit. Combined loading, very good. No standard test, wonderful guys. This is what I was expecting. Fine. So guys, now I am going to that point. My dear, whenever we are going for the uniaxial loading, like you have seen, whenever we are having loading of this type, okay, then my dear, let us say the stress induced is either P by A, or you will be having M upon ZNA, because both bending and bending and simple stress and strain, whenever you have bars, both the case are depending on the uniaxial loading. So let us say we have uniaxial loading. So in that the stress coming is P by A or M by Z, whatever. So my dear, what we are going to do? Let us say a person come to you and he say, I want to have mild steel shaft. I want 500 shaft which can bear 50 kilonewton of load. Then my dear, if someone is coming like that, what you will do? You will say, okay, load is 50 kilonewton. Okay, load is 50 kilonewton. Now my dear, stress is defined as P by A, and you want to design this component. So what you want? You want this should be less than equals to sigma permissible. Sigma permissible is SYT, because material is ductile, SYT by N. Now you may be thinking ki factor of safety, let us say we are deciding it should be 2. Factor of safety is always decided by us. Then what should be SYT? For that, we will be going for the tension test. And when you will be going for the tension test will give you the yield strength of the material. You will put that value. For the same material, you will go for the tension test. You will put that value, and with that you will be getting the area should be more than equals to this. So this is how we are going to define it. Okay. And when we are using the stress, when we are saying sigma induced is less than equals to sigma permissible, this is said to be the strength criteria of design. And whenever we are writing the deformation induced should be less than equals to deformation permissible, it is said to be rigidity criteria. But in our syllabus only strength criteria is there. So we will be going with this only. But in practical life we need to go for both the criteria. So here we will be going only for the strength criteria. So my dear, whenever we are talking about this case, very easily we are capable of designing. And for this case, we never require any theory of failure. But the point is, if we are going to have a loading, which we call as combined loading, when normal and shear both are coming together, you may be saying, sir, what is the problem in that? In strength of material, you have already told us, for such case, you can find out the principal stress is sigma 1, sigma 2. you can find out maximum shear stress tau max. So whatever be, if the material is ductile, consider shear failure, material is brittle, consider tensile failure. So we already know the maximum value of stresses. So you may be saying, sir, keep it sigma 1 or sigma 2, whatever is maximum should be less than equal to sigma permissible. Or you can write tau max should be less than equals to tau permissible. But my dear, my question will be, if I am doing this, yes, I can do that. But how I will get sigma permissible or tau permissible? You will be saying, sir, sigma permissible is nothing but sigma failure by n. You just said sigma failure would be either SYT or SUT. So just go for the tension test and find out SYT or SUT, put it here. I will say, dear, that is the catch. That is the trap. Actually, when I was doing here the same thing. Here this loading was uniaxial loading. Tension test is also uniaxial loading. So it is like whenever you are going to do rehearsal or preparation, you are preparing for gate कि these 12 subjects will be coming in my paper. You are prepared for those 12 subjects. But when really you went for the paper, in the paper all 48 subjects of engineering were asked in there. So you are not prepared with those subjects. If those will be coming in the paper, will you be able to perform the same what you have performed in those 12 subjects in the test series? No, never. So my dear, here if in the test loading was tension, uniaxial tensile, and in reality also uniaxial tensile, then we can use it, there is no problem. But here test is uniaxial and actual condition is this is combined loading. How we can compare it? It is like here you are having fight with one person, here also with one person. So performance can be equated. Here we are having fight with 4 person, here with 1 person. How the performance can be equated? So the point is, yes, whenever we have combined loading, there is no standard test available. Like tension test, we cannot perform combined loading test. There is nothing like combined loading test. Why? Because when you are going to perform the combined loading test, for that you will be having 3 variables, sigma xx, sigma yy, tau xy. Because you know tau xy, tau yx are equal. So if you would be having 3 variables, you would be keeping 2 variable constant, and you would see when the failure will happen with respect to 1 variable. Then here, let us say you keep sigma yy 1, tau xy 1, here you would be getting 100. You keep here 2, here 1, you will get 95. Likewise, even if you will go and perform a lax number of tests, still I would like to say you will not be able to cover all the values. Because when you are taking here 1 and 1, here 2 and 2, here 3 and 3, there are infinite such combinations possible. Because why here 1 and 1? Here 1 and here 2 can also happen. Here 2 and here 1 can also happen. Here 3 and here 1 can also happen. Here 1 and here 3 can also happen. So likewise, infinite combinations are possible. That's why for combined loading, standard test is not available. So for this, we stuck. So you may be thinking, sir, why we want to have combined loading? We will go for tensile loading. What is the problem with that? So the idea is, in this universe, whatever application you see, like whenever you will see your home, in your home also the beams are under combined loading. In the highways, they are also under combined loading. So everybody in this universe, 99.99% are in combined loading only. So if you want to make anything, you need to go for combined loading design. So for that, standard test was not possible. So we stuck somewhere in between. Then at that time, some researcher came. They have performed lakhs of experiment. And after those experiments, they have given some hypothetical statements. In that hypothetical statement, they tried to relate the performance of the component under combined loading with the material under tension test. And they try to relate both of them. They were not same, but they try to relate both of them. And when they try for some materials, for some loading conditions, they were found to be valid. And based on those conditions and those materials, those wonderful persons or researchers have given some wonderful statements. And those statements were given the name of theory of failure. and my dear, those statements by chance are found to be valid for some material under some loading condition and we are still using them. उनके लिए मैं एक चीज बोलता हूं, ये कुछ अंधेरे में चलाए गए तीर थे जो गलती से सही निशाने पर जा लगे. So that's why we are going for these wonderful statements, hypothetical statements. They are said to be theory of failure. They are relating combined loading with tension test, which are totally different. Combined loading is you are having fight with 4 person, tension test is you are having fight with 1 person. Both the ways, when you are having fight with 4 person and you are having fight with 1 person, you can only give the same performance if you are Rajinikanth, or you can give the same performance if it is South Indian movie going on, okay, or you can give the same performance if those 4 are not very good fighters and this one and these 4 are equivalent to each other. So like I said, in some conditions of loading or some particular type of material, you can equate them, and the same we are going to use while designing. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Okay, Harikesh, no issues. Is it clear for everyone? Shall we move on, guys? Everybody? Okay, guys. So now, my dear, we are starting the theories of failure. And my dear, whenever we are starting the theory of failure, the very first statement, now here derivation I will not be doing, okay? I already told you about strength and rigidity criteria. In real life we use both, okay? In real life we use both. So my dear, now the very first theory is coming out to be maximum principal stress theory. In short form we call it as MPST, and we also call it as maximum normal stress theory. And this was the theory which was given by Sir Rankine. This was the theory which was given by Sir Rankine. So that is why we are also calling it as Rankine theory of failure. And my dear, whenever we are talking about the Rankine theory of failure, what he said actually, Rankine was a strong lover of brittle materials. So whatever the test he have done, he found that tensile stresses are more dangerous than any other type of stresses. So what he said actually, he said if the maximum value of normal stress, actually he said materials are getting failed due to normal stresses. So he said if the maximum value of normal stress coming because of combined loading is going to exceed from the maximum value of normal stress because of tension test, then no one can save your material to fail. But if your maximum value of combined loading, you are going to keep it to be less than equals to sigma maximum of tension test, then my dear, your material is going to be on the safer side. You know that in the combined loading, sigma maximum can be sigma 1 or sigma 2. Here some students have doubt. Sir, why you are saying sigma 1 or sigma 2? Always sigma 1 is bigger, you said. I said sigma 1 is mathematically bigger than sigma 2. But magnitude wise, sigma 2 can also be bigger. Like if one value is minus 10, other value is minus 40, then this is sigma 1, this is sigma 2. Here sigma 2 is bigger in magnitude. So failure will happen by sigma 2 only. Mathematically sigma 1 is bigger. Yes. So my dear, when we are going for design, we are interested in magnitude, not in the, we are interested in magnitude, we are interested in magnitude, we are not interested in the mathematically bigger value. Okay. So that is why we would be saying it can be sigma 1, it can be sigma 2, any of them. And we would be calling it as less than equals to what is sigma maximum of tension test. You will write it as sigma failure divided by factor of safety. And sigma failure will be SYT for ductile material or SUT for brittle material. So the statement will be coming sigma 1 or sigma 2 less than equals to SYT or SUT divided by N. This is the wonderful statement for MPST. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. So my dear, when we see this theory was found to be valid for every loading condition for brittle material. For brittle material, this theory was always valid. For brittle material, this theory was always valid, but for ductile material, it was valid only if principal stresses are of same nature. Same nature means either both tensile or both compressive. Okay. So, but for brittle material, always we will be going for MPST. Now, my dear, we are going for the graphical representation also. So, when we are going for the graphical representation of this theory, you have said sigma 1 or sigma 2 is less than equals to now SYT or SUT by N. So, my dear, this is your choice. Whenever this theory was given, it was given for any material. But later on we found it is found to be valid for brittle material. But my dear, I am considering generally कि every time I will not be writing SYT or SUT. So I will always be writing only SYT. So whenever I will write SYT in this chapter, it simply means I want to write SYT or SUT. You consider it in your brain. I will not be writing all the time YT, UT, YT, UT, YT, UT. I will write only YT, but it means YT or UT both. Okay. So my dear, when we are going for that, sir, in this region questions came in ISRO. That's great. It came in GATE this year as well. For yes, it came. Yes, you are correct, Aniket. And that was a very easy question, I feel so. So when we are talking about on x-axis, we have taken sigma 1. Okay, the diagram is already plotted, so I am removing it. So how we will be moving ahead? So if sigma 1 is reaches to the target, material will fail. If sigma 2 reaches to the target, material will fail. So we can write if sigma 1 is going to be equals to SYT, material will fail. And if sigma 2 is going to be SYT, material will fail. In tension or compression, because we have an assumption that material behavior in tension and compression is going to be same. So my dear, we got by these 4 lines. You know, sigma 1 is equals to plus SYT is just like x is equals to plus constant. Then my dear, sigma 2 is equals to plus SYT is just like y is equals to plus constant, because SYT is a constant which is a property of the material. And my dear, whenever we are talking about this sigma 1 is SYT, sigma 2 is SYT, when you will be taking minus, then it would become x is equals to minus constant and y is equals to minus constant. So we got 4 straight line. X is equals to constant, y is equals to constant, x is equals to minus constant, y is equals to minus constant. Now my dear, whenever you have inequality less than means the towards the origin region. So when you will go towards origin from this line, 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 then this entire region will be coming as the feasible region. And as per the Rankine, this entire region was safe region. And if this is the safe region, if your loading is going to be inside this, your component will not fail. And if that is the case, my dear, I would like to say that this region can be shown in a boundary, and that boundary we are calling it as failure envelope, because this is separating the safe region from the fail region. Clear for everyone? It is separating the safe region from the fail region. Is it clear for everyone? Please tell me. Is it clear for everyone? Please tell me. Clear for everyone? Please tell me. Clear for everyone? Please tell me. So guys, do like and share the session so that other student can also join. We have just started it. Okay. Is it clear for everyone? Yes. Is it clear for everyone? Yes, very good guys. So moving further, this is the first theory I already told you. Now some of you may be thinking, sir, what is the meaning of factor of safety? So while plotting this failure theory, we have considered factor of safety to be 1. That's why we have considered this entire as SYT. If you would be considering factor of safety to be 2, then what will happen? My dear, in that case, SYT will become SYT by 2. So whatever the lines which are coming here, that SYT by 2 will be coming here, SYT by 2 will be coming here, SYT by 2 will be coming here, SYT by 2 will be coming here. So in that case your safe region would be getting reduced. So if you are going to take the factor of safety, you are going to restrict your loading within this region. Okay, that is the meaning of factor of safety. Okay, is it clear? So when we are taking factor of safety to be 2, you are saying that after this failure is there. Yes or no? So like when you were child, if your parents wants you to not go to some place, they were putting some fear into mind that if you will go there, that will happen, someone will take you. Yes or no? So those things happen, na? So the same way. So we are going to say loading should not go about more than this. So even if that loading is going to be slightly here and there, material will still not fail. So that is the purpose of factor of safety. Is it clear for everyone? So this was basically the first theory. Now we are going to the second theory. Second theory is nothing but maximum shear stress theory, my dear. And it was given by Guest and Tresca. It was given by Guest and Tresca. Okay, so my dear, sometime we are also calling it as Tresca theory. Sometime we are also calling it as Tresca theory. Sometime we are also calling it as Tresca theory. Okay, so when we are saying it as Tresca theory, my dear, I would like to tell you here one more thing. Ki this theory is saying that failure is happening because of shear. So they said if maximum value of shear stress due to combined loading is going to be more than the maximum value of shear stress because of the tension test, then material is going to fail. Nobody can save it from failure. But if the maximum value of shear stress because of combined loading is going to be less than equals to the maximum value of shear stress because of tension test, material is going to be safe. Now my dear, when we are going to talk about that in the strength of material, I told you that whenever we are talking about the design, we are not going for in plane maximum shear, we are going for absolute maximum shear. So here this is the absolute tau max actually. So if this is the absolute tau max of combined loading, it should be less than equals to absolute tau max of tension test. Okay, so combined loading is having absolute tau max what? It will be either sigma 1 minus sigma 2 by 2 or sigma 2 minus sigma 3 by 2 or sigma 1 minus sigma 3 by 2. Any of these three can be maximum. The same when you will be going for the tension test. Yes, you can write it as sigma 1 minus sigma 2 by 2 or sigma 2 minus sigma 3 by 2 or sigma 1 minus sigma 3 by 2. Now there is one change. This is of tension test. This is of combined loading. So for tension test, we can write sigma 1 as SYT by N, sigma 2 as 0, sigma 3 as 0, as I am considering the factor of safety. So my dear, this entire, what it would be having, sigma 2 is 0, sigma 2, sigma 3 0, sigma 3 0. So sigma 1 by 2 is going to be the maximum. So it would become SYT by 2N. You everybody know when I am writing SYT, it means SYT or SUT. So my dear, finally the expressions I get is sigma 1 minus sigma 2 by 2 or sigma 2 minus sigma 3 by 2 or sigma 1 minus sigma 3 by 2 less than equals to SYT by 2N. From here 2, 2, 2, 2 will be getting cancelled out. Now this is the statement of MSST if we are having the loading in 3 dimension. But if your loading is 2 dimension, you can say sigma 3 is 0 for 2D loading. And you already know in our syllabus only 2D loading is there. So when sigma 3 is 0, you can write it as sigma 1 minus sigma 2 or sigma 2 or sigma 1. That is less than equals to SYT by N. Is it clear? So this is the statement of MSST. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. This is the statement of MSST for 2D. This is the statement for MSST for 2D. Clear for everyone? Yes, clear for everyone. Now my dear, there are 3 terms. This, this and this. But if your memory is not weak, we have just seen sigma 1 or sigma 2 less than equals to SYT by N, this is nothing but MPST. This is nothing but MPST. So this part is something which is different in MSST. Okay, so now we need to see where we would be using this part, where we would be using this part. Okay, so for that there are two cases. One case is like principal stresses. If you see here, definitions also mentioned. Okay, whatever I am saying, everything is written here. Okay, so when we are talking about like principal stresses, means if both the stresses are either positive or negative. Let us say you have sigma 1 as 100, sigma 2 as 50. Then you know that sigma 1 is 100, then if I will ask you sigma 1 or sigma 2 or sigma 1 minus sigma 2. Out of these three, which one will be bigger? Out of these three, which one will be bigger for this case? Which one will be bigger here? Sigma 1, sigma 2 or sigma 1 minus 2? Which one will be bigger? You need to take maximum of these three. You need to take maximum of these three. Sigma 1 will be bigger. So here you would be saying the maximum is sigma 1. Okay, if I have sigma 1 as minus 10, sigma 2 as minus 20, then which one is bigger? Then which one is bigger? Here both are positive, here both are negative. Now which one is bigger? For design purpose you need to see only magnitudes. Now which one is bigger? Sigma 2. So you would be saying here sigma 1 or sigma 2. Okay, you will be having sigma 1 or sigma 2, and that is going to be nothing but less than equals to SYT by N. So what you understood, if principal stresses are of same nature, then Tresca says whatever Rankine said, I agreed with that. So for this case I would like to say Tresca agrees with Rankine. But for this, credit will be given to Rankine, because Rankine have given this statement 5 years before Tresca. Okay, so that is why for this credit will be there with the Rankine only. Then Tresca said there can be unlike principal stresses. Like if sigma 1 is 100, sigma 2 is minus 50. If now someone will ask you which one is bigger, simply you will say this is a clear winner, and you will say sigma 1 minus sigma 2 should be less than equals to SYT by N. This would be the statement of Tresca for unlike principal stresses. So the conclusion is we have two things, sigma 1 or sigma 2 less than equals to SYT by N if sigma 1 and sigma 2 are either both positive or both negative. Second is sigma 1 minus sigma 2 less than equals to SYT by N. This would be the case if sigma 1 and sigma 2 have opposite sign. Clear for everyone or not? Please tell me that. Clear for everyone or not? Please tell me that. Clear for everyone or not? Please tell me that. Okay, Sikandar, I have not seen that question right now. You do one thing, you share that question with me on Telegram. After this session, I will give you the answer for that. Okay? Because right now, we are not going to go for somewhere else. Neither I have that question in PPT, but I will give you the answer just after this class. You just put it on my Telegram personally or my WhatsApp personally, wherever you want. Okay? So guys, everybody is clear. This is the MSST. Now we will go for the failure envelope. If we are going for the failure envelope, how I will be going for? So you know that when we are going for the failure envelope, you know for the same principles, for the same nature of principal stresses, it is giving the same result as that of Rankine. So my dear, if the results are same, failure envelope will also be same. So you know, in the first quadrant both principal stresses are positive, so here the same failure envelope will be coming. In third quadrant both are negative, here also the same failure envelope will be coming. But in the second and fourth quadrant we would be having some change in the failure envelope, and for that you already know the equation is sigma 1 minus sigma 2 is less than equals to SYT by N. So for making the failure envelope we consider factor of safety to be 1. So sigma 1 minus sigma 2 is equals to SYT, is nothing but x minus y is constant, plus for tension minus for compression. Y will be x plus minus c, plus for tension minus for compression. So my dear, there are three equations. Y is equals to x, y is equals to x plus c, y is equals to x minus c. So we would be having three straight line equations. One straight line equation, y is equals to x, is like this, which is not required here. We are actually requiring y is equals to x plus c here and y is equals to x minus c here. So when we go for x plus c, c is SYT, this is SYT, this is SYT, SYT, SYT. Always remember, in theory of failure, every failure envelope is passing through the same SYT, all the axes. So if you go for y is equals to x plus c, you will be having this line. Y is equals to x minus c, you will be having this line. And my dear, as you have inequality less than 0, it means towards the origin. So every line will be saying, will be crying, चिल्ला चिल्ला कर बोल रही है, यही है, यही है, यही है. And when we are having यही है, so we would be saying this is the safe region. And my dear, if you are going to cover this with the boundary, then this hexagon is nothing but the failure envelope. Is it clear for everyone? Clear for everyone? Please tell me that. This is the second theory of failure. MSST is over. So when we see this theory is found to be valid for ductile material. Is it clear, guys? Clear, guys? This is found to be valid for ductile materials. Do like and share, guys. अभी तो first chapter ही चल रहा है. We are going to cover one by one each chapters. The more time will be taken by theory of failure and fatigue loading. Brakes is a small chapter, clutch is a small chapter. Then we have all other topics are not that big. Okay. Moving to the third theory is total strain energy theory. That is also said to be maximum strain energy theory, or we can call it as MSET. It was given by Hayes. So Hayes said that why you are considering the concept of stress and strain again and again, and that is why as you are taking stress, that is the problem, that either it is valid for ductile or it is valid for brittle, because different materials are getting failed by different type of stresses. You know that. So Hayes said that you should take a criteria that is related to the energy, because like in thermodynamics we have energy, first law, second law, you know energy can neither be created nor destroyed. So he was having the idea that if you will consider energy as a criteria, the theory may be valid for both ductile and brittle. So what was the energy defined actually? Sorry. Just wait, guys. Okay, sorry, actually ये गिर गया था. Fine, guys. So when we are talking about total strain energy theory, sir, for gate XE, which combination is good? I would say that both are good. If you are going for SOM plus thermo, FM plus thermo, FM plus SOM, both are good. Just you need to check whenever you are going for thermo and SOM, it is also including engineering mechanics and some part of TOM also. Just need to consider that. So when we are talking about maximum strain energy theory, they have considered the failure criteria to be total strain energy per unit volume. So he said if total strain energy volume per unit volume of combined loading is going to exceed the same of tension test, then my dear material is going to fail for sure. And if the strain energy per unit volume of combined loading is going to be less than equals to for the same of tension test, material is going to be safe. So my dear, when we are going to consider that, here we will not go for derivation, I will directly give you the result. So when we are going to find out this, what we are getting as a result, so we would be getting 1 upon 2E. I am giving you the result for total strain energy per unit volume because of combined loading. 1 upon 2E into sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu sigma 1 sigma 2 sigma 2 sigma 3 sigma 1 sigma 3. This is the result for combined loading. Yes, happy Bhogi to you also, Savi, no issues. So when we are talking about this is strain energy per unit volume for combined loading. And when we are going for the same for the tension test, strain energy per unit volume for tension test, it would be coming out to be 1 by 2E into sigma 1, you know, is SYT ka square upon N ka square. And you know sigma 2 sigma 3 will be 0. So when you will go for the final relation, it is coming out to be sigma 1 square plus sigma 2 square plus sigma 3 square minus 2 mu sigma 1 sigma 2 plus sigma 2 sigma 3 plus sigma 1 sigma 3. And that is less than equals to SYT square upon N square. Always remember, here we are having SYT square in the right hand side. Is it clear for everyone? That's great, Ashwin, Ganesh. So whenever you are getting selected, give that good news, okay? So that I get to know ki one of our good student got selection. Okay, so don't worry. And thanks for your wonderful words. So this is sigma 1 square plus 2 square plus 3 square. This is going to be the statement for maximum strain energy theory. And this is for 3D. If you want to write it for 2D, then you know sigma 3 will become 0. Sigma 1 square, sigma 2 square minus 2 mu sigma 1 sigma 2 less than equals to SYT square upon N square. So my dear, this is the relation, this is the equation for maximum strain energy theory for 2D. Okay, I would like to say, when this theory was coming, we were having an idea that this theory would be valid for both ductile and brittle material. But when this theory came, this was found to be neither valid for ductile material, neither for ductile material, nor for brittle materials. Is it clear for everyone? Is it clear for everyone? Is it clear for everyone? Okay, so this is going to be neither for ductile nor for brittle. Reason behind that, my dear, is whenever we are going for the failure envelope, you know that sigma 1 square plus sigma 2 square minus 2 mu sigma 1 sigma 2 is equals to SYT square. If you want to see that this equation shows which geometry, just divide entire equation by SYT ka square. So you would be writing here sigma 1 square SYT ka square, sigma 2 square SYT square, 2 mu sigma 1 sigma 2 SYT ka square. You can write less than equals to or write equals to only. Equals to only 1. So if you see this equation is the equation of generalized ellipse. This is generalized ellipse. And this type of ellipse is called as generalized ellipse because of this third term. It do not have its major and minor axis on x and y axis. So generally when we plot ellipse, we plot it like this. And we say this is major axis, this is minor axis. Okay, this is major axis, this is minor. But when this term is coming, because of that it became generalized ellipse, and this is the semi-major axis, this is the semi-minor axis. And when you will find out this semi-major axis, it is coming out to be SYT by square root of 1 minus mu. And semi-minor axis is coming out to be SYT. Okay, this is 1 minus mu. SYT by square root of 1 plus mu. So this is how we can find out semi-major and semi-minor axis. So guys, this is nothing but the failure envelope, and the problem with this envelope is this haze. Haze was saying that this is the safe region, but in reality some failure points entered inside this. Some failure points entered inside this, and if failure points are entered inside this, we cannot call it as failure envelope. Yes, Jahangir Pasha, good evening, how are you? So some failure points were lying inside it. Okay, I am not showing you exact location of the points, but I am telling you, yes, some failure points were coming inside this ellipse. That's why this was not found to be valid for ductile or brittle material, and that's why this theory was a big failure. And then, my dear, many researchers thought ki what can be the reason behind the failure of this theory, and at that time von Mises came into picture. When I teach this chapter in the classes, it takes 6 to 7 hours, okay, but here we are going just for the exam point of view, nothing more than that. So I am just giving you two things, one is statement, other is representation and equation. We are not going in the explanation, okay, because that is not required for GATE exam, okay. And this is marathon revisions going on. So my dear, when the fourth theory, when the next researcher have seen that there is some problem with maximum strain energy theory, then they started working over that, ki what can be the problem. So they found, studying, that total strain energy is having two components. One component is said to be volumetric strain energy, other is said to be distortion strain energy, distortion or shear strain energy. So they found whenever a material is subjected to some loading, there are two types of thing changes. One is its volume changes, other is its shape changes. So they said the component of the strain energy which is responsible for the change of volume is said to be volumetric strain energy, and the component which is responsible for the distortion or shape change is said to be distortion or shear strain energy. So they said ki whenever we are going to see different material, we found some materials are getting failed because of change of shape, and some materials are getting failed because of change of volume. So if that is the case, we cannot have the total strain energy as the failure criteria for all the materials. So they concluded that when this every material is having different failure criteria, how every material can have the same theory of failure. So that is why he have changed the direction of thinking, and he said I would be talking about the ductile materials, and ductile materials are failed because of change of shape, or you can say because of shear. So he concentrated on the distortion energy or shear strain energy per unit volume. So he said कि if the distortion energy per unit volume due to combined loading is more than the distortion energy per unit volume of tension test, material will fail. And if distortion energy of combined loading is less than equals to distortion energy of tension test, material will be safe. And while considering this fact, he derived the expression for the distortion energy, and he got various expression for distortion energy, which I am going to show you. The first expression which he have given for distortion energy was 1 plus mu, and I am telling you 2 to 3 times in GATE question have been asked where they have just asked which of the following expression is the correct expression for distortion energy per unit volume. So distortion energy per unit volume is 1 plus mu upon 3e. 1 plus mu upon 3e, sigma 1 square, sigma 2 square, sigma 3 square, minus sigma 1 sigma 2 minus sigma 2 sigma 3 minus sigma 1 sigma 3. This was the expression given for the combined loading. for distortion energy for the combined loading. Okay, this is the first expression. In the second expression, you can also do one thing, that we can multiply and divide it by 2. When I will multiply and divide it by 2, it will be 1 plus mu upon 6e. 1 plus mu upon 6e. And this after multiplication will become 2 sigma 1 square, 2 sigma 2 square, 2 sigma 3 square, minus 2 sigma 1 sigma 2, minus 2 sigma 2 sigma 3, minus 2 sigma 1 sigma 3. You will see they are 3 perfect square. Sigma 1 minus sigma 2 का square, sigma 2 minus sigma 3 का square, sigma 1 minus sigma 3 का square. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Then my dear, you also know that E is equals to 2G into 1 plus mu. So from here you can also write 1 plus mu upon E as 1 by 2G. So from that we can write the same expression as distortion energy for combined loading 1 by 12G sigma 1 minus sigma 2 का square plus sigma 2 minus sigma 3 का square plus sigma 1 minus sigma 3 का square. And when we are going for calculation of the UD for tension test, you know what we need to do? We just need to do sigma 2 बराबर 0, sigma 3 बराबर 0 and sigma 1 बराबर SYT by N. When you are going for that, it would be coming out to be 1 plus mu upon 3E into SYT square upon N square. So when you will be going for the theory that distortion energy per unit volume of combined loading shall be less than equals to distortion energy per unit volume of the tension test. Let us go for it. Let us go for it. Then you would be saying that sigma 1 का square, sigma 2 का square, sigma 3 का square, minus sigma 1 sigma 2, minus sigma 2 sigma 3, minus sigma 1 sigma 3 less than equals to SYT square upon N square. This is the statement, my dear, for 3D. Von Mises theory of failure for 3D. And if you are going to have for 2 dimension, then my dear, we would be having sigma 1 का square plus sigma 2 का square minus sigma 1 sigma 2 less than equals to SYT square upon N square. Is it clear for everyone? This is nothing but MDET, maximum distortion energy theory for 2D. Clear for everyone, guys? Please tell me that. Clear for everyone, guys? Please tell me that. Clear for everyone, guys? Please tell me that. Everybody understood? Everybody understood? Please tell me. Then we are moving further, guys. Please tell me. Because now we are going for the failure envelope of this theory. Now we are going for the failure envelope for this theory. Okay, and then we will be going to the last theory of failure. Okay? Yes. Fine, guys. So now, my dear, when we are going to make the failure envelope for this, once again you can see sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equals to SYT square upon N square. We will put N as 1 to make the failure envelope. Here also when you will be saying sigma 1 square upon SYT ka square, sigma 2 square SYT ka square, sigma 1 sigma 2 SYT ka square is equals to 1. So when you will see this, this is once again the generalized ellipse. But my dear, this generalized ellipse is not like the previous one. As the previous one was depending on mu, it is not depending on mu. So when we are talking about this failure envelope is also coming ellipse, But if you remember, we have studied a theory of failure, MSST, which have given us this hexagon. So my dear, when we are talking about this ellipse is going to pass, from all the corner points of this hexagon. So this ellipse is going to pass from all the corner point of the hexagon. And my dear, when we are talking about that, this is also having a semi-major and semi-minor axis. Semi-major axis is given as √2 times of SYT, and semi-minor axis is given as √2/3 of SYT. So this is going to be maximum distortion energy theory, and this theory was found to be valid for ductile material. So till now we have seen brittle materials are satisfied by Rankine theory, MSST ductile material, MSET no material, MDET ductile materials. Is it clear or not? I told you na, every theory of failure is not valid at every location. That was the limitation, because they are the hypothetical statements. So everywhere you cannot find them valid. Is it clear for everyone? Please tell me that. So we are going very quickly, and I feel you guys are ready for this. In the marathon, that is what you are looking for, because marathons are meant for revision purpose. Okay. So guys, now we are moving further. That when we are talking about the previous theory, MDET, here if you will ask me, sir, where the failure points is? In MPST and MSST, failure points were outside the envelope. Whereas in MDET, when we are talking about, failure points are lying on the ellipse. So when they are on the ellipse, I would like to say this is the exact theory. Because MPST, MSST give a area which is having failure points quite outside. MSET gives the failure theory, the envelope in such a way, failure points lies inside. But here failure points lies exactly on the ellipse. So that's why it is going to be somewhere the exact theory of failure. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that this is about the fourth theory of failure. Now my dear, we would be moving for the fifth theory of failure, which is also said to be maximum principal strain theory. When we are talking about maximum principal strain theory, it was given by Saint-Venant. So we also call it as Saint-Venant's theory. And Saint-Venant said that the material is getting failed because of the maximum value of strain. So he said that if the maximum value of strain because of combined loading is going to be more than the maximum value of strain because of tension test, material will fail. And if the maximum value of strain because of combined loading is less than equals to the maximum value of strain because of tension test, the material is going to be safe. And he talked about the normal strain. That's why the name of the theory is maximum principal strain theory or maximum normal strain theory. Okay, so it is maximum principal or maximum normal strain theory. So when we are talking about this Saint-Venant theory, you know that combined loading, when we are talking about combined loading, in the combined loading, if you are going to find out the principal stress and principal strain, you have seen in strength of material, we can write this as epsilon 1 and epsilon 2. So in combined loading, you know, like we have sigma 1, sigma 2, here we have epsilon 1, epsilon 2. And out of these two, any value can be bigger magnitude wise. So for failure, we would be saying epsilon 1 or epsilon 2 should be less than equals to epsilon max in the tension test. So when you would be going for this, what we are going to get? We would be getting sigma 1 by E minus mu times sigma 2 by E. Either this will be bigger or sigma 2 by E minus mu times sigma 1 by E. This will be bigger. And in the tension test, we will always be having SYT upon NE. Why? Because in tension test, we have sigma 2 0, sigma 3 0. That's why if only sigma 1 is there. then out of sigma 1 by E or mu times sigma 1 of E, is sigma 1 of E is going to be bigger. So that's why here we are having SYT upon NE. So here E will get cancelled out. And we have the equation sigma 1 minus mu times of sigma 2 or sigma 2 minus mu times of sigma 1. This should be less than equals to SYT by N. So my dear, this is going to be the statement for maximum principal strain theory. Everybody understood this? Please tell me that this is the maximum. If anybody have any doubt and anywhere you want more discussion, you can tell me. So we are going for revision, and where you find that discussion is required, we will go for it. Okay? Is it clear? Is it clear? Yes. Sorry guys, I was having some cold. So let us make the failure envelope for this. Let us make the failure envelope for this. When we are going for failure envelope, the equation is sigma 1 minus mu times sigma 2 is equals to SYT, because we consider factor of safety to be 1. So you can see sigma 2 minus mu times sigma 1 is equals to SYT. That is the equations we have. You can see one equation with this, other with this. And these equation, if you are going to have tension, you will make plus, compression minus. So likewise, if you say we have 4 straight line equation. One is x minus mu times of y is equals to plus constant. Other is x minus mu times of y minus constant. Then other two are y minus mu times of x plus constant, y minus mu times of x minus constant. If you make these 4 straight lines, then these 4 straight lines are going like this. This is 1, 2nd, 3rd, 4th. And you know, in reality we have an inequality of less than equals to 0. Less than equals to means towards the origin. So all these lines will be saying towards the origin. So when you would be going ahead with all the lines, you would be saying this region is going to be the safe region as per the theory. But my dear, when we see this closely, we found till now we studied 4 theory. Out of that, worst theory was MSET, because it was having a bigger ellipse in which failure points were coming inside. But when you put that ellipse into this, you will find that ellipse is getting fit into this. So if that ellipse is getting fit into this and already failure points are there in the ellipse, then it would be including even more failure points. So that is why this theory is reaching to the next worst. So if previous one was the bad one, this is the worst one. This is the charam seema of worstness. So my dear, here much failure points will lie inside. So this theory was also neither found to be valid for ductile nor for brittle. So my dear, we have studied 5 theories. We have studied 5 theories. Out of 5 theories, whenever we are talking about the 3 theories which were useful, one is MPST, other is MSST, other is MDET, where this would be used for brittle material. These 2 are used for ductile materials. And my dear, then if you remember, when I am teaching you complete theory of failure, I also go for the difference between these 2. But here we will not go for that derivation, we will directly go for the result. So when we are going to compare the MSST and MDET, so my dear, whenever we are going with this, what we found actually, both the theories are having the failure points outside or on the curve. They are not having failure points inside the curve. So that is why whenever we will be talking about maximum shear stress theory, it is found to be safest but uneconomic theory of failure. And this is going to be safe and economic theory of failure. Why? Because the failure envelope of MSST was like this, and the failure envelope for MDET was like this. So you know that when failure envelope is smaller, we are having more factor of safety. है ना? That you know already. So when we are using MSST, we are having more safety, and MDET is giving us less safety. And if you compare all the failure envelope at glance, you will find the smallest failure envelope we are going to get from MSST. That is one of the reason that MSST is also said to be the most conservative theory of failure. Okay, because you must have seen every parents are putting some kind of restrictions on their children's. Like some parents are putting the normal restrictions, like come on time, go on time, eat food, this food, not that food, that kind of thing. Some parents are that much conservative, they do not allow their children to go outside home. They say your tuitions will also coming to your home. You will just go school, come back, then tuition teacher is coming to home. And you need not to go outside anywhere. They are very conservative about their childs. Even for 11, 12, they will not send them to the coachings. They will ask the tutors to take extra money and come to us. So they are very conservative. Okay. So likewise, whenever we are going to have this thing in MSST, we have the conservative, because the boundaries are very small for this. And this is the smallest boundaries. So guys, this is the revision way we have completed all the theories. But if you will see, when I go in detail, there are many sessions of mine available where I have taught theory of failure in 3 to 3.5 hours. But here this is not the right time. I feel you also want me to go faster. Okay, because we are here for the revision purpose majorly. So that's why I went faster, and you can see till now 2 hours are not over, theory of failure is about to over. So we have went through very good speed today. Okay. And do you want me to go with that speed? If we will go with that speed, definitely we will be covering the syllabus fastly, on time. Okay, if we will go slower, then the problem is, once again, like in Tom's syllabus was not over, and many students would be feeling very happy also, because if they have not even touched the subject, they will be saying that, sir, you have taught everything. Okay, but for revision, these marathons are meant for. Okay, so guys, when we are talking about the last point here, that is, sometime they would be asking you the yield strength in shear as compared to yield strength in tension. Like they will give you that yield strength in tension is 200 MPa, and they will say find out the yield strength in shear as per maximum distortion energy theory. So if they ask you this type of question, for that also there are some derivations of all 5 theories. But I would give you the direct results. When we are talking about maximum principal stress theory, it says yield strength in shear is equals to yield strength in tension. And this we are deriving for the torsion test. Torsion test is a special condition when we have pure shear state of stress. For this condition we are deriving it. So we are going to have SYS is equals to SYT as per MPST. As per MSST, we would be having SYS is 0.5 times of SYT. And as per MDET, we have SYS as 0.577 times of SYT. And generally this is asked actually. Is it clear? So you should be aware of that. Like you have seen the relation of maximum distortion energy theory as sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equals to SYT square. If they ask you find out the equivalent stress according to MDET. So you can see left hand side denote the combined loading, right hand side denote the tension test. So when we have left hand side combined loading, right hand side tension test. Tension test is having एक अकेला सब पर भारी. Combined loading is having many loadings. So when he is asking find out the equivalent stress, so this SYT is said to be the equivalent stress. So whatever theory he says, write the expression for that, find out the value of SYT. Like SYT as per von Mises theory, you can also write it as equivalent stress or working stress. It will be coming out to be square root of sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. Please tell me how many of you understood this concept. With this we have completed the theories of failure. This is the first time I am going in that quick way. I thought ki let us try today how students feel this. Okay? Because if I will be going like that, then it will be possible that ki between the 21st to 30th, maybe in one day I can go for entire mechanical engineering revision. So is it clear for everyone? Please tell me. And that kind of thing is required from your side as well. Wonderful guys. बहुत बढ़िया. If anybody have any doubt at any of the position, any of the question, any of the topic, you can stop me there. I will help you out. Don't worry. So now we have some questions. Let us see some questions. Okay. This is the question. A thin cylindrical pressure vessel with mean diameter 10 meter and wall thickness 20 mm is subjected to an internal fluid pressure of 0.4 MPa. If the yield strength of the material of the cylinder is 200 MPa, factor of safety according to maximum shear stress theory. So my dear, you know that whenever we are talking about the thin cylindrical pressure vessel, you already know here sigma 1 is PR by T. Sigma 2 is PR by 2T. So you know that they both are positive. So principal stresses are of same nature. So MSST will say the same as MPST have said. It is less than equals to SYT by N. Put the value, get the answer. Put the value, get the answer. Yes, Ashray, you may not be remembering. Why? Because you were not there at that time. In 2020 GATE we have done that. 2021. When in 2021 we have gone through the complete mechanical engineering formulas in one day. And there, if you will see that marathon, it went for around 13-14 hours. And entire mechanical engineering we have done, but just only formulas we have revised at that time. Okay, first tell me what is the answer. This time also we are looking for that. We are thinking to repeat that. Tell me the answer, guys. Tell me the answer, guys. Tell me the answer, guys. Yes. Okay, okay. So the answer for this, is it coming out to be 2? So when you will be going for this, are you getting the 2? Vinay is saying 2. Aniket, अरे भाई 0.5 नहीं होगा. Factor of safety, whenever the material is safe, is always going to be on the positive side. Very good Kundan, very good Ashray, very good Dhanesh, very good Aniket, बहुत बढ़िया. Akhila, very good. So answer for this is going to be D. That's correct. That's definitely correct. Yes, that is correct. So guys, let us move to the next question. Let us move to the next question. Okay, this question guys. A component is subjected to an axial stress of 250 MPa, shear stress of 150 MPa. Yield strength is 400, ultimate is 600. The factor of safety by distortion energy. For that, first of all, you need to find out sigma 1, 2. And you know it is given that normal stress is nothing but 250 and shear stress is nothing but 150. So sigma xx is 250, sigma yy is 0 and tau xy is 150. So just solve it. Sigma 1, 2 is xx by 2 plus minus square root of xx by 2 का square plus tau xy. Find out 1, 2 and then apply sigma 1 square plus sigma 2 square minus sigma 1 sigma 2 is equals to SYT square upon N. When SYT and SUT both are given, it means material is ductile. So you will go with SYT. And if only SYT is given, it means material is brittle. Solve this question guys. Solve this question guys. हाँ बिल्कुल बिल्कुल अनिकेत, माइंड कैलकुलेशन मशीन डिजाइन में कैसे होगी यार. And don't worry, every chapter we will do 4-5 questions like that, because machine design is all about questions. Okay, there is nothing much theory of machine design. Give me the answer, then we will move for the next chapter, that is fatigue loading. That is also very important topic. We will try to finish that in 1 hour, 1 hour 15 minutes like that. Tell me guys, tell me, keep sharing the session. Find out sigma 1, 2, then use this equation, you will get the value of factor of safety. Solve it. Yes. Okay, Shreyas, you are correct. You are correct. Fine. Move further. Yes, everybody, I am waiting for your answer. Okay, so Kundan is saying C would be the answer. What about others? Yes, Shreyas. So when you are going to find out sigma 1, 2, sigma 1, 2, tell me the value of sigma 1. It would be coming out to be 250 by 2. 250 by 2 plus minus. 250 by 2 means 125 का square, 175 का square. Sorry, 150 का square. 150 का square. हाँ, सारे आंसर बता दो. What you are getting sigma 1, 2? First tell me that. It is coming out to be 125 plus minus square root of 125 का square plus 150 का square. I feel one value is coming out to be 370. 320.25. Okay, Shreyas is saying 320.25. And other value would be what? 320.25 minus 125, what is the other value? Minus of what? Minus of what? 70.25. Am I correct? Yes, very good, Vinay. So these are the two values we are getting, and one is positive, other is negative, but we are going for MDET. Apply this sigma 1 square, sigma 2 square minus sigma 1, sigma 2, and then tell me the answer. Very good, Shreyas. So tell me the answer. Are we getting C? Are we getting C? Are we getting C? Like Kundan is saying. Please tell me. Are we getting C? Shreyas, what is the answer you are getting? Please tell. Yes, very good, Ashray. 1.23 is coming. Okay, so if 1.23 is coming, we will be going for 1.1. I feel it would be coming near to 1.1, as I feel. Very good, Dhanesh. So answer will be C for this. Okay, guys. So now we are going to have this question. We have done one question on MDET, one question on MSST, and this is the last question from MPST. Then we will go to the next chapter, that is fatigue loading, and you can see the limit of proportionality for a certain steel sample is 300 MPa and simple tension. It is subjected to principles as 150, 60 and 30. All are tensile. According to maximum principal stress theory, the factor of safety would be. These type of questions are coming in the gate. Okay, Vineet, no problem. You can watch the recording in that case. Right now, if everything is fine, you can attend now. What is the answer we are getting? Last question from theory of failure. Then we will directly move to the next chapter, fatigue loading. Okay, and then fatigue loading, after that brakes, then bearings, then clutches, then joints, one by one, everything will be covered. Everything. And just as per the exam point of view, everything, a good revision session for every topic. Two hours are completed. So dear, this is very easy now. You know sigma 1 or sigma 2 or sigma 3 less than equals to SYT by N. The highest one is 150, 60 or 30. It is 150. Go for that. 300 by N. What is the answer? What is the answer? All are tensile. All are tensile. This is the maximum principal stress theory. Yes or no? So answer will be 2. How you are giving wrong answer for this, I don't know. How you are giving wrong answer for this, I don't know. Clear for everyone? Yes, very good, very good, very good. So guys, let us move further to the next topic now. Now we will going for the fatigue loading. Okay, this last question before we go to the fatigue loading. The last question before we go to the fatigue loading, which I have already told you, the uniaxial yield strength is 300. According to von Mises criteria, what is the shear yield strength? So you already know SYS is nothing but 0.577 of SYT. Just you need to use the relation and get the answer. This type of questions are also coming. Vineet, टॉम बाकी होगा मंगलवार या बुधवार को, Tuesday or Wednesday. We have already planned it to be Tuesday or Wednesday. Okay, so we are going to have this on Tuesday or Wednesday, most probably. Okay, I will inform in my Telegram channel and WhatsApp group. Don't worry. Okay, there we will see vibrations, gear trains, governor cam balancing. Answer will be coming out to be 173.25 MPa. Chapter is over. Moving to fatigue loading. So guys, now we are having the next chapter, design of machine element for fatigue loading, under fatigue loading. So first of all, we need to understand what is fatigue loading actually. So my dear, whenever we are going to have either magnitude or direction or both for a loading is getting changed with the time. If with the time magnitude is changing, with the time direction is changing, or with the time both are changing, then my dear, we call such loading as fatigue loading. My dear, whenever we are talking about the fatigue loading, why we need to study them separately? Because fatigue, wherever is present, they are going to create vibrations. And my dear, when you will study vibrations in the upcoming session, you will get to know that vibration in a running system can never be zero. And if vibrations are present in a running system, they are reducing the strength of component. They are reducing the strength. Actually, vibrations are said to be the cancer of the mechanical component. So if cancer is like in the human body is going to damage the parts, likewise, whenever vibrations are present in the system, they reduce the strength of the material. So because of that, even with the slower stress, after some time material will fail. Like we were expecting material will fail at SYT. Let us say SYT is 200 MPa. But you will find after some days material failed in 70 MPa because it was not having that much strength to withstand the 200 MPa. The reason is vibrations produces micro cracks in the system. That is why they are going to result into the failure of the component. So my dear, now we are talking about the questions are coming. Can we produce the dynamic or fatigue loading with the help of static? Yes. So my dear, if you are going to have a beam, let us say, and that beam is subjected to the bending. Because of this bending moment, you know that the bending stresses will be developed, and they will be developed like this. Topmost fiber will be in compression, bottommost will be in tension. So if we are going to have this as the state of stress like this, and my dear, now if this component is given rotation, then my dear, this is -5, this is +5 like that. When it is given rotation, the point at which right now the stress is -5, after 180 degree of rotation, the stress will be +5. So whenever you are going to provide the static loading, plus you are going to give rotation to the component, then the effect is getting converted into fatigue. Because when the same fiber right now is at -5 MPa, when this point will be moving after 180 degree, it will reach to here where stress is +5. So it is moving through point -0.2 to -4 to -3 to -2 to -1 to 0 to 1 to 2 likewise. So static loading plus rotation of the component is equals to fatigue loading. This is how the things are going to go ahead. Now my dear, we are going to have the types of fatigue loading. Then the very first type of fatigue loading, we are calling it as completely reverse type of loading. So my dear, now you may be thinking, what is the completely reverse type of loading? A loading is said to be completely reverse if the maximum value of stress and minimum value of stress have equal magnitude. You can see here, if this value is +5, this value is -5, we call this loading as completely reverse loading. Then my dear, repeated loading is having a identification if the minimum value of stress is 0. So if minimum value of stress is 0, we call such loading as repeated stresses or repeated loading. Then my dear, if we are going to have the loading variation only on one side, either they are on the positive side or they are on the negative side only, we call such loading as fluctuating loading. Like whenever voltage fluctuates, then my dear, the bulb is giving sometime more light, sometime less light, but it always gives light. It never gives darkness. Then my dear, we can have the alternating loading. If we have alternative plus minus, but the magnitude of plus and minus may not be same, we call it as alternating loading. So these are the 4 types of fatigue loading. And my dear, now let us see the terminology of fatigue loading. My dear, you have seen that fatigue loading means the stresses are going to vary. So the maximum value of stress, we call it as maximum stress, denoted by sigma maximum. The minimum value of stress, we call it as minimum stress, we denote it by sigma minimum. And my dear, when we are talking about the component or the definition of mean stress, then mean stress is defined as maximum plus minimum by 2. Then we have a terminology stress variable or amplitude stress. It is defined as sigma A, as sigma maximum minus sigma minimum by 2. Then we have something known as stress ratio. It is defined as sigma minimum by sigma maximum. Then my dear, the next terminology is range of stress. Range of stress is defined as sigma maximum minus sigma minimum. Then we have amplitude ratio. Amplitude ratio is defined as the ratio of amplitude stress but a mean stress. Amplitude stress is maximum minus minimum by 2, mean is maximum plus minimum by 2. So my dear, now if you are going to consider sigma maximum common from numerator and denominator both, you would be getting here 1 minus sigma minimum by sigma maximum, which is nothing but the stress ratio. Here 1 plus sigma minimum by sigma maximum, which is nothing but the stress ratio. So this is going to get cancelled out. So amplitude ratio is coming out to be 1 minus r by 1 plus r. Now my dear, generally we can expect in the paper that they can ask you all these parameters for a given particular type of loading. Like they can ask you what are the various values in case of completely reverse loading. So you know, in the completely reverse loading, maximum and minimum have the same magnitude. So for that, if sigma maximum is plus sigma, sigma minimum will be minus sigma. So I am calculating all the terms for completely reverse loading. Mean stress will become 0. Amplitude will become sigma. Stress ratio will become minus 1 because minus sigma by plus sigma. Similarly, range of stress will become 2 sigma. This amplitude ratio will become infinity because r is minus 1. So 1 minus 1 will become 0. Denominator 0 means infinity. They can also give you a question, given that the maximum value of stress is 250 MPa, minimum value of stress is 50 MPa. For the given fluctuating fatigue loading, find out the value of stress amplitude and stress ratio. This is the question of GATE 2015. Solve it and get the answer, guys. 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 Yes, yes, yes. इतना मुश्किल नहीं है भाई. What is amplitude stress? Maximum minus minimum by 2. What is stress ratio, bhai? Minimum by maximum. Yes, very good. So guys, it is 250 minus 50 by 2. It is 50 by 250. Clear for everyone? Savi, Ashray, Akhila, Shreyas, everybody understood? Everybody, Kundan, everybody have done some mistakes. Clear for everyone? These are the answers I have already mentioned. Aniket, here you have made some mistake. Okay, very good Vinay, बहुत बढ़िया. So guys, now we are moving next. The answer is 100.2. Now my dear, we are going to the R.R. Morey experiment. Okay, no issues, no issues. When we are talking about R.R. Morey experiment, I will not go into experiment. You guys know when I explain it in detail, it will take 40-50 minutes. That is not required. But you know that the result of this experiment we are getting as SN curve, which is important for exam. Nobody will ask you about the experiment. People will be asking you from the SN curve. So from this experiment, when we are going to plot the curve, we are getting this type of curve. You can see here this point when we are having 0. Here we have log base 10n. And here we have log base 10 sigma amplitude. Why we are going to have log scale? Because number of cycles for which we are going to test. Actually, what is the target of this experiment? We have taken a mild steel specimen. We have applied some loads here. You can see these are the loads, weights. And when we are applying that load, we are going to see at the loading is static, we are going to give rotation to make it fatigue. And we are going to see after how many cycles the component is going to get fracture. Okay, so if that is the case, we have made the table where in the first row, first column we have the load, second we have amplitude stress, third we have the number of revolutions. And with the help of this data, whenever we are going to plot the curve is coming like this from 0 to 1000 revolutions. Curve is coming like that. After that, its slope changes. Slope changes in such a way that this thing is log base 10 SUT, because if the stress induced is equals to the ultimate strength, then without any cycle the component will fracture, as we know from the stress strain diagram. But if you are going to reduce the value of stress, if the stress will be reducing from the ultimate stress, then it would be going to rotate some revolutions. And my dear, when we are going to apply the loading in such a way that stress is 0.9 times of SUT, for that we are going to see 1000 cycles are completed by the component. So that is denoted by 3, because 10 to the power 3 ka log base 10 will become 3. Then we will reduce the load, stress will get reduced, and after some time we will reach to the 10 to the power 6 revolution, which was a very big number for that time if you are talking about. And that corresponding to this revolution, we are getting a stress that is said to be endurance limit. Endurance limit is the stress corresponding to 10 to the power 6 revolutions. Although after that we stopped the experiment, but we are getting assumed there that after this much revolution we will change the component. So if you will change the component before failure, it will never fail. So that's why we are saying after this the life is going to be infinite. So 10 to the power 6 cycle was considered as infinite life, because after that you are changing the component will never fail. So my dear, this is the curve which is coming. If a component is getting failed between 0 to 1000 cycle, we call this as low cycle fatigue. And if a component is getting failed from 1000 to 10 to the power 6 cycles, we call this as high cycle fatigue failure. Low cycle fatigue failure is generally considered because of yielding, and high cycle fatigue is considered as a real fatigue failure. High cycle fatigue is being observed in the spring, in the shaft, in the bearing, in the gears. Low cycle fatigue is observed in the nut, in the bolt, in the screw, in the studs and all. Okay. So my dear, in general, we will not be talking about low cycle fatigue. We would be starting our diagram from here, and we are dealing with high cycle fatigue. So that's why in your case, whenever you would be having a question, you will be getting the diagram to be plotted like this. Your diagram which would be given to you would be like this. And you would be having its starting point as 3, 4, 5, 6. On x-axis we have log base 10 number of revolution. On y-axis we have log base 10 sigma amplitude. Okay, and when we are having this, the curve is coming like this. The curve is coming like this. And you know, my dear, when we are talking about this, this is log base 10 endurance limit. This is log base 10, 0.9 of SUT. Now my dear, in the question they will be asking you कि what is the life corresponding to this particular stress. So you need to find out this actually. And this will be given to you like log base 10 sigma. This will be given to you. Let us consider it as sigma star. It would be given to you. So whenever you are getting the question like this, how you will be moving further? You are going to take their two triangles. One triangle is ABC, other is ADE, and you would be going for the similar triangle. They are similar because this angle 90, this angle 90. This is common angle, same, and this is the common angle. So all three angles are same angle, similarity will be there. So you can write as AB by BC, AD by DE. When you are talking about AB is nothing but log base 10 0.9 SUT which would be given to you in the question minus log base 10 sigma star which would be given to you in the question divided by, this is let us say x minus 3. It is equals to log base 10 0.9 SUT minus log base 10 SE. Both these values will be known to us, divided by 6 minus 3. Here if there is some unknown, that is only x. And once you get x, your purpose is going to be solved. This is the very first type of numerical which are coming in the fatigue loading chapter. So from here you would be getting the value of x something. And if you would be getting the value of x, my dear, then you would be putting that x is to be log base 10n. N will be coming out to be 10 की power x. That would be the number of cycle or number of revolution, and that is going to be our final answer. Is it clear for everyone? Please tell me that. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. बोलो भाई आया कि नहीं? This is the first type of question from this chapter, guys. Wonderful, guys. Wonderful. First type of question from, second type of question. First type is from terminology of fatigue loading. This is the second type of question. Now, my dear, after that, I would like to tell you one more thing. Like you know SYT and SUT. They are the properties of material. But endurance limit is not a property. Because it is depending on the factor like size, shape, है ना, surface finish. That's why endurance limit is not a property of material. So guys, now we are moving for the next heading, that is stress concentration. I told you at the time of theory of failure, we see the stress concentration in the next chapter. Actually, my dear, whenever you are going to have any irregularity present in a cross section, like you were having a plate like this, and in this plate you are having a hole like this. So when you are going to have this type of irregularity, what is irregularity? Here you know the area was this into the thickness. Here also this into the thickness. Everywhere this into the thickness. But from here to here, the area is going to change, and here we get the minimum area, where the area would be nothing but B minus D into T. This is the minimum area at 2-2 section. So whenever likewise area is going to change, likewise you can also have a component like this. Here also area is changing. Sometimes you can also having a notch like this. Here also the area is changing. So whenever you see that kind of abrupt change in a cross section, then my dear, we find that stresses which are coming into the component are found to be quite high, but quite higher than what it's supposed to be. जितनी होनी चाहिए उससे कहीं ज्यादा आगे निकल जाता है. Yes, अजय, हाय डियर, लेट हो गए आज आप. तो यहाँ पर जो स्ट्रेस whatever we are thinking it would be, it is coming quite more than that. Like for example, you know stress is defined as force but a area, we know that. Okay, in that way if you would be writing stress in 1-1 section, it would be simply P divided by B into T. And if you will write in the 2-2 section, it would be P divided by B minus D into T. So if we are getting the stress in 1-1 as P by BT, in 2-2 as P by B minus D into T, from that you can feel that sigma 2-2 is coming out to be more than sigma 1-1. Is it clear? Sigma 2-2 is coming out, that is obviously going to be. And where we would be having the minimum area of cross section, where we are going to have the minimum area of cross section. This is the minimum area of cross section. So my dear, when we are going to get the minimum area of cross section, obviously stress is going to be maximum. So you may be thinking, sir, it is fine, na? Stress will be there, maximum only. It's fine, there is no problem. This is as per strength of material. But when we are going to find out this sigma 22, actually it is coming out to be much bigger than this P by B minus D into T. So we call this stress, which is coming from the formula of Sohm, as the nominal stress. So actual stress is coming more than the nominal stress. And my dear, when we are talking about this actual stress as it is coming more than the nominal stress, that phenomena of accumulation of more stress is said to be stress concentration. And that is defined by the idea of stress concentration lines. Like if you are having a normal cross section like this, these are the stress lines which are going. And these stress lines can be observed from a special type of experiment that is said to be photoelasticity experiment. There is a special type of experiment, photoelasticity experiment, which is performed in central polariscope. And my dear, in this central polariscope, when you are going to perform the experiment, you can observe these lines like that. But whenever you are going to have some abrupt or some obstacle, some this kind of disruptions in the area, now these stress lines, whenever they are passing, you can see whenever this line will be passing, it has to go like this. Whenever this line is passing, it has to go like this. Whenever this line is passing, it has to go like this. And because these lines have to travel like that, you will see in this vicinity of hole, the stress lines are coming closer than the usual ones. Because of that, here the stresses are going to be quite higher. And when you are going to find out the stress distribution, my dear, when you are going to find out the stress distribution, then my dear, the stress distribution will be coming like this. Stress distribution will be coming like this. Like this. Like this. So here you are going to get the maximum stress here. And this maximum stress is defined as Kf into sigma naught. Okay. And this Kf is said to be actual stress concentration factor. Actual stress concentration factor. But my dear, the problem is, whatever we are finding out here, sigma maximum, that is defined as Kt into sigma naught. So what is the difference between these two? This is the actual value of stress which would be coming at the vicinity of hole, and this is said to be the maximum value of stress which you are going to see in the photoelasticity experiment. Kf is actual and Kt is said to be theoretical stress concentration factor. Why it is theoretical stress concentration factor? My dear, because whenever we are going to perform the photoelasticity experiment, that experiment is going to be, sir, we having small request, if possible, cover only complete PYQ of FM. We are struggled a lot. Okay, Priyanka, we will see that. I will forward your request to the FM faculty. Okay, fine. But if you want any particular PYQ, you can share on the Telegram channels. Our respective faculty will definitely give you the solutions. Okay, so that would be, if you are looking for every subject, that would be a good solution. Rest I will put your request to the concerned faculty. So my dear, when we are talking about this photoelasticity experiment, this is performed with the static loading. And we are studying the chapter of fatigue loading. So loading type in the experiment and the reality is different. And whenever photoelasticity experiment is performed, that is to be performed on the synthetic plastic epoxy resin material. Real materials are mild steel cast iron. So neither the material is same nor the loading is same. So whatever you are getting from experiment is said to be theoretical stress concentration factor. And whatever actually coming is the actual stress concentration factor. But my dear, as whatever the materials we are choosing, for them the stress concentration factor is coming out to be more than the actual one. So that is why all the calculations we are going to do with the KT only, because it is very difficult to find out KF. For finding out KF, we need to actually fail the material. Like if someone will ask to a like there are some experts which will tell you by looking at your kundali, Janam Kundali, by knowing your date of birth. They will tell you your horoscope, how your day will be, when you will die, what is your age, when you will get married. So whenever you are going to such an astrologer and you are saying ki I want to know when I will die, and that astrologer says I will tell you when you will die. So you will say when I will die, then what you will tell me? So that is the point, that you want to know it before. So KF you can find out only by the actual failure of the component. So when we will actually fail the component, what we will be doing with that life? So we are looking for, note the KF, we are going with KT. Because KT we can find out from photoelasticity experiment, and KT is going to be always more than or equals to KF. So if we are going to design with the KT and our component is safe, then with the KF our component is going to be safer. So KT is going to give you better design always. Okay. So my dear, when we are talking about KT, as I have already defined that sigma maximum is nothing but KT times of sigma naught. So KT can be defined as theoretical stress concentration factor as sigma maximum by sigma naught. Is it clear for everyone? So I am giving you all the wonderful concept, that is the theoretical stress concentration factor. Why we call theoretical? Because in the experiment neither loading is real nor material is real. That is why. Now my dear, many people think that we are calling KT as theoretical because it is calculated theoretically. The answer is no. KT is generally measured experimentally with the photoelasticity experiment. So my dear, like we have seen with the photoelasticity experiment, it is majorly calculated or measured with the experiment. But yes, with the help of mathematics, we can also use some of the KT values. Like how? If you are having an elliptical hole like this, in which A is this, B is this. Okay? Okay, I am giving you an example. Let us say you are having a member which is subjected to the force like this. It is having an elliptical hole like this. And this elliptical hole is having this as 2B and this as 2A. If for that case you are finding out experimentally KT is coming out to be 1 plus 2B by A. Let us say you are getting this. Then on the other day, if the ellipse is given like this, and they are saying this distance is 2A, and they are saying this distance is 2B, it is almost same, only the axis is getting changed. Then I will not go for the calculation again, but I will say previously it was 2B by 2A. This time it will be 2A plus 2A by B. Simply I will say. Or someday if they are going to give you a figure like this and they are saying that I am going to have the hole like this. Okay, when this hole is like this, you know this thing is nothing but 2A. And this time the B is 0. If I am going to apply the force like this, you know I will be applying KT is 1 plus 2A by B. B is 0. So KT will be coming out to be infinity. And similarly, if the loading is given in such a way and they are giving this to be 2A and they are saying B is 0, then I would be writing here KT is 1 plus 2B by A. Here my dear, you know this is 2B by 8, B is 0, KT will be coming out to be 1. Can you feel all these things? This is said to be the mathematical way to find out. And my dear, I can also practically show that if you would be having this condition, theoretical stress concentration factor is becoming infinity. I can show you if you want. Okay, just give me a minute. I am showing you this. I am showing you this. I am showing you this. Let us say I am having a piece of paper. I'm going to have a piece of paper like this. Just wait, I am showing you the effect of stress concentration. That will give you a better idea of stress concentration. Just give me a minute. I am making two sheets to show you this experiment. Okay. So this is one sheet in front of you. And in this sheet, let us say I am making a hole like this, like I have shown here. First of all, just feel, if I have a sheet without hole, if I am going to apply the force onto this, you can see it is not getting fractured. But if I do a hole like this in this sheet, this is a horizontal hole, this is a horizontal hole, this is a horizontal hole. I am once again applying the force like that. You can see it is not failing, it is not getting failed. So you can see for this theoretical stress concentration factor is coming out to be 1. So whether the hole is present or not, it is not going to give any effect. But if the same sheet which you are having not fracture, if I am going to make a vertical hole like this, just feel it. If I am going to make a vertical hole, you can also try this at the home in the absence of Ajay Devgan also. So when you would be going to apply this time the force, you can see in the one only it go down. This is showing the effect of stress concentration. Okay, so when the same sheet I am holding this, it is not getting fractured, no effect of KT. Okay, the same I can show you here. KT is coming 1 for this horizontal hole, KT is coming infinity for this vertical hole. Everybody get the feel of stress concentration or not? Please tell me that. So guys, do like and share the session. Everything I am showing you to give you the feel. That level of class is going on for machine design. Moving further, now my dear, we are going for this corrected endurance shear strength. So my dear, as I told you that endurance limit is not the property of the material. It depends on many factors like surface finish, size, reliability and stress concentration. So that is why the corrected endurance limit or endurance strength is given as Ka into Kb into Kc into Kd into Sc. Here Sc is the endurance strength which was given by the Moore experiment or SN diagram. So this is that endurance limit which was given by SN diagram by Sir Moore and Wohler. And my dear, this is the experimental value, you can say. And my dear, whatever you have a component of yours, for that if you want to find out the endurance strength, it will be depending on many factors. Like maybe Sir Moore have taken a surface which was mirror polished, but your surface is having poor surface finish. Then my dear, you need to consider Ka as surface finish factor. Okay, I have given some values also from data book. You need not to remember that. Okay, they will be given in the paper. So this surface finish factor will be used if your surface finish is not mirror polished. Sir Moore have taken diameter less than or equals to 7.5 mm. If you are taking more size, then you need to consider another factor that is known as size factor. You can see the value of size factor is mentioned from the data book as if diameter is lying between 7.5 to 50, it is 0.85. If it is more than 50, it is 0.75. So if you are going to have stress concentration, then Kd is defined as 1 upon Kf. Here Kf is the actual stress concentration factor. But if actual stress concentration factor is not given in the paper, you can also use Kt in place of that. Similarly, Kc is said to be reliability factor. The value of reliability factor will also be given to you. So if these factor values are given to you, you have to consider them. If it is not given to you, leave them. It is simple as that. If they are not given, consider them equals to 1. If they are given, take their values. Why it is 1 by Kf? Because Kf is going to be always more than or equals to 1. But these factors should be less than 1. Because your component is going to be inferior than the Moore's components. Is it clear for everyone? This is the concept of corrected endurance limit. Okay. So this in the classes I go in detail with the data book things, but here it is not required for gate. Okay. So you can see reliability factor also they have given for 50%, 90%, 95%. What is reliability? Whenever you are in problem, you are going to remember those friends which are always going to help you. So a person which is always helping you is the most reliable person. And such persons are very few in number. So they are saying if you are considering 50% reliability, then case is 1. If you are taking 90% reliability, it is 0.897. So if these values will be given to you in the question, you can use it, otherwise leave it. Take KC as 1. Clear for everyone, guys? Clear for everyone? We are moving to the next topic. Everybody is getting it? Please tell me. So no need to worry. We are going with the perfect speed. We are going with the perfect speed. How, dear, you need not to worry about that, because if data book is not given to you, they will give you either the value of these things or you need not to worry about that. Okay, or question will not be coming. So till now they have never asked, but in engineering services they are asking by giving the values. So if they give you Ka is this, Kb is this, Kc is this, Kd is this, use them and find out. If they don't give, leave it. Okay, so moving further, we are going with a very nice speed. I feel we would be covering it in a very nice manner. So when we are talking about notch sensitivity, there are some material which are sensitivity towards notches. For them we are going to define a factor known as notch sensitivity factor. Notch sensitivity factor is defined as increase in actual stress concentration over theoretical stress concentration, increase in actual stress concentration, increase in actual stress due to stress concentration to the increase in theoretical stress because of stress concentration. You know, we were knowing that sigma naught is becoming Kf times sigma naught in reality. Theoretically, we were saying sigma naught is becoming Kt times sigma naught. So if you, we will go for break. Don't worry. In after completion of this chapter, I will give you 10 minutes break. After completion of this chapter, okay, I will give you break. So by 11:15 we will have the break. Don't worry. So my dear, whenever we are talking about this sigma naught is Kf times sigma naught, this is actually, this is theoretically. So actual increase in the stress is Kf times sigma naught minus sigma naught. Theoretical increase in the stress is Kt sigma naught minus sigma naught, and that is said to be stress concentration, notch sensitivity factor. So if you are going to define notch sensitivity factor, okay, when we are going for notch sensitivity factor, you can write it as Kf minus 1 into sigma naught by Kt minus 1 into sigma naught. Sigma naught cancel out. So you can write it as Kf minus 1 by Kt minus 1. In gate 2 times the question have been asked where they have just asked which is the correct formula for notch sensitivity factor. Notch sensitivity factor. Now my dear, practically found notch sensitivity factor lies between 0 to 1. 0 for insensitive material, 1 for extremely sensitive material. When we are talking about insensitive material, when Q is 0, putting Q 0, you would be getting Kf barabar Kt. Putting Q is equals to 1. Putting Q is equals to 1, you would be getting Kf barabar Kt. Putting Q is equals to 0, you will get Kf barabar 1. So from here you can say Kf will lie between 1 to Kt. That's why when we are using the Kt in place of Kf, we are always going for the safe design. So considering Kf in place of Kt will always give us the safe design. Please tell me, am I properly audible, visible, everything is going fine? Are you getting it properly? Please tell me that. Please tell me that. Clear for everyone? Clear for everyone? So guys, do like and share the session. Everybody is fine. Things are going in a nice way. Are you getting it properly? Please tell me that. Okay, moving further. Now we are reaching to the most important part of the chapter from where all the questions are coming. Okay, just give me a minute because my phone is getting discharged. So let me put it onto the charger. Then we are moving further. Okay guys, so now we are talking about the fatigue diagram. It is very, very important. So my dear, actually some researchers, what they have done some experiments. They have taken different materials on which different loadings were given. Okay, Savi, it is required, that's why I am a teacher now. So when we are talking about fatigue diagram, actually fatigue is a phenomena of failure of a material much before its failure stress. Like if I give you a wire, let us say if I give you a wire, okay, let us say I am giving you a wire, and if I am giving you a wire like this, I say you need to fracture it. You have two ways. One is you will be applying tension onto that. Other is you will be bending it first like this, then like that, first like this, then like that. And you know, even if you have not studied the fatigue loading, even if you have not studied mechanical engineering, even if you are a 10th class student, you know that always when I am going to do this and that, that is going to be the easier way to break it. Because when I will be doing this and this, after some time the wire will fracture very easily. Okay, what is that? That is said to be fatigue. So my dear, that whenever we are going to apply the loading like this and this, you are going to change the magnitude and direction of the loading. Because of that, internal cracks will be generating in the material, and after some time material will be fractured at much below its failure stress. And that phenomena is said to be nothing but the fatigue phenomena. And when we are talking about the fatigue phenomena, many researchers have taken many materials, they applied different types of loading, and they tried to calculate or find out the failure points for them. So they have taken on y-axis the amplitude stress, on x-axis the mean stress, and they found out all the failure points like that. They found out the failure points like that. And my dear, this diagram which is having these failure points for different material under different loading, we call this diagram as fatigue diagram. We call this diagram as fatigue diagram. So when we are talking about the fatigue diagram, we could not use it like that. So some researchers have given some format of some curvatures which we can use it to get the design. And for that I would like to say, first of all, there was a researcher known as Soderbergh. So Soderbergh have taken a point on x-axis as SYT, y-axis as endurance limit, and he joined both the points, and this line is referred as Soderbergh criteria. And if you want to write the equation of this, you know that we are having x by a plus y by b is equals to 1. This is the straight line equation. So if you know x-axis is having mean stress, so sigma mean by SYT, then sigma amplitude by SC is equals to 1. And this equation we are calling it as Soderberg criteria. And when we are talking about Soderberg criteria, as it has taken the yield strength on the mean stress, it is found to be better for ductile materials. It is found to be better for ductile materials. And my dear, whenever we are talking about, you are going to consider factor of safety, then you will be putting SYT to be SYT by N. You would be putting SC to be SC by N. Then this equation will become sigma mean by SYT plus sigma amplitude by SC is equals to 1 by N. And this is the equation of Soderberg you would be going for designing purpose. Then my dear, another researcher came, the name was Goodman. And Goodman said ki okay, y-axis criteria is fine for me, but x-axis criteria should not be SYT, it should be SUT. And if we are going to consider the y-axis criteria SYT, this is said to be Goodman line, and this was found to be better for brittle materials. And my dear, when you write the equation for that, it is going to be just similar to the Soderberg, sigma mean by SUT plus sigma amplitude by SC is equals to 1 by N. This was for brittle material. And my dear, then one more researcher came, that was Gerber, and he have done Gadbad. What he said? He said ki no doubt the point selection was very good, but here it should not be straight line, here it should be a kind of parabola. And whenever he have given the parabola, it was found that some failure points were lied onto this. So that is why Goodman and Soderberg are more safer than Gerber. And even the lowest area is coming under Soderberg. So Soderberg criteria is said to be the most conservative criteria. And when you write the equation of this parabola, it is coming out to be this: sigma mean square upon SUT square plus sigma amplitude by SC is equals to 1. This time when you will be putting SUT to be SUT by N, when you will be putting SC to be SC by N, this time different equation will be coming. Different equation will be coming. Because here sigma m square SUT ka square. So because of that, here you will have N ka square. Here you will have only N. So here you cannot write the equation in the form of 1 by N. So this time the equation is coming as sigma mean ka square, N ka square, SUT ka square plus sigma A by SC into N is equals to 1 by nothing. This is the equation for Gerber. Till date there is no question on Gerber. Till date questions are coming only from Soderberg and Goodman. Is it clear for everyone? Is it clear for everyone? And I am telling you, when you would be joining the practice session of machine design, there I would also do some questions on modified Goodman. Okay, modified Goodman you can understand very easily with the help of a question. So in the practice session I would be doing the question on modified Goodman. थोड़ा बहुत प्रैक्टिस सेशन के लिए रखना भी जरूरी है ताकि आपको उसके लिए भी ललक रहे कि अटेंड करना है. Okay, so practice session I will tell you modified Goodman, because from actually in the syllabus if you see the questions are coming only from 3 criteria. Even once when question came from modified, it was actually from Goodman only. But still, by taking a factor of safety of 2, we will cover this in the practice session. Is it clear? Savi, I did not say more failure point. I say that failure points were present on the curve. For Soderberg and Goodman, when we are talking about, they are considering the less values, na? Look this is considering small values, this is considering slightly more value, then you are having, this is having much more value. So it would be having failure points onto this. We wanted a line which will not be having any failure points. Failure point should above that. But here failure points were coming on to that. Just like we have seen one theory of failure known as MDET. So actually it is giving us the exact points where failure are happening. But the point is we are not going to consider, if we have to decide, we will go for Soderbergh for ductile, Goodman for brittle. If examiner says to go by Gerber, then only we will go for Gerber. Otherwise we will not go for Gerber. Clear for everyone? Clear for everyone? Please tell me that. Clear for everyone? Are we ready for some of the question? So now we will see some of the questions. Okay, almost we have completed. We will take break by 11:10. 15 minutes break I will give you. And after break, we will once again meet to complete the other topics. So you can see this is a forged steel link with uniform diameter of 30 mm. Okay, I feel here some data is missing, yield ultimate and was not given. So let us solve this question. In previous question, some data was missing. So you can see here, a thin spherical pressure vessel diameter of 200 mm. Thickness is 1 mm is subjected to an internal pressure which varies from 4 MPa to 8 MPa. Assume yield ultimate and endurance strength are this. Find out factor of safety by Goodman's criteria. Okay. So my dear, you know for thin sphere, sigma circumferential is coming as PD by 40. And you know this sigma C will give you the minimum value when you will be putting pressure to be minimum. And sigma C will give you the maximum value when pressure will be maximum. Find out this. Then with these two values, you can find out the mean value. Sigma max plus sigma min by 2. You will get the amplitude value. Sigma max minus sigma min by 2. Okay. Then my dear, we would be having the Goodman equation. Sigma mean SUT. Sigma amplitude SC. 1 by N. This is how the question will be done. This is a 2-mark question of gate only. So in machine design, the good thing is question are straightforward. Like if you know the equation, you can solve it. If you don't know the equation, you cannot solve it. They are very straightforward. Okay, they are not going to be tricky much. Clear? Solve it and get the answer. Solve it and get the answer, guys. Solve it and get the answer. So we are going with the decent speeds. 3 hours we have completed the 2 biggest chapter. Theory of failures, introduction and fatigue loading about to complete. After break we will go for brakes. Okay, brakes chapter is very small if we go for exam point of view. Okay. And then we will go for the bearings, joints, gears, springs, shaft. Okay. Solve it and get the answer. Pressure is varying from 4 MPa, minimum and maximum pressure are given. They have given yield, ultimate and endurance. This is ultimate, this is endurance. Solve it. Very simple question. Solve it, guys. Solve it, solve it, solve it. Very good. 1.6 is correct answer. So n factor of safety will be coming out to be 1.6. Very good Vinay, very good Ashray. What about others? Very good Shreyas. Very good Shreyas. Wonderful guys. 1.6 is correct. Okay. Let us do this question. A rotating steel shaft is supported at ends. It is subjected to a point load at the center, because of which the value of bending stress is developed as 100 MPa. So you know that bending stresses whenever we are going to have. For bending stress, you know that sigma maximum and sigma minimum. If this is minus 100, this is plus 100. So this will be sigma max, this will be sigma min. If the yield ultimate and endurance limits are given, find out the factor of safety. Here they have not mentioned which criteria to be used. So always remember, if they are not mentioning, for ductile, steel will be considered as ductile material. Steel will be considered as ductile material. For ductile material, we will go for MSST. And cast iron will be considered as brittle material. For brittle materials, for ductile material, we will go for Soderberg. For brittle material, we will go for Goodman. So steel will be considered as ductile. So here we will go for Soderberg. What Soderberg says? Sigma mean by SYT, sigma amplitude by SE, then 1 by N. Go and use the equation. You know here sigma max is plus 100, sigma min is minus 100. First of all, find out sigma mean, then sigma amplitude, then apply the equation. Vinay have given the answer to be 2. What about others? Vinay have given the answer to be 2. What about others? Yes, guys. What about others? Very good. Everybody, you know that this is a completely reverse loading, for which mean stress is 0. So if this will be going to 0, you just need to have amplitude stress. And amplitude stress is going to be 100, endurance limit is 200, factor of safety is 1 by N will be 2. Very easy question from gate only. Okay. Now my dear, whenever we are talking about the effect of stress concentration, then if we are having two types of material, one is ductile, other is brittle. Whenever we have ductile material, then if the loading is static, then we are never going to take the stress concentration effect, because it is found to be negligible. But if the loading is fatigue, then stress concentration effect is considered. But if the material is brittle, then the loading may be static or fatigue. We need to consider the effect of stress concentration. Okay, from this you can get a theory question. Now we are going to see the last heading of this chapter is cumulative fatigue, that is said to be Miner's rule. This is the last heading of this chapter. After this we will take the break. Okay. So when we are talking about cumulative fatigue, as the name suggesting, I would first of all will giving you an example. Let us say you are living in Delhi and today you have seen the newspaper. In the newspaper it was written that the average age for the persons living entire life in the Delhi is 60 years. And when you have seen this data 60 years, and you think that today your age is 20 years, आपका माथा ठनका कि ये क्या? It means 1/3 of the life you have completed without doing anything, just during the studies or the childhood. You may be thinking that's very bad. I have only 40 more years. Then my dear, you have seen the other data of other city. You get to know the similar data when you have found for Dehradun was found to be 75 years. You were very happy to see that. Then you said, yes, I will go to Dehradun because there my life will be more. So you went Dehradun for the job and you lived there for 25 years. And you lived 1/3 of life there because 25 by 75. Now, my dear, you thought to go for the rest 1/3 of your life to the region where the maximum life will be there, and you went to the Uttarkashi, let us say, pahadon par, where you have seen the average age was found to be 100 years, or let us say 90 years. So you know the rest is 1/3. So you know you are going to live approximately 30 more years. And when you are going to live at different levels of cities like this, here pollution level was different, here pollution level was different, here pollution level was different. That's why this phenomena is said to be the phenomena of cumulative fatigue. This is cumulative fatigue. How we are going to study this in the stresses? Let us say corresponding to a stress of sigma 1, the life of the component was N1, like Delhi 60 years. But you lived there only for this much number of revolution. Then you have lived N1 by N1 part of your life, 20 by 60. Similarly, you were there for sigma 2, your component was there for sigma 2, for which the life was N2, but you lived only this much, so you have used N2 by N2 part of your life. Then you have seen the stress was sigma 3, corresponding to that life was N3, and you have used this much, so N3 by N3 was the part of the life you have used. And the summation of these should be 1, because zindagi na milegi dobara, so you would be writing N1 by N1 the first part of the life, N2 by N2 the second part of the life, N3 by N3 is the third part of the life. That should be equals to 1, and this is said to be the Miner's rule, cumulative fatigue failure. This is the topic from which, this is underrated topic, no question till date, but I expect gate 24 may be asking from this. Gate 24 may be asking the question from this. Okay, now my dear, I would like to tell you one wonderful thing, that let us say if we know the total life is N, then my dear, if that is N and you know that small n1 is alpha 1 times of N, small n2 is this alpha 1, alpha 2, alpha 3 are the fractions. Like in the previous example, you can say, let us say with this the total life is 20 plus 25 plus 30, 30 and 20, 50 and 25, this is 75. So this 75, if you want to write down 20 is equals to alpha 1 times of 75. So alpha 1 will be coming out to be 20 by 75. So that is how I am defining that N1 is alpha 1n, N2 is alpha 2n, N3 is alpha 3n. If you will put the value, you will get alpha 1 by N1, alpha 2 by N2, alpha 3 by N3 upon 1 by N. Is it clear for everyone? This is nothing but the cumulative fatigue failure, my dear. It is also said to be the Miner's rule. With this, the chapter of fatigue loading is over. Now let us solve one question on SN diagram. After this question, we will have the break, and after the break, we will have the next chapter, chapter number 3. So you can see this question they have given. A cylindrical shaft subjected to an alternating stress. This is the sigma value given. Sigma star is given. Fatigue strength for 1000 cycle. This is 0.9 times of SUT value directly given. Corrected endurance, this is SE given. SE star given. So you know that we would be making the diagram. This is the diagram. So this value is log 10 given as 490, and this value is log 10 70, and they have said this is 3, this is 6, and they are asking somewhere here log base 10 100, what would be the life here? Let us assume x. Okay, so you know what to do. Once again you need to go for the similar triangle like this versus this, and you need to find out x. Once you get x, you will equate log base 10 n is equals to x. You will get the number of cycles or life. This is how you can solve this question, and this is a perfect question for SN diagram. So we have done all the types of question. Yes, everybody, are you enjoying this? The way we are going fast and furious, neither leaving anything and going at a very good pace, covering one-to-one questions of each type. Everybody is clear? Please tell me that. Solve it guys, solve it guys, solve it guys. After this question, 10 minutes break, 15 minutes break is coming, don't worry. And don't sleep before we complete machine design, okay? And I feel we will be able to complete within the time. We are going very nicely because in machine design we have nothing like theory, only concepts related to the numerical sergeant. Like in brakes, only two types of questions, okay? Tell me guys. I am telling you how to write log base 10 490 minus log base 10 70 6 minus 3 log base 10 100 490 100 x minus 3. From here find out the value of x. From here find out the value of x. Yes, very good Vinay. The value will be coming out to be 5.45, but they need the answer in cycles equated with log base 10 n. So n will be coming out to be 10 to the power x. That is your answer. 10 to the power x is 281914 cycles. B would be the right answer for this question. Clear for everyone? Clear for everyone? Please tell me that. Okay, so guys, with this we have completed. Now okay, one more thing is method to reduce the effect of stress concentration. So like whenever you are going to have the problem with the notches like this. So the problem with the notches was because stress lines were passing like this. But if we make the additional notches here, then stress lines will go straight. So there will be no stress concentration. Likewise, you can also make some holes here because this much part is already having the minimum area. So even if you create hole, this will not affect adversely. Then if you are going to have abrupt change of area like this, you can provide it with the fillet. With the fillet, the effect of stress concentration will get reduced. Okay. So with this we have completed this. Now we are moving to the next chapter. These all questions you can do very easily. Okay, all these are the questions. We are going to do them in the practice session, don't worry. Some are repeated questions also, don't worry. Okay. So guys, now we are moving to the next chapter. So should we take break here? Should we take break here before breaks? 15 minutes or 10 minutes? 15 minutes or 10 minutes? Ten minutes. Okay. So class will resume at 11:25. And we would be starting the next chapter, that is brakes. Okay. So just within 10 minutes I am coming back. Okay, so be ready. Next chapter is brakes. After brakes we will go for bearing. After bearing we will go for joint. Then last chapter will be gears. Okay, we will go as per the exam point of view. Okay, don't worry, we will not go for that theory which is useless. Only exam point of view. So मिलते हैं 10 मिनट के बाद. Okay. So guys, are you ready? Shall we start once again? Do like and share the session. So guys, when we are talking about the brake, the next topic, brakes. Brake is said to be a mechanical device which is used to absorb the energy possessed by a moving system or mechanism by means of friction. Whenever we are talking about the brake, generally students have one feel that some car is moving, I want to stop it, I will apply the brake. So they feel that brake is used to absorb the kinetic energy of the system and to change the state of motion of the body from motion to rest. And some people will also be knowing that yes, it can also be used to deaccelerate the body to reduce the speed. Yes, it is used to stop the body, it is used to reduce the speed of the body, and also, my dear, we can use it to hold the body. Like whenever we are talking about lift and escalators, like in the lifts, whenever you are going for 4th floor, you put the button, lift is opening at 4th floor. Lift is going to be stable there until you go out of the lift. After that, lift will be getting close. So at that time, potential energy is going to be there. Okay. So brakes are going to absorb potential and kinetic energy both based on the requirement, and then they are going to provide you the desired state of motion of the system, whether it is at rest or it is reduction in speed or it is holding at some particular level. So these are the brakes. So my dear, when we are talking about the brakes, brakes can be defined as mechanical brakes, electrical brakes, hydraulic brakes and pneumatic brakes. Then my dear, when we are talking about this pneumatic, hydraulic and electrical, these three types of brakes are used for high power transmission or high energy systems, okay, for high energy absorption. So that is why we are not going to study these here, because we are here interested in only in mechanical brakes. So when we are talking about the mechanical brake, we are going to study only the mechanical brakes here. Then mechanical brakes are going to be classified as radial brakes and axial brakes. So in axial brake, generally we have the disc brakes. So if we are going to have a thing, let us say something is rotating like that. If you want to stop it, for stopping it, if you are going to apply the force in the radial direction like this, then we call them as radial brake. But you know, for this, the second way to show is this. So if you are going to apply the force here to stop it, then we call them as axial brakes. And in our syllabus, we need to majorly talk about the radial brakes. And in radial brake, we are having shoe brakes, we are having band brakes, we are having shoe band brake. Here also we need to concentrate only on these two. Then when we are talking about the shoe brake, we are having small shoe brake, we are having long shoe brake. Here we have simple band brake, we have differential band brake. So when we are talking about these brakes, in our syllabus only these 4 types of brake we need to study. Even from these 4 types, if you will see the previous year's trend, questions are only asked from small shoe brake and simple band brake. Questions are coming only from these 2 types of brake. Is it clear for everyone? So now we are going to start with the single shoe brake, how it is going to act like that. So when we are talking about the single shoe brake, here this element shoe is also known as block, and this is the element which is going to provide the friction to the rotating element. So for that purpose, shoe is always having a friction lining. We are going to provide the friction lining majorly of 2 types of material. One is asbestos, other is Firodo. These are the 2 materials generally we are using for the brake friction lining. And when we are using this friction lining, then my dear, this friction lining is how it is going to stop. I am showing you. This is the drum which is rotating like this, and this is the block or shoe, you can say. This is the lever. So when you will be applying the force here, this shoe will be coming in contact with the drum, and it will provide the friction, and with that it will be able to stop it. Okay, you can see this is how it is rotating. Now my dear, the point is, whenever we are going for this analysis, in brakes there is nothing called a formula. We just need to go for the engineering mechanics analysis, like putting the summation, moment, zero and all. So you need to understand here the procedure of solving. Here there is nothing like the formula you will be remembering. Okay. So when we are talking about this case, first of all, this is the small shoe. Small shoe means it is going to withstand the angle which is 2 theta. If this 2 theta is less than equals to 45 degree, we call it as small shoe. And if the angle is more than 45 degree, we call it as long shoe. So my dear, whenever we are talking about the small shoe, I would also like to tell you here, this shoe is going to be welded over the lever. So it is having the permanent welded joint. So this shoe can be considered as the part of the lever only. And my dear, you can see the distances. Okay, I am going to predefine it. This distance is B, this is A, and this distance is C. You can see for that. So my dear, first of all, if I am going to consider this brake drum, this drum is rotating with the speed omega in this way. So you know that at the point of contact, we would be having a normal contact force N. And as it is rotating like this, on this friction force will be coming like this, which is mu N. So because of that, you can write the braking torque as mu N R. R is the radius of the drum. So my dear, this is the free body diagram of the drum I have made. Now I will also show you the free body diagram of the lever. If you see the free body diagram of the lever, I am showing on this diagram only. You know, here a contact force N will be acting like this. And as mu N is acting on this by Newton's third law, mu N will be coming like this here. Now you need to take the summation moment about this point O to be 0. So when you will be going for summation moment about O to be 0, what you will be getting, I am showing you that. You can see this F is creating anti-clockwise. So minus F into A plus B. Then this N is going to create clockwise. So plus N into A. Then mu N is going to create anti-clockwise minus mu N. I feel N into A, mu N into C. Equate it to 0. So when you will equate it to 0, what we are getting? We are getting F A plus B is equals to N A minus mu C divided by, A minus mu C. If you see this from here, you can write F is equals to N A minus mu C divided by A plus B. This is the braking force required. My dear, here if you are going to say this as braking force requirement, if you are going to say that A is more than mu C, then you would be having the braking force requirement to be more than 0. If you are going to put A as equals to mu C, then braking force requirement will be coming out to be 0. If you put A as less than mu C, then braking force would be coming out to be less than 0. Are you getting it, guys? Are you getting it, guys? So when we are doing this, you need to understand in this way that when we are saying A is equals to mu C, braking force is coming out to be 0. What do you mean by that? That without applying the brake, it simply means that without applying the brakes, brakes will work. We never want this condition. This condition is said to be self-locking. Just imagine you are sitting in the car and automatically brake is going to be applied. We never want this condition. This is the condition when braking force is coming out to be negative. It means maybe if you are putting your foot onto the brake, maybe you are getting the reverse force. So that is said to be the uncomfort. And both these conditions are undesirable. We never want these conditions to happen. And when we are saying A is more than mu C, this is said to be the self-energizing brakes. Why we are calling it self-energizing brake? First of all, we want whenever we apply the brakes, then only the brake should be working. So that is why braking force requirement should always come more than 0. That is for sure be required. But why we are calling it as this self-energizing? Because if friction is 0, if mu is 0, then braking force required would be Na by A plus B. But when mu is non-zero, then F is Na minus mu Nc divided by A plus B. So you can see this force and this force, F1 is more than F2. So because of friction, our force is coming lesser. It means this time friction is helping us. So whenever friction is going to create the moment in the direction of applied force, we call it as self-energizing condition. You can see here that our force is also creating anti-clockwise. This mu n is also creating anti-clockwise. Whenever you have the same direction of movement by both friction and our applied force, we call friction is a friend of ours. Friction is helping us, and we call the such condition as self-energizing condition. Here friction becomes our friend. This is friction is helping nature. Okay, you can see in the railway wheels we are using this type of brakes. You can see this is the shoe. So in the railway wheels we are using them. In the railway wheels we are using them. Okay, now my dear, whether you would be getting self-energizing or you would be getting self-locking or you would be getting uncomfortable condition, it depends on three things. The very first thing on which it depends is the value of A, B, C and mu. Second thing, it is depending on the direction of rotation. Direction of rotation of drum. Because my dear, in our example, we have taken drum rotating clockwise. If your drum is rotating anti-clockwise, the things will reverse. If the drum will rotate anti-clockwise, your normal reaction will remain here only, but friction will be coming here. If here friction is in this side, here friction will be in that side. If friction will be on that side, this time when you will write the equation, this F is anti-clockwise. You will write minus F into A plus B. This N is clockwise. You will write plus N into A. But this time mu N is creating clockwise. So this time mu N is also plus. And it is going to be equals to 0. This time force will be coming out to be N into A plus mu C divided by A plus B. This time friction is not helping us. This time friction is helping the normal reaction force. So my dear, that is why this is the condition when friction is not of helping nature. Just by the change of direction of rotation, friction changes its pala. कहते हैं ना, pala बदल लिया. Friction have changed its side. Previously it was supporting India, now it is supporting Afghanistan. Okay, so this is how the things are going to vary. Is it clear for everyone or not? अरे भाई कुछ कमेंट करके बताओ, आ रहा है नहीं आ रहा है, मुझे नहीं पता लग रहा कुछ. Tell me, tell me, tell me. Are we getting everything? Please tell me, guys. Wonderful, guys. Wonderful, guys. So this was about the single shoe, small shoe brake. Now we have the double shoe brake. Whenever you have double shoe brake, you just need to write the braking force requirement. Whenever we are going to write the braking torque requirement, whenever you are going to have, it is mu n n1r plus mu 2 n2r. Because this time you would be having two drums, two shoes, so two mu n's, mu 1 n1r plus mu 2 n2r. This is going to be the braking torque. Then my dear, if you are going to have long shoe, actually there is a story for long shoe. Okay, but we will not go for the story right now. One reason is long shoe is not coming in the paper. Second thing is, here we are having marathon, we are not much interested into the detail of that. So when we are going to have the long shoe or small shoe, what is the difference? If 2 theta is going to be more than 45 degree, we call it as long shoe. And when 2 theta is coming out to be less than 45 or equals to 45, we call it as small shoe. Whenever we have the small shoe, I have already told you, shoe is just welded over the lever. But in long shoe, we are not going to weld it, we are going to provide it in the pivoted form. Like if you are going to have long shoe, then long shoe will not be provided like this welded, but it would be pivoted. So how pivoted? If this is the lever, long shoe would be pivoted like that. Because otherwise long shoe would be getting wear out very soon. So whenever we are using the long shoes are made pivoted, because otherwise if you are going to find out the pressure distribution, they are not coming out to be linear. So pressure distribution are coming out to be like this. So to make them nearly linear, we are going to provide them in the form of pivot. When you will provide pivot, then with the pivot, the pressure distribution will be coming nearly linear. Because if pressure distribution are not linear, at some places it is going to wear out very fastly, which we never want. Is it clear? So guys, this is the reason for that. I feel we have seen the reason for that. Now one more thing I would like to say, here braking torque is coming out to be mu nr. I am writing here mu nr. But for long shoe, the braking torque will be coming out to be mu nr into 4 sine theta divided by 2 theta plus sine 2 theta. And when you are writing here 2 theta, this should be in radians. And I feel everybody knows this angle is 2 theta. This is the story of long shoe. Everybody understood? Everybody understood? Everybody understood? Everybody understood? Please tell me that. Everybody understood this? Moving further, guys. Moving further. Now, my dear, we are having the band brake, the second and last type of brakes. When we are talking about the band brake, first of all, you need to understand, here we are having a band of steel. Okay? Like you can consider, like if I am having a hanky like this, then you can consider this hanky as the band. Like this is the band. Okay? And if let us say my hand is the rotating drum, then it would be coming on to that and it will try to hold it. It will try to apply the brake because it is having some friction surface. So when we are talking about this brake drum is rotating clockwise like that. So it was rotating clockwise like that. There is no problem. But we have provided a steel band. And when we are going to provide this steel band over it, that steel band is also having the friction lining in the inside surface. So when it is having the friction lining in the inside surface, you should be aware that obviously it will resist the motion of this drum. And then we are going to connect it with a lever. Like this. Now my dear, if one end of the band is connected with the pivot and other end is connected with the lever, we call it as a simple band brake. And if both the end of this band are connected with the lever only, then we call it as differential band brake. Till date, whatever questions are asked in the paper, they are from simple band brake only, but we will cover both of them. So my dear, how this time we will be finding out? This time, my dear, you can see your drum is rotating with some angular velocity like that. And on this drum, you have applied the band. You know that if it is going to rotate like that, then in the band we would be having some tensions acting like that. And you know, here as we are going to have the friction present. If friction is not present, tension remain the same throughout this band. But because of presence of friction, we would be having different tensions on both the side. Maybe this tension is T, this tension is T dash. And you know the relation between the tension is given as T1 by T2 is equals to E to the power mu theta. Here mu is the coefficient of friction, theta is the angle of wrap. So my dear, but for that what we want actually? For that, what we want actually? That I will tell you. But otherwise I am telling you till date, if you see, there is no question from the design. Okay, I will tell you if you want, but till now there is no question on the design of shoe. Okay, but I will tell you if you want. So when we are talking about this angle theta, T1 by T2 is going to be e to the power mu theta. Theta is nothing but the angle of wrap or wrap angle. Then my dear, you need to understand one thing. Like if this is the center and this distance is the radius, this distance is the radius. So if you want to write down the braking torque, you must understand first of all that if it is rotating in this way, then this tension is going to stop it and this tension is supporting it. So obviously this tension should be more. So braking torque will be coming out to be T dash R minus TR. So for sure this T dash is going to be T1 and T is going to be T2. So you can write it as T1 minus T2 into R. So we are going to say T dash will become T1, T will become T2. Everybody understand about the braking torque? Braking torque is T1 minus T2 into R. But if you want to go for the equilibrium about this point, so you can see here force F is acting, here some tension, here some tension. You have just seen this is tension T1. So this is tension T1. This is tension T2. Take summation moment about O to be 0. You know T1 is passing from center only. It is passing from pivot only. So there is no moment because of T1. T2 is creating anti-clockwise. F is creating clockwise. So you can write F into A is T2 into B. So braking force required is T2 into B by A. So is it clear, guys? This is the analysis of simple band brake. Clear for everyone? Ajay, Shreyas, Akhil, Savi, Shreyas. Please tell me, everybody understood? Everybody understood? This is something called as simple band brake. Now my dear, when we are talking about the differential band brake, what is that? When we are talking about the differential band brake, what is that? Differential band brake is when you are having both the ends of the lever are joined, both the ends of the band are joined with the lever. If both the ends of the band are joined with the lever, we call it as differential band brake. And you can see this distance from the centroid is B1, this is B2 and this is A. And you know, first of all you need to see the drum. Drum is rotating like this. If drum is rotating like this, you know one tension is here, other tension is here. This time you will tell me out of T and T dash which one is T1, which one is T2. This time you will tell me which one is T1, which one is T2. You need to just check if this is the rotation, this should be the braking torque direction. So if that is the braking torque direction, obviously which one should be bigger? T should be bigger. T dash should be smaller. So this will become T1, this will become T2. So once again you can write the braking torque is nothing but T1 minus T2 into R. And we already know one relation, T1 by T2 is equals to e to the power mu theta. And if you know two relation, third relation we would be going for, yes Kusum, hi, we would be going for summation moment about O to be 0 if this point is O. You know that here tension will be acting in this direction, this is T2. Here tension will be acting in this direction, this is T1. So you can see summation moment about O to be 0. This is creating clockwise, so T1 B2. This is creating anti-clockwise, minus T2 B1. And this is creating clockwise, plus F into A is equals to 0. So you can write here F is equals to, or F into A is equals to T1 B2 minus T1 B2 plus T2 A1, T2 B1. So you can write F into A, T2 B1 minus T1 B2. If you see this, once again you will be getting three conditions. If T2 B1 minus T1 B2 is equals to 0, you will get self-locking. If T2 B1 minus T1 B2 is less than 0, uncomfortable. And if you are going to have T2 B1 minus T1 B2 to be more than 0, it is self-energizing. And you know that we want this condition. So T2 B1 should be more than T1 B2. B1 by B2 should be more than T1 by T2. T1 by T2 is nothing but e to the power mu theta. So B1 by B2 more than e to the power mu theta is the desirable condition. Is it clear for everyone? Shreyas, Vinay, Akhil, Savi, Ajay, please tell me, everybody is okay with this? Everybody is okay with this? Please tell me, guys. Is it clear or not? Please tell me. Yes, yes, yes. So guys, now we are moving for one more thing, that is design of shoe, like someone was asking. So if we are talking about the shoe, this is the shoe and this is the friction lining. You already know on the shoe we are going to have a normal reaction acting like this. This angle is 2 theta. This is radius r. And let us say width of this shoe is B. So you can write the induced pressure in the shoe is nothing but force but a area. What is area? This is r into 2 theta into B. That should be less than equals to the permissible pressure. So obviously question are not coming from that in GATE. This is asked in ESC conventional. So here you would be getting N should be less than equals to R into 2 theta into B into P permissible. This is the permissible pressure which the friction lining can bear. So you can write the N maximum. The maximum value of normal reaction possible is R into 2 theta into B into P permissible. Is it clear for everyone? Please tell me that. This is how we can design the shoe. Okay? Clear? Fine. I feel everybody understood. Now, my dear, we are going for springs. But before that, let us see some questions on the brakes. Because whatever we have studied, the theory of brake is over. And now it's time to say good morning. Okay? Time is 12. I already told you other chapters will not take time. Whatever time would be taken, that is taken by fatigue loading and theory of failure. You can see we have completed brakes in 30 minutes. Savi, for that, just do one thing. Okay, for that you need to do one thing. You need to revise it for 3, 4, 5 times. And I don't know whether you have that opportunity or not, but I am telling you how the things became easier for me when I was preparing. Because when I was preparing at that time also I was teaching to my friends. Like there were some friends of mine, like they were studying for, like some of them were not affording the coaching. So I was teaching them. Or second thing is you need to go and revise again and again. Okay, 4, 5, 6 revisions. Okay, sometime I used to teach alone. There is no person, I am teaching someone. So when you are teaching someone, it is becoming easier for you. And while teaching, you get to know where is the problem. Maybe the person may or may not ask you, but you will know what is the problem. Okay. But right now, as time is less, I will suggest you to go for the revisions, practice, PYQ. Okay, nothing more than that. Clear? Shall we move further? Shall we move further? Yes, Savi, is it clear? Fine. Vinay, Akhil, Dhanesh, everybody is okay. Now you need to do this question. The force is F1, F2 in a brake band. The direction of rotation of the drum is shown in the figure. Coefficient of friction is 0.25. Angle of wrap is 3 pi by 2. It is given that R is 1 meter, F2 is 1 Newton. You need to find out the torque. So you know this is rotating like this. And they have given this is F1. This is F2. You know that braking torque F1 minus F2 into R. And you know F1 by F2, e to the power mu into 3 pi by 2. So from this equation, F2 is already given. You can find out F1. Put it here, you can find out braking torque. This is the previous year's question of gate only. Ajay have already given the answer as 2.24. Very good. Very good. This is the question from band brake in gate. Very easy question. Sometimes they are also asking from the formula of T1 by T2 e to the power mu theta. Be ready for that type of questions as well. Clear for everyone, guys? Clear for everyone, guys? Very good, Vinay. बहुत बढ़िया. Wonderful. हाँ भाई, Akhil, Dhanesh. Clear for everyone? Moving further to this question from shoe brake. Let us solve one question from shoe brake as well. A drum brake is shown in the figure. Drum is rotating anti-clockwise direction. The coefficient of friction between drum and shoe is 0.2. Dimensions are given in the figure. Find out the braking torque. You can see this is rotating like this. So when you will be making the free body diagram for this, here will be the N, here will be the mu N. And braking torque will be coming out to be mu N R. And here if you will make the free body diagram, normal reaction on the shoe will be here, mu N will be here. You need to take summation moment O to be 0. Solve this question. Summation moment O to be 0. So you can see this 1000 is creating anti-clockwise. Minus 1000 into 800. This is clockwise. Mu N is clockwise. This will give you the value of N. If you get the value of N from here, you can find out the braking torque. This is a wonderful question, guys, from the brakes. This is also a previous year question of gate. Solve it. Solve it, guys. Clear, guys? Everybody understood? No, check Ajay. It is not correct. Check it. Answer is not correct. First of all, you need to find out N from here. Once you will find N from here, then put it here, you will get braking torque. Solve it, solve it, solve it. Solve it, guys. solve it guys. अरे भाई विनय अजय क्या कर रहे हो भाई? म्यू इज गिवन, यस 64 is correct. 64 Newton meter is correct. Very good अजय, वंडरफुल विनय, बहुत बढ़िया. धानेश, अखिल, वेरी गुड, बहुत बढ़िया. Moving further guys, this was okay. One more question from band brake. A force of 400 Newton is applied to the brake drum 0.5 meter dia in a band brake system as shown in the figure where wrapping angle is 180 degree. If the coefficient of friction between the drum and band is 0.25, find out braking torque. You know it is rotating like this. So obviously this will be T1, this will be T2. T1 is already given to you. First of all, use T1 by T2 e to the power mu theta. Theta is pi. Always put it in radians. You will get here T2. Once you get it, braking torque is nothing but T1 minus T2 into R. You can see very easy questions are coming from this chapter. Okay. No issues, Vinay. Solve it, solve it, solve it, solve it, solve it, solve it. Tomorrow, which subject you want the practice session? Tomorrow, which subject practice session you want? Shall we go for casting welding or shall we go for machine design? As term is not yet over, so we will go for either casting welding, sheet metal operation, or machine design. Tomorrow, which practice session? Shall we go for machine design because today we are discussing it? Tomorrow night let's practice machine design. Okay, Ashray is saying casting. Okay. Let us see what about others. Okay, what you are getting is braking torque. Shreyas, 54. Everybody is saying 54.5. Very good. Very good guys, बहुत ही बढ़िया, wonderful. Moving further. Okay, now I feel we shall go ahead to the next topic because we have done a lot on this. So guys, next chapter we would be going ahead and I am thinking to go for not for the joints right now. Now we will go to the next topic. I feel bearings will be the good choice. Joints we will do at the last. Okay guys, so now we would be talking about the bearings. Okay, now we would be talking about the bearings. Saurabh Nandi, okay, I am telling you maybe tomorrow, not tomorrow, tomorrow, day after tomorrow, there would be a session coming in the video section of this channel that is related to calculator. Okay, how to use gate calc effectively. There I will show you how to do this type of calculation. Actually I have taken 40-50 things to tell you in that. So you see that 1 hour lecture and that will give you each and everything whatever you are looking for. Okay, so just wait for one more day. Okay, by tomorrow or day after tomorrow morning you will get that session. Okay, definitely there is no problem. Now my dear, we are talking about the bearings topic. Now we are talking about the bearings topic. So my dear, whenever we are talking about bearing, first of all we need to understand actually what bearing is. Okay, bearing is very important topic. First of all I would like to tell you, and every year we are getting one question from bearing for sure. So this is most important one. That's why before joint I am going to bearing. Okay, so after bearing we will go to joint. After joint we will go to then that gears and springs. Okay, so majorly bearings and joints, these two are the big chapters. Now whenever we are talking about the bearings, my dear, bearing means something which is going to bear. Like earth is there, let us say we have a earth and there is a block. We have earth and block is there on the earth. And my dear, let us say this block is a moving body. So you know that block is moving, earth is rest. Block is moving, earth is rest. Or you can say earth is stationary. And this stationary earth is going to support this moving block. So my dear, whenever we are having two bodies in contact, out of which one is fixed, other is moving. Whenever we have two bodies in contact, out of which one is fixed, other is moving, and fixed one is supporting the moving one. Fixed one is supporting the moving one. Fixed one is supporting the moving one. Then my dear, fixed one is said to be bearing with respect to moving one. This is the bearing. Okay, so my dear, but here we are not going to discuss here that type of bearing. Here we are going to talk about a bearing with respect to shaft. Like let us say we are going to have a bearing, okay, and in this bearing we would be having a shaft like this. Now my dear, whatever weight is coming on to the shaft, those weight are definitely going to be beared by the bearing. Bearing is fixed, shaft is rotating or moving. So when we are defining bearing with respect to shaft, bearing is a fixed element which is going to support the moving element shaft in such a way that it is not allowing it to move in the direction of the applied force and also confining its motion. Because shaft cannot go beyond the bearing, it will be moving inside the bearing. So we also call it is also confining the motion. Bearing is a very big field which is related to tribology. But here we are not talking about that. We are going to talk only about the bearing with respect to shaft. Other things are not in our syllabus. So my dear, bearings are classified into two categories. One is sliding contact bearing, other is rolling contact bearing. Rolling contact bearing we will see as a separate chapter. First of all, we will talk about sliding contact bearing. Sliding contact bearing can be sleeve bearing, can be sleeper or guide bearing. Sleeper or guide bearing I have taught you in the theory of machines. Whenever we are talking about this, if you remember, this was external combustion engine. So when I have taught you the external combustion engine, you would be knowing I called this as sleeper or guide bearing. So this is the sleeper or guide bearing. But these type of bearings are not in our syllabus, so forget about them. So we need not to go for these bearings. We are interested in sleeve bearing. In the sleeve bearing, it can be classified in three ways: with respect to load, with respect to lubrication, with respect to configuration. My dear, if bearing with respect to configuration we are talking about is, it can be in a single piece, it can be in a multiple piece. If we are having the bearing in a single piece like this, like I have made like this, then we call it as solid bush type of bearing. But if we are going to make the bearing in two parts like this, then we are calling it as split bush type. Then we are calling it as split bush type. And my dear, whenever we are talking about with respect to load, it can be defined as radial load bearing or axial load bearing. What is radial and axial load bearing? My dear, if bearing is going to withstand this radial load, this load is in the direction of radius, then we are calling such bearings as radial load bearing. And if we are going to have a shaft like this, and force on the shaft is coming like this, if the bearing is bearing this load, we call it as axial load bearing. So I would like to tell you, in our syllabus majorly radial load bearings are there. Axial load bearing we need not to study, but we will study because the same formulas are going to be used in the clutches. So my dear, isko laga dala to live jinga lala. If you have studied this type of bearing, automatically clutches will be studied. Automatically clutches will be covered. We need not to go for separately clutches. Okay. So my dear, when we are talking about this, radial load bearing, then radial load bearing can be defined as full journal bearing, fitted journal bearing, partial journal bearing, that we will see one by one when we will go for this type of bearing. Similarly, when we are talking about the last classification, that is with respect to lubrication, this we are going to discuss here. About this we will see in detail in the upcoming slides. What is with respect to lubrication? Lubrication is the science of reducing the friction by providing a lubricant. So my dear, whenever we are talking about lubricant, there are some application like food processing industry. There are some application like food processing industry where we cannot use the liquid lubricant. Okay, because it can produce some kind of smells in the food. So here we cannot very easily use the lubricants. So for such cases, we are not going for liquid lubricant, but we are going to use the solid lubricants, or we are going to add the lubricants in the shaft material itself. The example of solid lubricants is nothing but, you know, HCP elements, molybdenum sulfide. We are going to have molybdenum sulfide. We are going to have graphite. So we can add them into the shaft material itself and they are acting like lubricant. So my dear, in that case we are not going to provide any additional lubricant. But at the same time, I would like to tell you, sometimes like tool slides are there, lathe machine. You are having shutter of the shops. There you are going to use grease. Grease is going to be semi-solid lubricant. But my dear, in this case, metal to metal contact is present. Metal to metal contact is present. It is not avoided. So what I want to say here actually, कि whenever we are having food industry, we use solid lubricant. Grease is used for the metal to metal contact is always there. It is used as a semi-solid lubricant in the machine tool slides. But my dear, in the bearings, we are generally going for the liquid lubricants. So in the bearing, we are going for liquid lubricants, and I am going to say that solid lubricants are also known as zero film lubricant. Semi-solid are also known as thin film lubricant. So in the bearing, we are going to talk about liquid lubricant, which is said to be thick film lubricant. They are of two types. One is hydrostatic, other is hydrodynamic. And now we are going to enter into this part. Are we ready for that or not? Now, one by one, we are going to see all the types of bearing. I have just given you the introduction of the bearing. Rolling contact bearing, we will see separately. Okay. There we will see separately these two things. Is it clear for everyone? Danesh, it will be coming on Tuesday morning. Tuesday morning it will be coming. Don't worry. So guys, now one by one we are going to see this. First of all, we are starting with the axial load bearing. Okay, so axial load bearing are divided into two parts. One is pivot or footstep bearing. Other is said to be the collar bearing. So you can see footstep bearing. This is the shaft. And this is the bearing surface you can see. Then my dear, if you are having this shaft can reciprocate also, and this shaft can rotate also. But we are going to have the axial load always acting onto the shaft. So because of the axial load always acting onto the shaft, always there is a contact maintained. So my dear, whenever this force is coming, this shaft now can only have one motion, that is rotation. And as this surface is going to support this rotating shaft, we call it as a bearing. And why we are calling it as footstep bearing? As the bottom part is going to be in contact. And this is the friction surface which is going to be resisting this axial force coming onto this. And this type of bearing we are calling it as flat pivot bearing. And my dear, similarly, if we are going to have the surface of bearing like this collar, we call it as conical flat bearing. You can see conical pivot bearing. And here the load is coming axially, not radially. So that is why we are calling it as axial load bearing. Similarly, you can see if we are going to have a shaft like this. On this shaft, this collar is welded like this. I already told you collar is the part of the shaft. This is the shaft. This is the shaft. Yesterday we have discussed all these things in the theory of machines. Now my dear, if you are going to provide the bearing surface like this, now this diagram you need to understand actually how the things are going to happen. This is the example of collar bearing. And why we call it as axial load bearing? Because load is acting in this direction like this. And when the load will be acting here, I feel everybody understand that this collar will be coming in, this is the collar and this is the bearing. And my dear, if you don't have the idea of this properly, I am going to make this diagram. This shaft is like this. Okay, just wait. We are going to have, just wait yaar. We are going to have like this. This is the shaft going on. And then we are having the bearing, this is the collar like this. Collar is going to be like this. So you can feel it. I feel I have some diagram here. I don't have any diagram. Okay, just wait. But I feel you can understand it very easily. That whenever we are going to have this collar is having a thickness of T. And this collar is also actually circular like this. This diagram will give you a clear feel. This is the collar. Can you feel it now? Can you feel it now? Like this it is having. This is the collar. Is it clear or not? Please tell me that. So my dear, when we are talking about this collar, whenever we are talking about this collar, when you will be applying the force, this collar will be coming in contact onto the bearing. And this bearing is also a circular surface. So whenever you are going to say this bearing, if I will show you, the bearing surface is going to be like this. This white one is the bearing. Then my dear, this yellow one is the collar. And this green one is the shaft. So I am saying the shaft is having a radius of Ri. Collar is having a radius of R0. So if I ask you that which part of the shaft and collar is in contact, can you feel that this is that blue part? Whatever this blue part I am showing, that is the part where collar and bearing will be coming in contact to each other. So you can see this is the shaft, this is the bearing, it is a welded plate over that, this is the collar, this is shaft, this is collar which is a welded plate, and this is bearing. When the force is applied, this collar will try to go like this, but this bearing will not allow to go. Can you feel it? So bearing will not allow to go like that. Okay, so this is how the collar bearing is going to work. Everybody is getting it or not? Please tell me that. Everybody is getting it or not? Please tell me that. So this force which is coming, let us say this is W, this is the axial load, and this force is beared by this area. This is R0, this is Ri. Is it clear? And my dear, when this is the case, I would like to say, let us consider a small radius. Let us consider a small ring of dr thickness. when you are going to consider a small ring of dr thickness at a radius of r, then the area of this small ring can be written as 2 pi r dr. And my dear, if you want to write down the force which is coming onto this ring, that is pressure into delta A. So we can write the small force beared by that small area is nothing but P into 2 pi r dr. Then the small friction force is nothing but mu times of small force. It is mu times of P into 2 pi r dr. And my dear, if you want to write down the frictional torque, because you know this shaft is rotating as well. So because of rotation, the frictional torque will be coming. So that small frictional torque is nothing but small frictional force into that radius r. You can write it as mu P 2 pi r square dr. Is it clear or not? Please tell me. Till this point, everybody understood or not? It is required. You may be thinking, sir, you were saying I will not go for derivation. What is this? Dear, because questions are being asked where you will be requiring these expressions. After that, integration you can do by yourself. Okay, but these things, whatever I have written, was required in many of the questions I have seen. So from here, what you will do? From here, my dear, we are going to divert that there are two theories given. And my dear, what are those theories? The very first theory says that uniform pressure theory, where it says pressure is going to be constant. When we are going to take the pressure to be constant, then my dear, you are going to write down the frictional torque by integrating the small fractional friction torque from Ri to R naught. Because in this previous expression, only R is variable. All other things are constant. So now whatever expression I will give you, that you need to remember for clutches as well. Because if this is completed, clutch is completed. For this, the frictional torque will be coming like this. It is 2 by 3 mu W R naught cube minus Ri cube by R naught square minus Ri square. This is the expression for frictional torque. Now my dear, here W can be written as P into pi R naught square minus Ri square. So if you want W is there. W is the axial load. W is the axial load. Is it clear for everyone? These are the expression for uniform pressure theory. So if in the question it is mentioned that pressure is uniform, you will go for uniform pressure theory, which says frictional torque is this, axial load is this. Only these two formulas will be required. Nothing more than that will be required. Till this day, 100% questions are being asked from this expression. And these expressions are equally valid for clutches as well. Because in your syllabus, we are studying this for clutches, not for the bearings actually. So when I am teaching this, I am teaching you clutches. Clear for everyone? Clear for everyone? And my dear, if they say, assume uniform wear theory to be valid, where pressure into R ka product is going to be constant, then my dear, you would be getting the frictional torque as 1 by 2 mu W R naught plus Ri. And here W is going to be P into 2 pi R naught minus Ri. This is going to be the value of W. Now my dear, here also sometimes they are asking you the pressure. Pressure is W by pi R naught square minus Ri square. And here if they ask you the maximum pressure, it is W by 2 pi Ri R naught minus Ri. And here pressure is not uniform. So if they ask you minimum pressure, it is W by 2 pi R naught minus Ri. So these are the results which would be required for this chapter. There are two theories, uniform pressure and uniform wear. Is it clear? And my dear, here when we are talking about two theories, I would like to say कि you may be saying, sir, both are theory. What about the actual results? So if you will ask me about the actual results, I would like to tell you that when we find out the frictional torque actual, it is coming out to be always more than the frictional torque coming because of UWT, and coming out to be less than the frictional torque coming out to be UPT. So UPT is giving more than the actual value, UWT is giving less than the actual value. So the point is which value we should consider. So my dear, if you are working for the bearings, then my dear, for bearings friction is a loss. My dear, if in the question examiner is saying do it by UPT, do it. If examiner says pressure is uniform, go for UPT. If examiner says go for UWT, do it. But if examiner leaves it on you, what you have to decide which theory. Then my dear, for bearings, as friction is a loss, we would be going for more loss. Because with the more loss, if we will design, in the lesser loss, our bearing will be very good. Design are always done in the worst condition. So we would go for the maximum losses. So we would be going for UPT. But when we are talking about the clutches, in the clutches, friction is going to help us to run the clutch. Basically, what is the clutch? Clutch is going to, like, we are having one shaft here like this. This is, we are having the plate on which friction surface would be there. And this is the another plate. So in the clutch, we are going to transmit the power from driver to driven with the help of friction. So their friction will be helping thing. So if we can transmit the power with less help, with more help, we can very easily transmit the power. So for the clutches, if nothing is mentioned, you would be going for uniform wear theory. But if they say clutch is new, then for that new clutch also you need to go for UPT. So I have told you 3 points. If they say apply this theory, you need not to think. But if they say no name of the theory, means you have to decide which theory to be used. Then for bearing, go for UPT. For clutch, you need to see whether it is new clutch or old clutch. New clutch UPT, old clutch UWT. Nothing more than that. Is it clear for everyone? Please tell me that. If you are talking about UPT, then my dear, I would like to say, in case of UPT, on the bearing, the pressure distribution is this as per UPT. This I am making on the bearing or on the collar, you can say. On the bearing or on the collar, because whatever collar is applying on the bearing, bearing will also apply on the collar. Then you know here pressure is constant. Here pressure into R is constant. R increases, pressure decreases. Here pressure distribution is like this. This is UWT. Clear for everyone or not? Please tell me that. So guys, the same things I teach for 3 hours in paid course. Here we have completed in less than 30 minutes. So the point is, this is the revision marathon. This is not the complete course going on. But I have given you everything, whatever I give there, without derivation. Clear for everyone? Please tell me that. If you are going for pivot bearing, which is not in your syllabus, you can see in pivot you are having this as the shaft, okay, and this as the bearing. So there, if you see, only one radius is there. So you will say Ri is equals to 0, R0 is equals to R in the same formulas. But this is not in your syllabus, so even if you want, you can leave it. Even if you want, you can leave it. Clear for everyone? Very good, guys. Very good. Very good. So the same things have been done there. If you want to see derivation, you can see. Now this is the question. A disc clutch is required to transmit a power of 5 kilowatt. Speed is 2000 rpm. So for that you can find out the torque, because you know power is T into 2 pi n by 60. So this will give you the value of torque. They have given coefficient of friction, this inner radius, this find out using the uniform pressure theory. The outside radius of friction, assume uniform pressure theory. If uniform pressure theory will be UPT. Ajay, okay, do this question, then I will tell you pivot. Otherwise, let's say pivot is not in your syllabus. Actually, pivot is not in your syllabus, but still I will tell you, just solve this question first. I will tell you, just solve this question first. So you will get the torque from here as per UPT. The formula is 2 by 3 mu W R naught cube minus Ri cube by R naught square minus Ri square. And what is W? W is P into R naught square minus Ri square. Just put this value here. You will get the value of R naught. Good question from gate side. Solve it guys. Machine design questions are always lengthy. They take more time. Solve it. Yes. After this question, we will move to the next sliding contact bearing. Okay? That will also take 30 more minutes. Then we will go to the rolling contact bearing, 15 minutes. Then joints. No, Vinay, that is not correct. Arey bhai, inner radius is 25. How outer can be 25.07? Okay, it would be coming more. Some calculation mistake you are doing. Yes, solve it, no issues. We will be going with the normal pace. But we'll go in the marathon style. Dear, in load equation, pi will be coming. Pi will be there. Yes, definitely Raja. Pi will be there. Solve it guys. हाँ भाई विनय, Ashray, it would be coming somewhere around, I feel 37 point something. it would be coming somewhere around 37 point something. This is the previous year question of gate. I feel 37.4 something like that. Okay, so Ashra is getting nearby answer, I feel. If you want, I can check and tell you. Just give me a minute. If you want the answer, it is just not far away from me. Clutch is the chapter. Yes, it is coming out to be 39.4. 39.4 mm. Okay. First of all, can you tell me what you are getting as the value of torque? Can you tell me what you are getting as the value of torque? Okay, you can solve it by your own. You will get 39.4. Okay, 39.4 is correct. Very good, Shreyas. Very good, Raja. So did you understand? If you remember the formula and if you can do the calculation easily, then this is nothing. Okay, it is the game of calculation. No, Ajay, answer will be 39.4. Arey bhai, if inner radius is 25, how outer can come less than 25? It means you are struggling with calculations. Okay, formula is same, everything is same. Only thing is you are struggling with calculations. Okay, no issues. So moving further, guys. Okay, you are talking about torque 23.87. That is correct. That is fine. So you are just making mistake in calculation. 39.4 is correct. So shall we move further now? Shall we move further now? Please tell me. Shall we move further now? Please tell me. Shall we move further now? Please tell me. Okay, very good. So guys, we have already seen that now we are moving to the journal bearing. Now we are moving to the journal bearing. Journal bearing is also known as, journal bearing is a part of radial load bearing. And my dear, it is also a type of sliding contact bearing. So my dear, now we are going to have this as the shaft. And you can see in this shaft various rotor gears will be there. And this is the bearing. If you will see, bearing is actually like that only. Bearing is circular only. So this bearing is having the length as L. And the diameter of the bearing is capital D. And the diameter of the shaft is small d. So my dear, the part of the shaft which is inside the bearing, the part of the shaft which is inside the bearing, we call it as journal. This part is said to be journal. And my dear, you can see the gap between them. Here we are going to have the lubricant. So lubricant is having major picture in this type of bearing. And here this is nothing but the lubricant. And in the second view, you can make the bearing as fixed like this. And this is the journal. In between the gap is having the lubricant. Now my dear, you can see if the journal is completely, you can see complete journal is in contact with the lubricant. So entire periphery of the journal is going to have the contact with the lubricant. So we call it as full journal bearing. What is the advantage of full journal bearing? If even load is acting in this direction, this direction, this direction, this direction, everywhere lubricant is present. So that lubricant will bear the load. So here, whatever be the direction of load, if we don't know, no problem. This bearing will take care. Full journal bearing. So we call it as full journal bearing. But my dear, if you already know that load will be coming in this direction only, then we will not be going for full journal bearing, then we will be going for partial journal bearing. We will be providing only this much part. Because more the surface will be coming in contact with the lubricant, more will be the viscosity losses. So that is why for such cases we would be going for partial journal bearing. So if the direction of load is known to us, we will go for partial journal bearing. If direction of load is not known to us, we will go for the full journal bearing. Okay, here our discussion will be going as per the full journal bearing. Okay, so my dear, now we are going to see the types of lubrication. If you remember, I told you that we are going with the thick film lubrication, and thick film lubrication is also known as the liquid lubrication. And liquid lubrication can be of two types. One is hydrodynamic, other is hydrostatic. And one by one we will see both of them. Questions are coming from that. First type of lubrication we are talking about is hydrodynamic lubrication. I am making, or you can see the diagram is available. You can see for hydrodynamic lubrication, this lubricant is provided at 1 atmospheric pressure. You can see shaft is having some load W acting downward, and you must know when this will be having the contact. Here some contact reaction will be coming, which is nothing but N. And for equilibrium of the body, as this is the condition when shaft is at rest, shaft is not moving. So because of that, you know, for equilibrium this W load should be equal to the normal reaction. This is the first condition when the shaft is at rest. This is hydrodynamic journal bearing. Now my dear, slowly we start giving rotation to this shaft. When we are going to give rotation to this shaft, my dear, what will happen here? You can see this W is resisted by this N. But this motion which is happening, this is going to start the rotation. Because of this rotation, my dear, a friction force will start coming here, which is mu N, because wherever relative motion will be there, friction will be coming. This W is balanced by N, but this mu N is not balanced by anyone. So because of this mu N, this shaft will start moving in this direction, and the next stage you will find the shaft to be present like this. And shaft will be moving in this direction until the body once again come to the equilibrium. You know, here we are having W load acting downward. Here we would be having normal reaction which will be passing from the center, and friction would be like this. And my dear, the resultant of both will be going like this Rn. And when this Rn will become equals to W, then only this will be coming into equilibrium. But this equilibrium is not complete equilibrium, because here this Rn force and this W force, they are separated by some distance. And whenever we have two equal and opposite forces separated by a distance, it definitely constitutes a couple. And because of that, they are equal and opposites, they will be creating a opposing couple. It is moving in this way, couple will be opposing it. That's why we call this friction as this couple as the friction couple. And this friction couple is nothing but W into X. Now if we go for some trigonometry, you can see that this is, if you want to say, this is the distance X, this is the radius R, and you can see if this is X, this is R, you know, this is resultant, this is normal. The angle between normal and resultant, if you are going to have a block like this on a surface, and on this normal reaction is acting like this, it is moving in this way, so friction will be acting like this. Resultant will be acting in this direction. Then the angle between resultant and normal force is said to be the friction angle beta. So here also this angle is beta, because friction is mu n, and resultant will be having the angle of beta. So if this angle is beta, that is much obvious, this angle will also be beta. So from here you can write X, this is X by R, is equals to sine beta. Here beta is found to be very, very small. When beta is very, very small, we can write sine beta as beta. We can write tangent beta as beta. So we can write sine beta as tangent beta. So we can write x as r tangent beta. With that formula, you can get the value of frictional torque as W into R tangent beta. And I feel everybody knows tangent of friction angle is coefficient of friction. So we can write this frictional torque as mu WR. And if you want to write down the frictional power, it is mu WR omega, because T into omega is nothing but power. And you know R into omega is velocity, so you can write it as mu WV. Any doubt, Ajay, Vinay, Shreyas, Raja, Ashray? Please tell. Yes, yes, yes. Bolo bhai. And my dear, this x, actually this x is going to decide the magnitude of the friction. And if you take this x as radius and make a circle, that circle is said to be friction circle. That circle is said to be friction circle. But my dear, one more thing, whatever I have told you, this is the mathematics. Now let us see the physics, what is going to happen in reality. You know that when this shaft will be rotating in the clockwise direction with the slow speed, whatever the lubricant is present, it would be having some no slip condition onto the shaft surface. So whatever layer which is just touching the shaft will be just stick to the shaft. And because of that sticky layer, it will try to move along the shaft, with the shaft. And my dear, with the time, that layer will start increasing. And after some time, this layer will be very, very thick. And this will try to move with the shaft and will try to go from this wider region to this narrow region. Initially, that layer is not having that much pressure with which it can push this shaft. But after a layer thickness is obtained, then my dear, this layer is going to enter into this narrow region and pushing the shaft onto the other side. As the speed increases, this is the phenomena which is going to happen. And this is said to be the dynamic action of shaft or wedging action of lubricant. And here, by that, metal to metal contact will be avoided, and at high speed you will see this. At high speed you will see this. And when you are going to get this at high speed, metal to metal contact is avoided, and this is happening because of the wedging action of lubricant or dynamic action of shaft. So we call it as hydrodynamic lubrication. Because the concept of lubrication is to reduce the friction. When metal to metal contact is avoided, friction is automatically reduced. Are we getting it? Please tell me. Are we getting it? Please tell me. Are we getting it? Please tell me. Everybody got it? Please tell me. Very good. Then my dear, we are coming on to the hydrostatic lubrication. In hydrostatic lubrication, we are providing the fluid at high pressure with the help of a pump. And as you are providing at high pressure with the help of a pump, so even at starting, even at rest, the shaft will not be in contact with the bearing, and you would be always having a layer of lubricant present. Because of its high pressure, it is automatically capable of withstanding the weight of the shaft. Actually, what is going to happen when you are going to rotate the shaft at high speed? The layer of lubricant is getting pressurized. When the layer of lubricant is getting pressurized, it is capable to bear the load of the shaft. Then it was putting the shaft on the other side. But here automatically you are putting the lubricant at high pressure. So because of that, as you are putting the lubricant at high pressure, even at stationary condition, there is no metal to metal contact, but at the same time this pump will be taking some electricity, so it is going to be the costlier way of lubrication. This is hydrostatic. Now my dear, this is at high speed or at slow speed. This is always. Here always this metal to metal contact is avoided. But you can see one thing, here the center of shaft and center of bearing will be same. But in case of hydrodynamic, here the center of bearing is different than center of shaft. So the motion of shaft and bearing will be at some eccentricity. That's why we call it as eccentric motion. Is it clear for everyone, bhai? Shall we move on? So when we are going to have a table of hydrostatic versus hydrodynamic, I am telling you one by one all the points. In hydrostatic, we are providing the lubricant at high pressure. In hydrodynamic, we are providing the lubricant at room temp, at 1 atmosphere pressure. In hydrodynamic, metal to metal contact is avoided only at high speed. In hydrostatic, metal to metal contact is avoided even at rest, even at stationary condition. In hydrodynamic, metal to metal contact is avoided with the help of the wedging action of lubricant or the dynamic action of shaft. In hydrostatic, it is going to happen because of the external pressure. Hydrodynamic is cheap lubrication, hydrostatic is costly lubrication. Hydrodynamic is eccentric motion between shaft and bearing, hydrostatic is concentric motion. As at the rest condition in hydrostatic there is no metal to metal contact, so hydrostatic is preferred if the load at the starting conditions are very, very high. Otherwise we will go for hydrodynamic. In the real condition it is better to go with the mixed lubrication. In the starting we go with hydrostatic to avoid metal to metal contact, and when the speed is increasing we are not providing the pump, and then by the hydrodynamic action the metal to metal contact will remain avoided. So generally we go for mixed lubrication, and here the applications are also mentioned. The applications for hydrodynamic are IC engine, crankshaft, steam and gas turbine, electric motors. For hydrostatic is heavy machines like bowl mills, large size vertical turbo generators. I feel this is clear for everyone. Everything is written in the slides. Now we are going for the terminology of hydrodynamic and hydrostatic bearing. After this terminology we will go for the formulas and the chapter will be over. Are we ready? So guys, don't worry, not by 2 but before 3 we will complete. Okay? So when we are talking about this, I am going for the terminologies. This is the bearing. This is the bearing. So guys, बने रहना है, ठीक है, हिम्मत नहीं हारनी है. जब आपके टीचर रात को जाग के आपको खड़े होके पढ़ा सकता है तो आप नहीं पढ़ सकते हो क्या? बैठे बैठे पढ़ना है आपने तो. This is the lubricant. And this distance is said to be minimum oil film thickness. This is center of shaft, center of bearing. I am defining the parameters. This is eccentricity. O dash. I am saying that R and D, they are for journal, radius and diameter. R and D, they are for bearings. Capital for bearing, small for journal. So this is the hydrodynamic, and hydrostatic would be like this. So in hydrostatic they are always concentric. So when we are talking about hydrostatic, you would be having something called as radial clearance. Radial clearance can be written as R minus R. Diametral clearance can be written as d minus d. This is the radial clearance. If you make it 2 times, it is diametral clearance. C is 2 times C1. And my dear, whenever we are talking about this radial clearance, diametral clearance. My dear, if you want to find out eccentricity, I am saying that the distance from this to this is the r, and this distance is small r. So we can write r as E plus r plus h naught. What is E? R minus r minus h naught. C1 minus h naught. So eccentricity is C1 minus h naught. And when we are going to talk about E upon C1, it will be 1 minus h naught by C1. This is said to be eccentricity ratio. Okay, you can also write it as 1 minus 2 h naught by C. C1 is C by 2. So this is eccentricity ratio. Till this point, whatever the terms we have discussed, are you clear about these or not? Terminologies are always defined for the high speed conditions, because 99% of the time shafts are rotating at high speed conditions. Clear? Now my dear, we are going to define one more thing, that is said to be the bearing pressure. I already told you bearing pressure is W by LD, that we have already defined in the starting. And there is something called as bearing characteristic number. It is defined as Zn by P. Here Z is the viscosity of the lubricant. P is the pressure, bearing pressure. N is the RPS, revolution per second. So you can say N by 60. Okay. So my dear, this is bearing characteristic number. We will see its significance in next 5-10 minutes. After that, my dear, there is a wonderful number comes, that is the Sommerfeld number. And when we are talking about the Sommerfeld number, this is identical for, this is same for identical bearings. If two bearings are identical, Sommerfeld number will be same for them. And the very first numerical which is coming from this chapter is from Sommerfeld number. It is defined as Zn by P, which is nothing but bearing characteristic number into R by C1 ka square. Or you can also write it as Zn by P D by C ka square. This is the first formula from which question is coming. Okay, clear for everyone? You can find out the Sommerfeld number for this question. For two identical bearing, this is this number. Okay, this is not question, this is mentioned actually. From here question is start. A natural feed journal bearing with diameter 50 mm, length 50 mm. So you can find out pressure. Pressure will be 200 Newton by 50 cross 50 mm square. This will give you the pressure. Pressure is always defined in Pascal in the bearing characteristic number. So this is the pressure. Then you know they are find out Sommerfeld number. Viscosity Z N by P R by C1 ka whole square. Put the values. This is 20 millipascal second. So 10 power minus 3. This will be coming into Pascal. Okay. Newton per mm square. You will be getting it also MPa. So you need to convert it into Pascal. Okay. So I feel you will be able to put the values and get the answer. Try to solve it. Try to solve it, guys. This is the previous year question of GATE only. They are asking you for Sommerfeld number. Just 2 more expression, this chapter will be over. And next chapter will be taking much lesser time because next chapter is very small. That is rolling contact bearings. And after that, we would be having riveted, bolted and welded joints. Solve it, guys, solve it, guys, solve it. अरे क्वेश्चन करने हैं नहीं करने हैं या सीधा कॉन्सेप्ट ही पढ़ाता जाऊं है? सॉल्व इट. Solve it, guys. Okay, let us see about others as well, विनय. इसका भी आंसर मैं मैच कर लेता हूं क्योंकि मेरे पास प्रीवियस ईयर क्वेश्चंस के सॉल्यूशन अभी है, तो चेक करना सही रहेगा. 0.125. देखो आपने गलती क्या की होगी, ये 2000 बटे 2500 आ गया. सो आई फील दिस विल बी coming out to be 0.8 into 10 to the power 6 Pascal. So when you will be putting the value, viscosity is 20 10 power minus 3, RPS is 20, pressure is 0.8 into 10 power 6, then into R by C1, radius is 50 mm, diameter is 50, so radius is 25, and clearance is, radial clearance is 50 microns into 10 power minus 3 square. It will be 0.125. Yes, very good, Akhilesh. Is it clear for everyone? This is Sommerfeld number, guys. Now we are moving to the next thing, that is the power loss in terms of viscosity. So my dear, when we are going for the expression for power loss in terms of viscosity, so you know that whenever we are talking about this shaft is rotating, bearing is at rest. So if we are going to consider this part and we see this with the microscope, it would be looking like bigger. So you can consider this to be the flow between two flat plates, out of which one plate is at rest, other plate is moving. So you know this velocity profile will be, here the velocity is v, here velocity is 0, velocity will be varying linearly. You know the Newton's law of viscosity, where you say shear stress is equals to mu u by y. So from that we can write shear stress as, here viscosity we are showing it by z, velocity is v, the distance between them is the radial clearance, that is C1. This is C1 in case of hydrostatic. Why we are always interested in H naught? Because H naught is the minimum oil film thickness. If minimum oil film thickness can bear the load, then any layer thickness can bear. H naught will be used for hydrodynamic. Choice is yours. So we got the expression for shear stress. We got the expression for shear stress as tau Z into V upon H naught, or Z into V upon C1. This would be the shear stress. Here V is nothing but pi dn. Okay, velocity is pi dn. Any doubt anybody can ask. Shear force is shear stress into area. Area of this is, you know that this is L, this is D. So area is nothing but pi dl. This is the shear force. If you want to write down the torque, torque is force into d by 2. And if you want to write down the power, Tf into omega. Now you can write down the expression for anything. Please tell me, is it clear for everyone or not? If there is any doubt, please ask. Yes, is it clear for everyone? Is it clear for everyone? Very good. Very good. So guys, whatever we have done, we have seen all the formulas from which till date the questions are being asked. Okay, till date all the questions. Okay, no issue Ajay. Till now whatever questions are being asked in the GATE examination, they are asked from these formulas only what we have discussed. Other than that, I would like to give you one more formula from which the question can come, that is related to the coefficient of friction. They can also ask you the coefficient of friction. So coefficient of friction is given as 2 pi square Zn by P into R by C1 का whole square. Sorry, R by C1. This is the formula for coefficient of friction. Don't go by this. This is the correct formula. This is also known as Petrov equation. This is also known as Petrov equation. Okay. So this is nothing but Petrov equation. And if you will say that there was a scientist known as Mackey, he said this as K plus 2.008 pi square Zn by P R by C1. So this is also coefficient of friction. Both are nearly same. This is theoretically consideration. This is experimentally calculated. And here K is nothing but the leakage factor. But if leakage factor is given in the question, then only you will be using this formula. So you can see leakage factor is 0.002. This is from data book. But in the question, if they don't give it, then you go for Petrov equation. So in that way, you can also find out the coefficient of friction. Is it clear for everyone or not? Please tell me that. So this is about this type of bearing. Rest all other things are not required. This is the last heading under the sliding contact bearing. That is nothing but the significance of bearing characteristic number. After that, within, you can say 1:15 is the time, na? By 1:30 we will be completing the bearing. Then joint will take some time. After that, nothing is required. Okay. After that, topics are very less. You know, clutch we have done, bearing we have done. For spring and gears, I will give you direct formulas. Okay. So when we are talking about significance of bearing characteristic number, so Mackey have made an investigation curve between coefficient of friction and bearing characteristic number Zn by P, and this curve is coming like this. You can see the coefficient of friction is coming out to be minimum here, and where coefficient of friction is coming out to be minimum, that bearing characteristic number we are calling it as bearing modulus, and bearing modulus is denoted by alpha. So my dear, this is the alpha, and we always think that we should work over the minimum coefficient of friction because here losses will be minimum. So we want to operate at alpha. But my dear, alpha is not good for operating. Why? I am telling you, if you are going to operate at alpha, there is no problem. Let us say slight change in load happen. Load is slightly increased. Then you know frictional power is written as mu WV. then obviously frictional power will be increasing because W increased. Power will increase, obviously you know heat loss will be increasing. Heat loss will be increasing. Obviously you know whenever heat loss will be happening, sorry, not heat loss, heat generated, because whenever power loss is happening, that will be generating the heat. So because of that you will see heat will be getting generated. So heat generation will be increasing, which will increase the temperature, which will reduce the viscosity, which will reduce the bearing characteristic number. If bearing characteristic number will be reducing, we will be moving towards left. And if we will be moving towards left, mu will be increasing. Previously this all things were happening because of increase of W. Now the same cycle will increase because of the increase of mu. Power increase, heat increase, temperature increase, Z decrease, Zn by P decrease. Once again you will go to the left. So my dear, without doing anything, it will go on the left, and one day will come when the bearing will burst. And I always use here a phrase of Nana Patekar, "aa gaye meri maut ka tamasha dekhne." Bearing will be saying you this, that "aa gaye meri maut ka tamasha dekhne," if you are going to operate in this range. Just a slight change in the load and it will go to hell. So that is why this region is said to be unstable region. And we never operate in that. Even we are going to start our operation in such a way, we operate in 3 alpha to 15 alpha. We are operating far away from this region. Because if you will see this region, this is said to be stable. Because here, if the same cycle will repeat, reduction of Zn by P, let us say you are working here, load increases. If load increases, if the same cycle is going to happen, this time Zn by P reduction means you will be going to left and coefficient of friction will reduce. So because of reduction of coefficient of friction, this time the same cycle will not repeat. And that is why this part is said to be stable, this part is unstable. Is it clear or not? This is the significance of bearing characteristic number. Any doubt, anybody, please ask. Ashray, Vinay, Dhanesh, Shreyas, Akhil, Ajay, please tell me. If any doubt you find, you can ask. Clear for everyone? सो गया ये जहां सो गया आसमां है. Clear? Sliding contact bearing is over, guys. Now we are going for the rolling contact bearing. Now when we are talking about rolling contact bearing, okay, why we call this unstable? Because once we are moving slightly left, it is moving to the extreme. And why this is said to be stable? Because when it will be going down, because of which power loss will reduce. So the effect of increase of W will be nullified and it will come back to this condition. That's why we call it as stable. Because here condition of stable equilibrium is followed. Okay, so this chapter is over. We are moving. Okay, stable, I am explaining Shreyas again. If you are operating here, let us say, okay, I am showing it again to you. If you are operating here, this time let us say the load increases. If load will increase, power loss will increase. Power loss will increase, heat generation will increase, temperature will increase, viscosity will decrease, and Zn by P will decrease. If Zn by P will decrease, you will go to the left. And when you are going to the left, coefficient of friction is decreasing. So when coefficient of friction will decrease, this time this cycle will not repeat, na? Because when mu is decreasing, power loss will decrease, heat generation will decrease, temperature will decrease, Z will increase, Zn by P will increase, and you will come back to this condition. That's why stable. Because stable equilibrium means if you are moving it to this way, it will come back to this way. Stable. Clear, Shreyas? The same, when you are taking this ball here, ball will come back. Stable equilibrium. Okay? Fine. Now my dear, rolling contact bearing. So my dear, whenever we are going to make the curve between coefficient of friction and speed, For journal bearing, it is coming like that. For roller bearing, it is coming like that. For ball bearing, it is coming like that. So you can see in the slow speed region, coefficient of friction is quite less in ball bearing and roller bearing. That is why we are calling them as anti-friction bearing. As friction is less for these two types of bearing at the slow speeds, we call them as anti-friction bearing. And when we are talking about these anti-friction bearing, the name anti-friction is just a misnomer, because here friction is present but it is very less. So we call it as anti-friction bearing, but they are good in slow speeds only. In the rolling contact bearing, there is a rolling element which is going to bear the load. And in this we need to study only one type of bearing, that we call it as deep groove ball bearing. In the deep groove ball bearing, we are going to have a bearing like this. It is said to be outer race. Then we are going to have an inner race. If you remember yesterday also in the tome we have discussed this. This is inner race. And my dear, in between the inner and outer race, we are going to have the balls or rollers. If we are having balls, we call it as ball bearing. If we have rollers, we call it as roller bearing. And these balls are separated by some cage or separators. These balls are separated by cage or separator. So these things are said to be cage or separator. So whenever we are talking about, you can see these balls are present at some positions. Actually, they are always equidistant. And if you are going to change the position of the ball, their load carrying capacity will change. And out of inner and outer race, one race is fixed, other is moving. If outer race is fixed, inner race will be moving. That is the example when you would be having a shaft and this bearing. If you are talking about automobile, axle is not moving, then inner race will be at rest, outer race will be moving with the wheels. So these bearings you can use with the axle, also you can use with the steering. With the steering, inner race will rotate, outer will be at rest. With the axle, inner will be at rest, outer will be rotating with the wheels. Okay, so I am going slightly faster. Where you find any doubt, you can please ask. So my dear, when we are talking about this bearing is having a bearing number of 6. 6 is the bearing number. And this bearing is coming in 5 series particularly. What are those 5 series? 5 series are, I am showing it. One series is 100 series, other is 200 series, other is 300 series, other is 400 series, other is 500 series. 100 series is said to be extra light series. 200 series is said to be light series. 300 is the medium series. 400 is the heavy series. 500 is the extra heavy series. And when we are moving from 100 to 500, its size increases, its load carrying capacity increases, its cost increases. Okay, what is the meaning of increase in the size? I am showing you that. You can see this bearing and this bearing. They are both used for the same shaft. This is the second view of the bearing. Like I am making the bearing like this now. The same bearing we can also denote like this. So we show it like this. So you can see here the size of ball increases. The size of bearing is bigger. Width is increasing. Maybe this is 200 series, this is 500 series. Is it clear? Is it clear? So my dear, when we are talking about these bearings, they are denoted like this, 6104. Here 6 is the bearing number, 100 is the series, and last 2 digit multiply with 5 will give you the diameter. Like here it will be giving you the diameter of shaft. Okay, this will give you the diameter of shaft. So when we are using 6100, 6101, 6102, 6103, this rule is applicable only after 6104. But before that rule is not applicable. For 6100, if you will multiply these 2 digits with 5, it will come 0. So that is why for this it is 10 mm, for 6101 it is 12 mm, for 6102 it is 15 mm, for 6103 it is 17 mm. After that we will follow this rule, multiply by 5. Very good Ajay, wonderful dear. So this is about deep groove ball bearings. And my dear, whatever I have told you, that is not going to come in the exam. SKF and Tata are the manufacturer of this type of bearing. So whatever we have discussed till now will not be coming in the exam. Ashray, this will be the diameter of shaft only, na, whatever I am saying. Whatever I am saying, this is the dia of shaft. This 6 is bearing number, this 1 is telling us the, like let us say this is 6104, this is 6504. Both are having the same diameter of shaft. Clear? Okay. So my dear, now we are coming on to the thing from which the questions are coming actually. Now we are coming on to the thing for which the questions are coming actually. So first of all, we would be going for the first heading, that is equivalent radial load. If we are going to have, this is the shaft, this is the bearing, and you know these are the balls. The position of ball is very important. There are many balls, I am showing it 3 only, just for the sake of understanding. This is the load acting like this, FR, radial load. If you see the second view of the bearing, it is like this. Let us say some axial load is also coming on to this is FA. But these bearings are found to be good in the radial load. So that's why we are going to have the conversion factor and we are finding out equivalent radial load. It is coming out to be XVFR plus YFA into S. Here X is said to be radial load factor. Y is the axial load factor. V is the race rotation factor. FR is the radial load. FA is the axial load. S is the service factor. Is it clear? Service factor will be given to you in the question. You need not to worry about that. Everybody is clear about this? Please tell me that. Everybody is clear about this or not? Please tell me that. So my dear, this we are going to consider with the consideration that FR and FA are not changing with time. If I make the curve, this is FR, this is FA, and they are constant with time, and speed is also constant, then only this formula is applicable. then only this formula is applicable. Clear for everyone? Yes. And my dear, let us say if we have, just wait, I need to add 2 slides here. Okay. If we are going to have the conditions like this, I am having for this time t1, force is Fr1, axial force is Fa1, speed is n1. Let us say that is given to us. Then for second time interval t2, radial load is Fr2, axial load is Fa2. Then for third time interval, radial load is Fr3, axial load is Fa3. You know, this is the case of cumulative fatigue. So when this is given, then for all the 3 time intervals, you will apply the formula and you will find out the equivalent E1, equivalent E2, equivalent E3. Which formula you will use? You will use this formula, XVFR plus YFA into S. Using this formula, you will find out the equivalent load 1, equivalent load 2, equivalent load 3. And you will also find out the number of cycles. What is number of cycles? N1, N2, N3. What is N1 here? N1 is speed into time. N2 is speed into time. N3 is speed into time. So once you are going to find out this time, when you are having different equivalent load, if I want to find out one load which would be valid for the entire time, that is said to be cubic mean load. This is a new formula from which the question can be asked. Cubic mean load. It is given as cubic mean load. It is N1 PE1 की power cube, N2 N3 divided by N1 plus N2 plus N3 to the power 1 by 3. This is said to be cubic mean load. You can have a question from this for the first time in this year. Till date there is no question on this. Clear by Shreyas, Vinay, Neen to nahi aa rahi, Ajay, Ashray, yes, everybody, Akhil. Clear for you guys or not? Please tell me that. Everybody is clear or not? Please tell me that. Bolo bhai, bolo bhai. Yes. Now my dear, this is the cubic mean load. Now we are going to have a heading of bearing life. Generally when we talk about the life means what? Life means the number of revolutions a bearing will complete before failure, or the number of hours a bearing will complete before failure. Generally we define like that only. But for bearing, we are defining the life in terms of rated life. Like if we are going to have 100 bearings, they are working at a constant load and a constant speed. Then my dear, you know, after some time when you will check, out of 100 bearing, maybe 95 bearing would be safe, 5 bearing would be getting failed. After some time you will see 90 bearings are safe and 10 bearings are fail. And at that instant you will see how many number of revolutions are being completed. That will be defined as the rated life. And generally we are using the rated life for the reliability of 90% only. Means this is that number of revolution which 90% of the bearing would be successfully completing, and 10% bearing will get fail. So my dear, that is said to be rated life, and it is denoted by L90, or L10. 90% pass, 10% fail. So my dear, if we are having the notation as L90 or L10, it means 90% pass, 10% fail. You can also have L80 or L20. You can also have L70 or L30. You can also have L60 or L40. You can also have L50. So my dear, 90 and 10 means 90% pass and 10% fail, and so on. So my dear, L50 is said to be average life. This is the life. This 90%, 80%, 70% is the reliability. Like if you are saying out of 190 bearings are pass, it is like out of 10 times there is a friend who is helping you for the 9 times. He is having a 90% reliability. You will say he is 90% reliable. So whenever we are talking about reliability, it is helping us, because if someone is reliable, it is a good thing that we can have a faith on it. Thanks, Ajay. So when we are talking about this L90, L80, L70, this is L50, and when you are going to see the relation, L50 is coming out to be 5 times of L90. This is said to be rated life. This is said to be average life. Average life is 5 times the rated life. Why like that? Because reliability will be reducing, number of friend will be increasing. Very less friend with high reliability, very large friend with low reliability. Okay? And my dear, I would also like to tell you how I get that. There is a relation. If you want to write, let us say L any life but a L90. It can be written as Ln. 1 by that reliability, Ln. 1 by reliability of 90% to the power 1 by 1.17. Like I want to find out L50. L90 is known to me. That is equals to Ln. 1 by, you will write here 0.5. Ln. 1 by 0.9. 1 by 1.17. From here you will be getting L50 as 5 times of L90. My dear, whenever we are talking about this L90, it is generally given in the millions of revolution. Millions of revolution. And I would also like to tell you, sometime in the question they can give you the life in the hours. Then you need to multiply it with 60 to convert it into minutes. Then multiply it with the RPM so that you get it into the revolution. Then divide it by 10 to the power 6 so that you get it into the millions of revolution. This formula will help you a lot. Is it clear for everyone or not? Please tell me that. Now we are left with only 3 things to complete this chapter. Only 3 things to complete this chapter. My dear, first of all, I would like to tell you the load carrying capacity. Load carrying capacity. My dear, for this type of bearing, there are 2 types of load carrying capacity. One is said to be static load carrying capacity. Other is said to be dynamic load carrying capacity. When we are talking about the static load carrying capacity, it is defined as C naught. And it is that equivalent radial load which will produce a permanent deformation at the heavily stressed point. At the heavily stressed point. That point can be present on inner race, outer race or ball, because only these are the 3 things which are going to bear the load. So at heavily stressed point, the permanent deformation of 0.0001 times of diameter of ball. If that much deformation at the heavily stressed point is coming by some load, that load is said to be static load carrying capacity. It is not important, you can leave it. It is not required for exam. Because we are not designing bearing to be at stationary condition, we are defining the bearing to be in the rotating condition. So that is why this is important for us. This is also known as catalog rating. This is also known as catalog rating. So dynamic load carrying capacity is also known as catalog rating. How we will be defining catalog rating or dynamic load carrying capacity? Actually, you already know, you were taking 100 bearings at a constant speed, at a constant load. And you were finding out the time when this 100 will remain 90. And you were finding out at this condition what are the number of revolutions, and you were calling that is my rated life. So my dear, when we are talking about dynamic load carrying capacity, dynamic load carrying capacity is that value of PE. That value of PE for which L90 is 1 million. So that value of equivalent radial load for which L90 will become 1 million is nothing but the dynamic load carrying capacity. And my dear, the relation which is said to be load life relation from which all the questions are coming, it is defined as C by PE is equals to L90 to the power 1 by 3. If you remember this relation, you will be able to solve 100% question of this chapter. Till date, all 100% are been asked from this. Whatever other formulas I have shown you, there is no question from that. Is it clear? Is it clear? So this formula is becoming very, very important. It is said to be load life relationship. With this, bearing chapter is over. It was the biggest chapter, but we have completed it. Okay, we have completed till now theory of failure. What are the chapters over? Theory of failure over, fatigue over, brake over. Now clutch, whatever I have told you, for gate till now only that is asked. Other types of clutch, if you want to study, I have shared the notes on the Telegram channel. You can also study for engineering services. Many types of clutches are asked, like cone clutch, centrifugal clutch. In gate till now they are not asked. Okay, but if they are asked in the paid courses, I teach that, because I have a doubt sometime question may come. If you also want to cover, you can cover it from notes. But in marathon, we will go as per the syllabus. Okay. So clutch is over, these 4 chapters. Now 5th chapter is also in the list. Bearing is over. Clear? Let us solve one question to finish this. After that, we will enter into joint. Joint is the last big chapter. Whatever time we will give in the joints, that is the most important topic. After that, if you are talking about gears, shaft and springs, 10 minutes, not more than that. Okay, so now whatever time would be required, here C is dynamic load carrying capacity. Bhai Ajay, C is dynamic load carrying capacity. Clear? Let us see the question. Solve this one. Okay, first solve this one. Two identical ball bearings P and Q are operating at the load of 30 and 45 kilonewton. So you can say the equivalent load of P is 30, equivalent load for Q is 45. The ratio of the life of P to the life of Q, you need to find out this. Okay, and you already know L90 C by PE. As this was, I was writing 1 by 3. I would like to say generally it is defined as L90 to the power 1 by K. Sorry, L90 to the power K C by PE. This K is 1 by 3 for deep groove ball bearing or ball bearing, and this is 10 by 3. Sorry, this is 10 by 3 for roller bearing. You can also write the expression like this. Okay, so don't worry, I am showing you this question how to do. So you can see L90 is inversely proportional to P to the power cube. So you can write it as L90 by P, L90 by Q. So PE of Q by PE of P to the power cube, that will be your answer. Solve it and get the answer. Vinay have given the answer as B. You can remember this in this way also, because here if they give you ball bearing or roller bearing, for both of them I defined the value of K. Very good Akhil and Vinay. Very good Shreyas. So you know that it is nothing but the 45 by 30. Yes, Ajay, do you have any doubt in this? It will be coming out to be 3 by 2. 27 by 8. Anybody have any doubt, you can ask. Okay, one last question on this. The expected life of a ball bearing subjected to a load is 9800 Newton. You know dynamic load carrying capacity C is same for identical bearing. It is like a property of bearing. So if they are saying the expected life of a ball bearing subjected to a load of, so PE1 9800, working at 1000 RPM, 3000 hours, PE L90 P1 is 9800, LH1 is 3000 hours, N1 is 1000 RPM. What is the expected life for the same bearing? P2 is 4900 Newton. LH2 is calculating. N2 is 2000 RPM. So you know how to solve this question. First of all, you know the relation is C by PE to the power 3, because it is ball bearing, is equals to L90. From here we can write C is equals to L90 1 by 3 into PE. For two bearings which are identical, C is same. So you can write PE L90 1 by 3 is equals to PE L90 1 by 3. This is for bearing 1, this is for bearing 2. Load is given as 9800 Newton. You know L90 can be written as life in hours into 60 into N1 divided by 10 to the power 6. This is 1 by 3. Right hand side 4900 LH2 into 60 into N2 into 10 power 6. Solve this and find out LH2. Vinay have calculated it as 12,000. Okay, what about others? Very good. So the answer will be coming out to be 12,000 hours. Very good Vinay, very good Ajay. Sandbok, hi dear, how are you? Happy to meet you at 1:15 in the night. Yes, 12,000 hours is correct. Very good guys. So with this we have completed this bearing chapter. Okay. Now it's time to go to the joints. Okay. So we will go back now to the joints. We will go back now to the joints. Yes, we are starting with the joints now. Where is rivet yaar? Okay guys, the last big chapter is joint. Last big chapter is joint, and my dear, after this 10 minutes would be required for other chapters if we complete this. And this we can very easily complete. Okay, because here theory is very less and numericals we have to do one type only, nothing more than that. So when we are talking about joint, first of all you need to understand how joints are different than couplings. Then the answer is joints are used to transmit the loads and couplings are used to transmit the power. So coupling are used to transmit the power, joints are used to transmit the load. So if that is the case, joints are defined as in two types. One is temporary. Second type of joints are the permanent joints. In the temporary joints, we are having bolted joint, we are having pin joint, we have cotter joint, we have knuckle joint. In the permanent joint, we have welded joint, we have riveted joint, we have soldered joint, we have braced joint. So whenever we are talking about these joints, my dear, I would like to tell you one thing, that out of these we need to study only bolted joint, we need to study only riveted joint, we need to study only welded joint. Only these three joints are in our syllabus. Nothing more than that we need to study. So we would be going with the riveted joints. So when we are talking about rivet is having a head, then a shank, then a tail. And how to make the riveted joint? We are having one plate like this. We are having another plate like this, and in that plate we are going to make a hole, and in that hole we are going to place the rivet like this. You will be forcing it and closing it. The benefit of this type of joint is that riveted joint do not have any heat affected zone like welding operation. So this is the advantage. Second advantage is you can join two plates with different material, with different thickness. These are the advantage. Disadvantage are when you are making these joints, you are making the hole in the plate. And when you are making the hole in the plate, because of this, the efficiency of joint is always reaching from 65 to 70%. This is the loss in efficiency from this joint. And second problem can be the presence of leakage. These are the problem with the riveted joints. Now my dear, whenever we are talking about these riveted joint, okay, whenever we are talking about the riveted joint, you know this type of configuration is said to be lap joint. And if you are going to see this joint, from here you cannot tell how many rivets are there. If you will see in this diagram, it may looks like one rivet is there. But I would like to say, by looking at this diagram, you should say one row of rivet is there. One row of rivet is there. Why? Because when you will see the top view of this, you may be having the top view like this. Just look at it. Just look at the top view of this. The top view may look like this. This is that plate. The second plate is this. And you may have this as the row of rivet. In this row you can have more than one rivet. So that is why without looking at the top view you cannot tell about the number of rivets. You can only tell about the row of rivet. Is it clear? So this is how you can tell us about the number of rivet by looking at the top view. Clear? So my dear, this type of joint is said to be the lap joint configuration, and this type of configuration is said to be the butt joint configuration. If you want to join two plates like this, now you cannot put the rivet in between them. So for such cases we are going to use the strap plate. This is said to be strap plate. Now you would be making the hole into this strap plate and this plate like this, and you would be placing the rivet like this. Always the hole size is bigger than the rivet size. Then only rivet will go inside the hole. And whenever we are going to see, this time if I will ask you how many row of rivets are there? This time can you tell me how many row of rivets are there? How many row of rivets are there? How many rows of rivets are there? It looks like 2, but dear, the answer is 1, because row of rivet is always counted per plate. Like if you see this plate, with this plate only we have 1 row. So always the rows of rivets are counted per plate. So the answer will be single row. Here you can see this is the plate now. With this plate you can see for this plate only 1 row of rivet is there. Always the rows of rivet are counted per plate. So we will be saying only single row is there. Is it clear for everyone? And my dear, when we are using the single strap plate, here we are using the double strap plate. So my dear, when you would be using the single strap plate, when you will apply force like this, you would be having only single shear failure happening here. You would be having single shear failure happening here. But in case of double strap plate, this and this, two shear will be happening. So when you have the double strap plate, it is the failure of double shear. I will show you what is the meaning of double shear. Here this and this, both areas will be reacting. Both area will be showing the resistance for the external force. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Akhil, Shreyas, Raja, Ajay, Vinay, Sanbok. Yes. So my dear, when we are talking about this, now whenever you will see the rivets, you can have the rivets in this way also. You can have the rivets in this way also. This is said to be the row of rivet. Row of rivet. This is one case. This is the row of rivet. This is row of rivet. So my dear, this is said to be the chain riveting. This is said to be the zigzag riveting. My dear, the line which is joining all the centers of the rivet, we call it as gauge line. And the gap between the center of two rivet is said to be the pitch. The gap between the two gauge line is said to be the back pitch. and the gap between two diagonally opposite rivet is said to be the diagonal pitch. My dear, diagonal pitch is written as the square root of p square plus pb square. In the zigzag, this is pb, this is p, this is p by 2. So the diagonally opposite rivet PD will be coming here, p by 2 का square plus pb का square. Is it clear for everyone? Please tell me that, guys. Is it clear for everyone? Please tell me that, guys. Is it clear for everyone? We have discussed two things. Okay, as I said, I am going in the marathon way, I am going in the exam way. So like in the paid course, when I teach you the types of rivet, the terminology in one class. Here we will not waste our time like that. It doesn't mean there we have wasted the time. No, at that time that was the requirement. At this time it is revision for those who have already studied. Revision should go in that. So we completed the terminology also. Now my dear, we would be going for the design part. Okay. So my dear, whenever we are talking about the rivet, whenever we are talking about the reverted joint, in a reverted joint there are two things. One is rivet, other is plate. Plate is generally getting failed by tearing strength. By tearing. And that tearing can happen because of load and can happen because of insufficient margin. Insufficient margin. Both can be the reason. And rivet is getting failed because of either shear or crushing. So first of all, we will be talking about the failure of the plate. You know that this is the plate. If this and this, very less margin is there. So here, if any failure will be generated very easily from here, plate can tear. Tear because whenever the failure happen, it is happening like this. So we call it as tearing failure. So in the plate, if we are going to have like this, let us say this is rivet, hole. So if the failure will be happening, it will be, crack will be moving like this. So we call it as tearing failure. So this time the tearing is happening because of this very less gap, that is said to be insufficient gap. And my dear, whenever we are talking about because of the load, like you can see the tearing failure. But my dear, if you are going to have, let us say this is the plate. In this plate we are having 3 holes. And we will be applying the load P like this. You know that this plate is having width of W and thickness of T. Then the tearing stress induced in the body will be force bate. Area is W minus 3 diameter of hole into T. This is the tensile stress induced in the plate. So like I have taken the case of 3 holes, you can have more than 3 holes also. So as a general, you can write sigma T as P divided by W minus NDH into T. And likewise, when you will be going for sigma T less than equals to sigma T permissible, then my dear, you would be getting the tearing strength formula as W minus NDH into T into sigma T permissible. I feel everybody would be remembering this is how we need to find out the formulas. This is said to be the tearing strength of the plate. I already told you we will be directly going with the formulas now, okay, because it is wastage of time if I will be going for derivation. Tearing strength. So you can see for your motivation, Abhinav sir is also there in the comment section at 2 AM, okay. So you can see how Abhinav sir is always coming to motivate you at any time whenever sessions are going on. Sir is coming to motivate you. So you can make heart for sir. At this time, sir would also be happy. Yes. So guys, this is about the tearing failure. And when we are talking about shearing of rivet, so shear strength will be coming out to be, if n number of rivets are there, pi by 4 dr ka square into tau s permissible. There is only one difference. When we are writing shearing strength, this is for rivet material and this is for plate material. Similarly, when you will write the crushing stress, PCR is N into dr into T into sigma CR permissible. This is the crushing strength. So we have seen tensile strength, crushing strength, shear strength, like that. Okay. Here sigma CR is also of the rivet. These two are the failures of rivet. I already taught you the crushing failure in the starting. Shear failure also we have already seen. The PDF of this session you would be getting on Telegram channel for sure. Okay. And just after the session I will share it. N is for number of rivets, Varun. Number of rivets. Okay. Even I would like to say here, I will say this, let us say M. Here M is number of rivets in a row. Because even if you have one more row of the same rivet, the cross section of this and this will remain the same. Okay, but if you are having rivet at 6 slot, then all 6 will be resisting in the shear and crushing. So in the tearing strength, only one row is important. In shearing and crushing, total number of rivets are important. Okay, so this is the total number of rivets. Because every rivet cross section is resisting the force. Is it clear for everyone or not? Please tell me that. If you are going to have the case of double shear, then you need to multiply by 2. But till date there is no question in the gate like that. Okay, so these are the cases when they are asking you. And I am also telling you, whenever we are talking about the efficiency of riveted joint, it is the maximum of PT, PCR, PS by the strength of unriveted plate. Here the strength of unriveted plate is nothing but W into T into sigma T permissible. This is the condition when there is no hole in the plate. This is the condition when there is no hole in the plate. This is the plate. This is W, this is T. No hole in the plate. Then it is W into T into sigma T permissible. Sometimes they are giving you per unit pitch length. For the cases of per unit pitch length, the efficiency of riveted joint is, when we are defining it as PT by PUN. And tearing strength is given per unit pitch length. Like you are having this plate, these are the holes, and we are talking only per unit pitch length. This is the P. Then you would be writing here sigma T permissible. Here it is, what is the material? P minus DH. What is P unriveted? It is P into T, pitch into thickness, into sigma T permissible. And you would be getting the formula for riveted joint as 1 minus DH by P. This is a very famous formula from which already many questions are being asked. Is it clear for everyone? Varun, I did not get what minimum you are asking actually. Okay. Actually, in practical, this is considered to be 1.875. But if GATE exam you are giving, you will consider it 2 only. Okay, 1.875 will be useful on ESC conventional paper. That is from the data book when we are going with machine design. So guys, this is about the efficiency of the joint. Now we are going for the case of reverted joint subjected to eccentric loading. And I am telling you, okay. I have written I feel maximum by mistake. This is minimum, sorry. Minimum? अरे भाई मैक्सिमम ओनली ना. अरे यार क्या कह रहे हो, मैं तो चलो 6 घंटे से पढ़ा रहा हूं, आप तो अभी आए हो. मैक्सिमम ओनली ना. अरे भाई डिजाइन इज ऑलवेज डन फॉर द मैक्सिमम, नॉट फॉर द मिनिमम. ओके. Design is always done for the maximum, not for the minimum. Now my dear, we are coming with the eccentric loading. This is, even if they are giving you the reverted joints or they are giving you the bolted joints. In the gate, bolt and rivet, whenever we are talking about, they are not considered different because they give only one diameter. So my dear, I am giving you, this is one of the case. Likewise, there are many cases possible. So in this marathon, I am going to cover only one case. If you want to have all the types of these, like rivet can be present over a periphery of circle. So if you want to go for all those cases, for that you need to join the practice session which will be there tomorrow or day after tomorrow. Means not tomorrow, today or day after today, because today already started. Okay, so you may be having the practice session either tonight or day after tomorrow. So when you have that session of practice, you come. There I will consider all the types of this. You can say rivet can be present here. Rivet ऐसे हो सकते हैं, periphery of circle पे हो सकते हैं, 2 rivet हो सकते हैं, 3 rivet हो सकते हैं. तो I am taking one case. Okay, you just need to repeat it whatever I am going to do. But still, if you want practice with more number of cases, for that you have to join me in the practice session for that. But here I am giving you one case with everything how to do that. So whenever you are getting this case, how to solve. This is the mostly asked case and this is the most difficult case out of all the cases. So I have considered this. For this, first of all, you can see the load is not passing from the centroid of rivets. If load is not passing from the centroid of the rivet, we call such loading as eccentric loading. That is why this loading is said to be eccentric loading. So this is the load P and this is eccentric loading. So what is the procedure? The first step says find out CG or centroid. So you can see just by looking at the diagram, you will be able to find out the CG or centroid of the rivets. Second step is find out the eccentricity of load. Eccentricity of load is the distance of the centroid from the line of application of load. Third step is go for the equivalent effect. For equivalent effect, you know load is present here. So I want to see the effect of the load at centroid. So I will apply one load in the downward direction, other in the upward direction. This P and this P will be making a couple. So you will see on those 4 rivets, you will find there is a force and a couple. You can see the force is acting parallel to the cross section of rivets. Couple is also acting parallel to the plane of cross section of rivets. So that is why this force P is a direct transverse shear load. And the couple P into E is nothing but a twisting couple. Now my dear, we will be going for the step number 4. In the step number 4, we would be having the effect of P. As the load is acting on the centroid, it will be equally divided into all the 4 rivets. So we will be having the primary forces which are shear in nature will be coming out to be P by N. N is the number of rivets. Here there are 4 rivets, so we will say P by 4. Now my dear, we will be going for the effect of couple. When we are going for the effect of couple, any doubt guys, you can ask me, okay? If you will not ask, I will assume you are getting everything. So as you are getting couple here, I am applying the stresses in the direction of force. In reality, it should be opposite. In reality, I should show the force resistance upward because load is downward. But as I said, it is fine because they are never asking you direction. So you can directly take the direction of load because we are just finding out the magnitude majorly. Direction they are never asking. Okay, so that's why we are taking everything in the direction of load. So you know, whenever we are having the torsion happening, we are always having a habit to make it as radius perpendicular. So these are the secondary force which will be coming on the rivets. These are the secondary forces: Fs1, Fs2, Fs3, Fs4. We already know shear stress is directly proportional to radius. So shear force will be directly proportional to radius as well. So we can write shear force, secondary shear force. This is secondary or shear force. Fs1 can be written as constant times R1. Fs2 can be written as constant times R2. Fs3 can be written as constant times R3. Fs4 can be written as constant times R4. Here R1, R2, R3, R4 are nothing but these distances. First rivet R1, second rivet R2, third rivet R3, fourth rivet R4. This will be given by the geometry. So now you know this P into E is converted into these 4 couples. So we can write P into E as equals to Fs1 R1, Fs2 R2. Ajay, are you getting it or not? Varun, are you getting it or not? I feel all of you are from revision here, so you would be getting. Still, if you have any doubt, you can ask me. Shreyas, are you getting it or not? So my dear, you know Fs1 CR1, Fs2 CR2. So we can also write P into E is C into R1 square plus R2 square plus R3 square plus R4 square. So from here we can find out the value of C. P into E by R1 square plus R2 square plus R3 square plus R4 square. So with that we can find out all the secondary forces. Here primary and secondary both are shear in nature. So that is why if you want to find out the resultant in rivet 1, you can find out with the vector addition formula that primary force ka square plus secondary force ka square plus 2 times of primary secondary cos theta, where what is theta? For that I will show you once again the rivets, the equivalent effect. You know that primary forces are acting downwards like this and secondary forces are acting like this. So the angle between them, this is theta 1, this is theta 2, this is theta 3, this is theta 4. So with that you will be able to finding out R2, R3 and R4. You need to see the maximum of them. And when you will be finding out the maximum of them, just put it pi by 4 dr ka square. That will be the maximum shear stress induced. Keep it less than equals to tau permissible, you would be getting the diameter of rivet. This is the final procedure of such questions. So as I said, this is just a example or sample I have shown you. When you would be coming to the practice session, I will show you all the possibility of location of the rivets. These rivets can be present also like that. These can also be present like that. It can also be provided present like that. So all these possibility we will see in the practice session. Okay, is it clear? But the procedure will remain the same. Everybody understood that? Because those who are revising, they would be getting what I am saying. Okay, is it clear? So this is going to be the same for riveted joint as well and bolted joint as well. There is no difference for that. Okay, so my dear, now if I would be going for, you can see these are the various questions. I would also like to tell you here one thing. You can see that here the angle is going to be smaller for these two rivets, rivet number 2 and 3. So as theta is less than 90, so here cos theta for second and third rivet would be coming out to be positive. And for positive, resultant will be coming more. You will find R2 and R3 will be coming more, R1 and R4 will be coming less. So in other words, you can say that rivet which is near to the load will be having more stress. The rivet which is near to the load will be having more stress. And rivet 1 and 3 will be having less stress. Sometimes they can ask you critically loaded rivet. So critically loaded rivet are those which are near to the load. Okay. So my dear, we will see all these types of questions in the practice session. You can see. Okay, this question I want you to do because this is the formula based question. This question I want you to do, this is formula based question. Solve it. Solve it. They are asking you to avoid tearing failure, find out the value of P. So I am giving you the formula. P will be W minus 3DH into T into sigma T permissible. Solve this question. This is a GATE previous year. Solve it. One more question. Then we will go for bolted and welded joint. So I feel by 3 AM we would be completing. You can see this is given the 200. Width is given 200. Number of rivets you are having 3. Solve it. What you will get? Very good, Vinay. Vinay is saying the answer to be C, that is 167 Newton. Very good. 167 is correct. Because when you will be having width 200 minus 3 into 11, thickness is 5 into 200. Answer will be 167 kilonewton. Very good. Okay. Okay, here can you tell me which one is the critically loaded rivet? Out of these, which rivet is the critically loaded rivet? Out of these, which rivet is the critically loaded rivet? B. Q and R are near to the load. B is the critically loaded rivets. Very good. So guys, now whenever we are talking about the bolted joints, I would like to tell you that whenever we are showing the threads are like that. So when you are making the threads like that, these are said to be the major diameter. This is said to be the minor diameter. Threads are always known by their major diameter. So whenever we are writing these type of thread, they are said to be metric threads. So if I write M12, this 12 is the major diameter, which is denoted by D naught. and this minor diameter is said to be core diameter. So if you have a question in the bolted joint, whatever we have seen in the rivet, the things will remain the same, only one difference. If he gives you the relation between D naught and DC, if he gives you the relation between D naught and DC, you can see this is the smaller diameter. So failure will be happening from here. Like let us say in the previous question, whatever we have done with the eccentric loading, let us say that is given for the bolted joints. Then you would be writing R max. Previously you were writing pi by 4 dr ka square. Here you will be saying dc ka square. That is equals to tau max. And you will say that is less than equals to tau permissible. Now from here you would be getting the value of dc. Once you get dc, then my dear, that d naught and dc relation, let us say it is given to us, it is 0.84 times. Then you can find out the d naught value. Okay, because threads are known by the outer diameters. Is it clear for everyone? Please tell me that. Clear for everyone? Please tell me that. Clear for everyone? Please tell me that. That is the only difference. Okay. So my dear, that is the only difference for the bolt. And whenever we are talking about nut and bolt connection, you are having a plate like this. So what you are doing? You are making the hole. In the hole, you are going to put the bolt like this. So bolt is having like this, and you are going to have this. Okay, and in between sometime we need to put a washer for the uniform pressure. So this is nut, this is washer, this is bolt. Clear for everyone, guys? Clear for everyone, guys? Now my dear, eccentric loading is going to be the same as whatever we have discussed. Only one thing I would like to tell you here is that eccentric loading, all these things are the same, whatever we have seen. Okay, only one thing I would like to tell you here is not eccentric loading, that is basically elastic analysis. Sometime you may be given like a plate like this. There is another plate like this. And these two plates are connected, in between there is a hole. And in this hole you are going to put a bolt. You can see there is threaded and unthreaded part. Then my dear, I would like to tell you that this part, we can also consider them as the spring. So we can consider them as the spring. Then you can say this is unthreaded part, this is threaded part. So if this is the stiffness of unthreaded part, this is the stiffness of threaded part. These two springs are joined in series, so the equivalent stiffness can be written as K of unthreaded plus K of threaded. When you are talking about K of unthreaded, it is, we know that how it is defined. It is A by L. So A by L, this is of unthreaded part. Similarly, KT is A by L of threaded part. So this is how you can find out the equivalent stiffness. This is said to be elastic analysis of bolt. Is it clear? It is said to be elastic analysis of bolt. Clear for everyone? Everybody remember? अरे भाई रिवीजन के लिए याद आ रही है सारी बातें, ऑल दीज थिंग्स वी हैव डन. इसेंट्रिक लोडिंग की टाइप्स जैसा मैंने आपको बोला वो सारे हम क्वेश्चन से ही देख सकते हैं. तो दैट वी विल डू इन द प्रैक्टिस सेशन. रेस्ट आई हैव कवर्ड एवरीथिंग व्हाटएवर आई टॉट यू. नाउ द लास्ट थिंग आई एम कमिंग ऑन टू इज द बोल्ट ऑफ यूनिफॉर्म स्ट्रेंथ. द लास्ट थिंग वी आर गोइंग टू डिस्कस हियर इज द बोल्ट ऑफ यूनिफॉर्म स्ट्रेंथ. देन वी विल गो टू द वेल्डेड जॉइंट. बोल्ट ऑफ यूनिफॉर्म स्ट्रेंथ. So my dear, you know that whenever we are making a bolt, bolt looks like this. Bolt is looking like this. So we know that if we are talking about here, the diameter is D, here the diameter is DC. So when we are talking about this bolt, we are also showing it in this way, like this. So when we are talking about the strength of this part, it is pi by 4 d square into sigma permissible. The strength of this part is pi by 4 dc square into sigma permissible. You know d is more than dc. So upper part is having more strength, lower part is having upper part is having more strength, lower is having lesser strength. If you want to make a bolt of uniform strength, what you need to do? Either increase the strength of this part or decrease the strength of this part. If you want to decrease the strength of the upper part, then you would be drilling a hole into that. And let us say I am going to drill a hole of dh into that. Then this will become pi by 4 d square minus dh square into sigma permissible. And you are saying that is going to be equals to pi by 4 dc ka square into sigma permissible. So from here you can definitely find out what is the diameter of hole to be drilled. So dh square is coming out to be square root of, dh is coming out to be square root of d square minus dc square. So if you know the relation between d and dc, you can find out how much diameter of hole to be drilled to get the bolt of uniform strength. And if you want to go for the second way, by making this part stronger, you will be going with the external threads. Second way is to go with the external threads. Threads will be made like this. In that case, your DC will become equals to D. So this is the second way to get the bolt of uniform strength. Just we are finishing. I told you that before 3 AM I will leave you. Just be there with 15-20 minutes. We are about to complete. Bolted joint is over. We are moving to the welded joints now. So for the welded joint, you already know the welded joints are said to be the strongest joint in this universe. When we are talking about the strongest, they are having the efficiency of 90% or plus, maybe 100% or more than that. So when we are talking about the welded joints are going to be classified into two categories. First of all, one category is the butt joint. Other category is the fillet. When we are talking about the fillet joint can be parallel fillet. Guys, आपको ऐसा तो नहीं लग रहा कि मैं उड़ा रहा हूँ चीजें? Because questions वाला part हम questions में ही देखेंगे. अगर मैं questions में, if I will be doing questions here also, then it will not be over by 5 AM also. So we are going to revise the concepts only now, okay? Because we are about to complete. All important topics we have seen very nicely. This is transverse fillet. Everybody is happy with this now? Transverse fillet. Practice session will also help you a lot. Then it is combined fillet. So we are going to have this parallel fillet, transverse fillet, combined fillet. Then we are going to have butt joint. Here we are going to see the formulas, okay? So parallel fillet, transverse fillet, combined fillet. Fillet welds are found to be weak in shear. They are found to be weak in shear. And when we are talking about butt, they are found to be weak in tension. First of all, you need to see what is parallel fillet, what is transverse fillet. So if we are going to have one plate like this, other plate like this, if the forces are acting like this, and the weld is present like this or like this, we call it as parallel fillet, because load is parallel to weld. If you are going to have it in this way, this is said to be the transverse fillet. And if you are going to have like this, this is combined fillet. Okay, and butt joint is very simple. This is butt joint. So my dear, whenever we are talking about the parallel fillet, going on to this. So whenever we are going for the parallel fillet, then my dear, if you see the weld, like this is the weld. Weld is generally considered as a triangle. So if you consider the triangle like this, it is found that this is the minimum thickness. Here thickness is T, here thickness is T. They are said to be the leg of weld. And here we are going to get thickness as 0.707 times of T. So when it is 0.707 times of T, this is the minimum thickness. And here only the failure is going to happen. So when we are going to write down the force or the strength of the parallel fillet joint, it is coming out to be 0.707 TL into tau permissible. Why tau? Because they are weak in shear. Similarly, when you are going to write for the transverse fillet, it is coming out to be 0.824, 0.808, sorry, 0.824. 0.824 TL into tau permissible. But the point is, to make it uniform, we are never consider 0.824. Here also we will write 0.707. So the same formula we are going to use. If in the question they are not giving you tau permissible, they are giving you sigma permissible, then you can replace tau permissible by sigma permissible also. Okay, so this is the strength of transverse fillet and parallel fillet. Now my dear, we are going to have butt weld. So when we are talking about the butt weld, and whenever we are going to write the parallel fillet or transverse fillet, like I have written 0.707 TL into tau permissible. Here L is the complete length of the weld. Complete length. Like in this case, this is L, this is L, this is L. Entire total length you will be counting. Okay. So my dear, when we are talking about the butt weld, butt weld is going to be like this. Here you know this is thickness T. And if you are going to have the plate to be like this, W is the width. You know here the forces are acting like this and they are weak in tension. Tension will be coming on to this area. This is width, this is thickness. So you would be writing the strength of butt joint as W into T into sigma permissible. They are weak in tension, so sigma permissible. Sometimes they can be giving you the, like this is the weld, na? This is the weld. Sometimes they can give you the undercut. They may say you this much is the undercut. In that case, you would be writing F butt is W minus undercut into T into sigma permissible. Sometimes they give you one plate is bigger, other plate is smaller. This is T1, this is T2. In that case, you would be going with the minimum thickness. Then F butt will be W into T2 into sigma permissible. Is it clear for everyone or not? Please tell me that. Is it clear? Everybody remember, all these are just derived in the classes. Here I am not going for the derivation, just this is the difference. Okay. And you are also having one more case if you remember. When you are having this, here when welded joints are joined like this with this plate. If it is subjected with the T torque, then if you remember, we are going to have it 2.83 M divided by pi d cube T. This is the formula for the maximum shear stress. Everybody remember that? And if it is subjected to the bending moment M, Because of that, you would be having 5.46. It is 2.83 or 73? 5.63 m by pi d cube t. This is sigma b maximum. Everybody remember this? आ गया सभी को याद? It is similar to like we are writing sigma b as 32 m by pi d cube. It is similar to that. And tau s we write it as 16 t by pi d cube. Okay. I have मुझे भी अब यार रात हो गई ना तो नींद आ गई है. Yes, it is. I am correcting. बहुत लेट आया आपको भी ध्यान. This is t minus u into w. Yes, Vinay, it is correct. Clear है भाई? Okay, fine. So now just we are concluding, don't worry. Last formula for the gears we are writing, then we will complete it. So when we are talking about the gears, for gears there are two areas from where questions are coming. Number one is the force analysis. So if you are having a gear like this, in the theory of machines I already told you that on the gears there are two forces coming. One is the radial force, other is the tangential force. And my dear, when two forces are coming, I also told you the net force which is coming. The net force which is coming is the resultant of them. Like that. And this is making an angle of phi. That's why you were saying Ft is F net cos phi. You know that generally power will be known to us. Power is torque into omega. From here torque will be known to us. Torque is Ft into R. So we can write Ft as torque bate R. So the point is we are knowing the Ft force. We are not knowing any other force. Ft is given to us in the form of power. So when we know the Ft, you know module is d by z, which can be written as 2r by z. From here r is mz by 2. So you can write Ft as t 2t by mz. And if Ft is 2t by mz, what is F net? F net is Ft by cos phi. And what is Fr? Fr is F net sin phi. F net is nothing but Ft by cos phi. From this formula, whatever I am writing here or deriving here, at least 7 to 8 questions have already been asked. Am I correct or not? Am I correct or not? Please tell me that. Yes. And my dear, now the last from the gears is the Lewis equation. For that you must be knowing the formula, service factor, velocity factor, then Ft, that is less than equals to B M Y sigma B permissible. This is the Lewis equation. Here the S into service factor is always more than, okay, S is more than equals to 1, service factor will also be more than equals to 1. If it is given less than 1, take opposite of that. And this is Ft, you know that 2t by mz. B is the face width of the gear. M is the module of the gear. Y is the Lewis form factor. और टूथ ज्योमेट्री फैक्टर. Sigma be permissible is the permissible stresses. Clear for everyone? Clear for everyone? Yes. Everybody. यही आता है गियर्स में, ठीक है, बस इसका डेरिवेशन नहीं कर रहे हम. ओके. Now my dear, one last thing is the design of shaft. For shaft there are two things. One is the equivalent torque, m square plus t square. This is the case when we have a shaft subjected to a bending moment and twisting moment together. When we are going to have the equivalent bending moment, it is nothing but 1 by 2 m plus m square plus t square. This is the formula for shaft, because we already have discussed solid hollow shaft, who is better, in the torsion chapter in SOM. So this is for the shaft. Is it clear for everyone? And when we are talking about the springs, I feel everybody would be knowing that maximum stress is coming out to be Kw 8 Pd by pi d cube. Yes, याद है सभी को मैक्सिमम शियर स्ट्रेस. डोंट वरी, स्प्रिंग के फॉर्मूला मैं अभी नहीं दे रहा हूं. स्प्रिंग के फॉर्मूला हम क्वेश्चंस के साथ देखेंगे, ठीक है. इज इट क्लियर फॉर एवरीवन? क्योंकि अभी मुझे लग रहा है कि और मैं खड़ा रहा तो गिर ना जाऊं. Is it clear guys? आया सभी को समझ? I can understand you guys also are there with me from last 6 hours. वो बात अलग है, आप बैठे हुए हो, मैं खड़ा हुआ हूं, ठीक है. So, but guys, I feel we have tried to go in a decent manner, and this is how the marathon means for me. Marathon means we need to just revise the things in a manner that we can just have a look over each and every formula. So guys, now whenever we are talking about the practice session, we will try to keep the practice session in next upcoming days. I will share that on my Telegram channel. This PDF of machine design also I will be sharing on my Telegram channel. Be ready for that as well. Okay. So, sir, when will be having remaining tome? Dear, I would be taking that either on Tuesday or Wednesday. Because tomorrow already Suraj Gopi sir is taking the industrial engineering. So most probably Tuesday or Wednesday we will plan it. Okay. So that I will inform you, don't worry about that. But whatever marathons of technical subjects will be completing by the Sunday. Because from 22nd onward maths aptitude will be starting. So we are leaving here. Thanks for your love and support guys. You are there with me till the last. For spring, I will give you the formula. I have given one formula that is correct only. But rest formula we will be having. Ajay, actually one marathon is not going to be there. That I will tell you. In that place we will manage. Otherwise, Sunday is also reserved for us. Next Sunday. Okay. कल की क्लास टाइमिंग क्या रहेगी? प्रैक्टिस सेशन की तो रात में ही रखेंगे, क्योंकि मेरी क्लास रहेगी एटलीस्ट 10-11 बजे तक, तो रात में ही रखेंगे, ठीक है, रात में ही रखते हैं. ओके. तो आप मेरे टेलीग्राम पे जुड़े रहो, वहां पर मैं शेयर कर दूंगा प्रैक्टिस सेशन, ठीक है. इज इट क्लियर? प्रैक्टिस सेशन की लिंक आई विल शेयर देयर ओनली. Okay, so goodbye guys for this session and good morning. Sorry, good night. Goodbye. Wonderful guys.